Hello grade 12s, welcome to my channel. Let us discuss differential calculus. So this was by request. I hope Lesejo is watching, and I hope and believe that I probably would have hit all the areas you needed. Otherwise, for all the other grade 12s who are part of this channel, please learn as best as you can, and hopefully this course helps you as well. So what do we talk about when we refer to differential calculus? Well, folks, it's all about differentiation. So this is when we differentiate algebraic expressions or functions for that matter. Okay, so we differentiate expressions. You can just say expressions, or let's just say algebraic expressions, right? And perhaps functions. Right. So that's essentially what we're going to be doing here. And this technique is very useful for sketching a cubic function and to interpret, a cubic function. But we're going to get to that later. So let's start by this. So folks, we know that essentially, what's the deal about straight lines? Let's talk about straight lines. In general, we know that the gradient of a straight line is constant, right? Okay, it is constant. That's the key. And based on the gradient, we may say the function is increasing, or we can say the function is decreasing depending on the gradient. Okay, so the function may be increasing or decreasing depending on the nature of its gradient. Of course, we say increasing when the gradient m is greater than 0, and we say it's decreasing when the gradient m is less than 0. So let's be clear that the small letter m here stands for the gradient. Okay, so let's just have a look on the Cartesian plane. What can we observe? Take that we've got this equation with that point and perhaps this point. So we've got point A where we have, say, -3 and -1. And we've got point B where we've got 2 and 4. Okay, I'm just guessing. Maybe this is good, maybe it's bad, I don't know. So we will see. So this is the origin. We've got the x-axis and the y-axis. Right, so let's talk about what would be the gradient between AB. It's going to be y at B minus y at A divided by x at B minus x at A. Right, so this is 4 minus -1, which is going to be +1, divided by 2 minus -3. So we get ourselves a very nice gradient of 1. Okay, it worked. although I didn't see it coming. So folks, we know that when we look for the gradient between any 2 points, it is going to be essentially a constant gradient. Now folks, say as we keep going, I ask you that this is point C. Maybe let's make it ahead, because we've already named these points already, so let's do it somewhere else. Let's say at the end of this line, I have C. Now, the question would be, what is the gradient at C? Ever thought of such a question? Now we've got a gradient between 2 points, but now we know for a straight line the gradient is a constant. So this means the gradient at any point is going to be the same. So the quick answer would be gradient at C is going to be equal to 1. Nothing changes. So for a straight line, the gradient at any point is going to be the same as the gradient between any 2 points. Okay, so that's just the idea. And take note that we call those points N, B. We know that A, B, and C are collinear points. Okay, so this is very important also to note that. Remember, mathematical language, guys, is very important. So this is what we know. That when we look for the gradient between any 2 points, this is what we do. We take the y value at the top, we subtract the y value at the bottom. Now say that this, let's just say this graph represents the function f of x. Okay, let's just say f. This graph represents the function f. Just want to write better, Okay, so this is the function f on the Cartesian plane. So if you look at this equation here, this is literally suggesting that we could easily write this gradient between a and b is the same as the function where it's the x at b minus the function for the x value at a, all divided by the x value at b minus the x value at a. So these are some of the things that one can look at. So, okay, in terms of function notation, this is essentially how a gradient is calculated if we have a function f on the Cartesian plane. I hope this is clear, guys, because we are not going to sit on this much longer. Now let's get to the second issue here that can take us where we need to go. So say we've got a parabola this time. So we've got a function f of x is equal to ax squared plus bx plus c. We're just going to use the standard parabola where we know that a is greater than 0, for example. Right. So, and has real roots. Okay, so this is just a typical quadratic function. Let's look at it on the Cartesian plane. That's the origin. So let's look at our parabola. Right, so this is our function f. Now, we've got a situation, okay? We've got a situation now. If you look, I could call this point B, and I could call this point A, right? So let's just gauge, what should this be? Okay, let me just do it nicely. Okay, my graph doesn't look right. Anyway, guys, it doesn't have to be excellent. At this point, we just want to get some thought going. So we can say this is roughly, let's say, well, let's just call it 1, right? And we could call the corresponding value there the corresponding value, we could call it, say, -2. And we will do the same there for B, right? Just trying to show you some things, folks. It's very important to really focus on this, to then understand what this is all about. So this is 2, and this is 2. Okay, no problem. If you want, you may write the coordinates at B as such. So that's not a big deal. So we've got our parabola f that has real roots with a greater than 0, and we see what we see. Now, if we were to determine the average gradient, or rather the gradient between these 2 points, because now this gradient, remember this line is the line that we call a secant, isn't it? Let's get this f out of here. So this line is the line called a secant, right? Because a secant is a straight line that cuts a curve at 2 points. Right, so it's a secant. Why? Because it's a straight line that cuts a curve at 2 points. Right, remember that, the definition of the term. So we've got our secant through points B and A. Now, if we were to calculate the gradient between those 2 points, since this is a curve, we know that every other point, the gradient changes. So if we calculate a gradient between any 2 points on a curve, what does this give us? It gives us what we call an average gradient. So the gradient of a secant is what we call an average gradient. So we will know that the gradient of a secant, just going to say m sec, is the same as the average gradient of the curve. Between between 2 points. So notice I said the gradient of a secant is also called the average gradient of the curve. the gradient of a secant is essentially the average gradient of the curve between 2 points. I hope this is very clear, guys. It has to be between 2 points. So this is what we have. Now let's have a look. How would we calculate the gradient here? Same story. We would then say, well, the average gradient between A and B. So we're going to say M average between A and B is still going to be the y at B minus y at A divided by x at B minus x at A, in which case we're going to have 2 minus 2 is going to be plus 2 divided by 2 minus 2 is going to be 2 minus 1, excuse me. Okay, so this is going to be 4. Nice and easy. So basically, this is the gradient of the secant, but for the curve, for the curve f, we call it an average gradient. But for the straight line, which is the secant, it is just the gradient because it's constant. So that's just the idea of how things are cooking here, guys. But I need you to realize something here. Just look at this situation right here. Okay, I'm gonna take that one out. So this is 2. Now just look at this situation, guys. Do you realize point A and B are a distance apart, a distance of 1 unit? Apart. So this means the second point is some distance from the first point. So please, this becomes very important in this topic, that we sometimes look at the relationship of those 2 points on the horizontal axis. What is the distance between those 2 points? All right. So that's very important. And of course, we said this could be written as the gradient between A and B as the function where x is that of B minus the function at x in A divided by x at B minus x at A. But notice something again. What is this? This is the distance between A and B. This is the horizontal distance between A and B. Let's put it clearly. All right, so this is the horizontal distance between A and B. I hope these things, guys, are starting to make some sense, because you surely have been taught all of these things. So every time we do this gradient business, you will notice that at the denominator, this is the distance between A and B. The horizontal Okay, please notice these things. So we are happy. So this means this distance is non-zero, essentially. So usually we're dealing with a non-zero distance. Again, I want you to notice that this distance is non-zero. Now this is very important to keep in mind. So it is non-zero, okay? Keep that in mind, that this horizontal distance between A and B has a value, or it has some unit. Okay, so this is very important. So we are good. I hope we understand everything. But now, this could bring us to a very interesting question. What would be the answer to this question? What is the gradient at B? Let's just say, be clear, what is the gradient of F? What is the gradient of F at B? Now that's a very interesting question. An answer which is interesting. The answer is, whoopsie, we really don't know, hey? We really don't know. So how would we find out? Perhaps because now we saw that for a straight line we were happy. We were very happy. You could easily be silly and say the gradient at B, but remember that would be the second. Maybe let's call the second G. Let's give it a different name so that there is no confusion, because students would jump and say, well, that is on a straight line, so the gradient should be 4. No, it's not 4. Because this is the second G. The second G. Now we said F. So we know for sure that the gradient at B is certainly not equal to 4 for F. But the gradient at B is equal to 4 for G. That is very important. Separate the issues. So we know that indeed for the function f, it's not 4. But for the function g, which is the second function, it is certainly going to be 4 because that's on the straight line. But now we're interested in f. How could we find a gradient at a point for a specific function? Now remember, what does this mean? We can use these 2 points as a means to an end and say, okay, we know that these points have a non-zero distance between them. But what happens when we move the first point as close as possible to the first point? Then what do we see? All right, now we're going to get to answering this question right here. We're going to answer this question nice and easy. So bear that in mind, and then we're going to answer this. Now let's go and start working. Now let's say we've got a function on the Cartesian plane. Okay, I'm going to make it an exponential function. It's not a big deal. We just do the things that we're supposed to do. So say we've got this function. Right. So we've got a nice exponential, but I want it to curve a bit more. Right. So we've got our function f, an exponential. Right? So we know that an exponential that is not shifted about will cut at 1, at least on the y-axis. Right. Now let's say we've got a point. Let's look at... this one didn't come out the way I want. But anyway, let's look at a point A. Right, we've got point A. Right, and let's look at point B. So we've got those 2 points. And we want to focus on a tangent. Remember, we know about tangents, right? Tangent is a graph, or it's a straight line that cuts, or at least touches a curve at just one point. So the tangent, this is the tangent line. So you know about tangents, right? What is a tangent? This is a straight line that touches a curve at only one point. Okay, so it's a straight line that touches a curve at only one point. Now we can call this tangent, say, G, since our function is f. Now we've got a second line which joins A to B. Right. So there's a lot of stuff happening now. So we've got a second. We can call it H. Maybe let's not call it H. Let's call it K. Okay, and we know what a second is. It is a straight line that cuts a curve at 2 points. Okay, don't forget. Right, so we've got these two. Now we want to relate these two. Look at a tangent. A tangent will give us a gradient at a point because it is also a straight line. So we know that the gradient of a straight line should be the same. All right? And no matter what point we're looking at, we should get more or less the same. So what happens now when we have these 2 points? Now I want to drop them down nicely. Let's do this. Actually, I wanted some straight line that I can steal. Yeah. I want to steal it. So we can see, guys, this is the x at A. And then this is the x at B. And these 2 points are some distance apart. We call this distance h. Now h is the horizontal distance between the 2 x coordinates, right? So h is that non-zero distance between the 2 points. So it's the horizontal distance between the 2 points. I'm going to put it points A and B. Okay, so nothing has changed. We still have that. But now we decide to move point B very close to essentially, okay, let's hold on. Let's hold on. We're moving too fast. Right, now, folks, how would we essentially sort ourselves up here? Now let's do something. Let's do something. We now decide to move the point B as close as possible to A, so that there's almost no distance between them. Now, do you realize when we move those like that, what would be the gradient of our second? This is the line that will join the 2 points. So do you see that? Literally, when those points are so close together, I'm going to just protrude it a bit. So do you see that this line, if I may cut it, okay, let's just draw this one here. So when those points have been brought so close together that the distance between them is as good as non-existent. So this is what we mean. We're bringing these two so close together such that the distance between A and B, you know, we can even call it B prime or something, whatever you want to call it. Let's just call this point now B prime or whatever. This is point B. Can do 10 B1 now, but snacks go. So that is point B. Now remember, point B is a variable point. We are varying its position in relation to A. So first, they were a distance apart, but now we're bringing B as close as possible to A. But now we notice that this is still the second. This is the second K. You can say K1 if you want, and say this is the second K2. The second, let's just leave it as the second K. Again, seeing that these two are variable. Now look at this. What was the gradient of the second in the first place? So we know that the gradient of the second was going to be between the points A, B, which is going to be f x at B minus f x at A, all divided by x at B minus x at A, where the denominator is non-zero. Okay? The denominator is non-zero. But now look at what is happening here. What is happening to this gradient of the second? We know that the gradient of AB is as good as the gradient of a tangent. Because can you see these ones are almost lying on top of each other. So technically this means if we move B a little bit closer again, this would essentially give us the gradient of a tangent. So we know that the gradient of AB is, between A and B in the second instance, is as good as the gradient of the tangent. Right? Right. And what does this look like? It's going to be the function of x at B minus the function at x in A divided by the distance between the two. xb minus x what is h, right? But now what have we done with this h? This is when we limit this as h tends to 0, because remember we initially had a distance that we could calculate, but this time around the distance is so close that it's as close to 0 as possible. So once we have this, we know that the gradient of a tangent is as good as the limit of any function when the distance between the two is as close to 0 as possible. We just say it tends to 0 or it approaches 0. We are not saying it's equal to 0. Okay, right. But of course, when we want the distance, the gradient at a point, it means there is no distance. It's as good as 0. But then with the strategy, we can get around. So this is how we came up with this formula of the first principles, guys. So what we ended up saying, we said from here, you can say therefore, the gradient of any function at a specific point is going to be such that the gradient m is going to be equal to the limit as h tends to 0 of the function when x adds h, meaning the second point, minus the first point, all divided by h. We know h is the horizontal distance between the two functions. So for example, if we decided to say the x value at a is just x, the second value is going to be x plus h. Okay, I hope you understand. So this is as good as the x at b, and this is as good as the x at a. So I'm just going to write them here. Just remember that this is b, this is x at b, this is x at a. Now we're just talking in general when we don't specify. So according to our points here, it was this guy versus this guy. All right, so that's essentially what we did. So we took the gradient of a secant and made it the gradient of a tangent. And we saw that the only difference is that gradient of a secant and that of a tangent. The tangent 1 is still the same as the gradient of the secant, but when the horizontal distance of the two x values or the 2 points is as close to 0 as possible, or essentially 0. Okay. So this we called Sir Isaac Newton's quotient, and we call this the definition of a derivative. So this is the derivative. So this is so-called Sir Isaac. Is it Isaac? Isaac Newton's quotient. Right? A quotient is that gradient. Gradient, of course. So see this is Sir Isaac Newton's quotient, and we call this the definition. This is the definition of a derivative. Okay, this is the definition of the derivative, and we call this the first principles. I hope this is clear, guys. This was just for demonstration purposes. As you can see, you can appreciate what happens when we move B all the way down. You can appreciate that when we moved B from there to there. I don't know, guys, if you can follow. So we moved B from there to a new position, and this gave us the gradient at a point, which is exactly what we want. And so came up the so-called f prime x, meaning at any x value, this is going to be the limit as h tends to 0 of x plus h, the second point, when actually that point does not really exist per se. Okay, so you have it, guys. So this is the formula we are going to come across every chance we write our maths paper 1. Okay, guys, that was a lot. I don't know, I'm too slow. I should have finished this in 20 minutes, but speed kills, isn't it? Speed kills. So let's recap, guys, because I know it's easy to lose students. So basically, differential calculus, folks, is all about differentiation. We can either do this to an algebraic expression or a function or any derivative that can be modeled either as a function or an algebraic expression. Now, if we just take a back seat, straight lines, which you've been studying since grade 9 or so, we know that the gradient of a straight line is constant. It never changes. And of course, it may be positive, in which case we say the function is increasing. It may be negative, in which case the function may be decreasing. Right, and we demonstrated this by choosing some function f on a Cartesian plane with these 2 points. How do we find the gradient? Well, we say y ahead minus y before divided by x ahead minus x before. And that gave us the gradient. Because we call this the rise over run. Okay? The rise, isn't it? The rise over run. Rise over run. Or is it run over rise? No, it's the rise, meaning from A to B, vertical distance, over the horizontal distance between them. So it's a rise over run. I hope that is clear. Rise over run. Right, so that's the story. Now, that was good. So this, if we looked at it in function notation, we could say it's f of x at b minus f of x at a divided by x at b minus a. And we said this x at b minus a is nothing but the horizontal distance between a and b, and it's normally non-zero. Otherwise, this would not exist. It would be undefined. Okay, cool. Now it says, what is the gradient at point C? Now, point C is a collinear point because it also falls on this line. So we know that the gradient is a constant. So basically, the gradient at point C is going to be 1. Again, we said these are collinear points, right? We then said, fine, how about a curve this time around? So we took a quadratic. So fine, we've got a standard quadratic equation with a greater than 0, and the function has real roots. Excuse me, so I got lost. Now, we know that the real roots, it means it cuts the x-axis, basically. It has x-intercepts, that's what I mean. Now we looked at 2 points again, point A and point B, and we drew a second line, which is the line that cuts the curve at 2 points. And we said the gradient of a secant, it's a straight line, so it's going to be constant, fine. But this is synonymous, if not exactly the same thing, as the average gradient of the curve between 2 points, because this is not truly the gradient of the curve at any particular point. Remember, a curve keeps changing gradients every point. Okay. Again, we still see that, well, there's this distance between A and B. It is there. They are 1 unit apart, so it's non-zero. Then we went again and said, look, if we're looking for the average gradient for the curve f between A and B, it's going to be as we know how. We call it an average gradient because it is the gradient of a secant between those 2 points. Right, or through those 2 points, let me put it that way. But now if we were to write this in function notation again, we would do it that way. Bear in mind that distance is non-zero. But now if you were asked a question, what is the gradient of f at point B? Right? Right. So now this is a nice question. So the gradient is not very easy to determine, and it's certainly not 4. because this is the gradient of a second. Yes, for the second line, it would be 4. But for the function f, it would not be 4. So how do we do that? We went and played and said, fine, let's move the point B for any function on the Cartesian plane as close as possible to the first point. Now, when that distance is almost as good as 0, we saw that when we draw the tangent line versus the new second line, they almost have the same gradient. So we saw that we could make this conclusion that, look, the gradient between A and B, the second line, is as good as the gradient of a tangent when this distance between them, h, is closer to 0. And we then said, fine, the gradient of any function at a specific point is going to be the limit as the distance between the 2 points is as close as possible to 0, where we can look at those points pretty much as the same thing, because if you say 0, it means there's almost nothing happening there. Right, we called this Sir Isaac Newton's quotient, which is the definition of a derivative, and we often refer to this as first principles. And now this graph here, this equation gives us the gradient at any point. The gradient of any function at any point, right? And this is essentially equal to the gradient of a tangent. At any point. Right. Good. So we know two things, that this first principles business gives us the gradient of a tangent at any point on a curve, or we could easily refer to this as the gradient of the function at any point. Maybe let's not say any function, but gradient of a function at any point. All right, so this is essentially the basis of differential calculus, guys. We differentiate and we use this rule, the first principles. Okay, so this is fun. This is fun. Now let's go and answer that question above. How do we answer this question now? So obviously, f prime of x, which is going to be the f prime of x at c, is going to be equal to the limit as h tends to 0 of f of x plus h okay, let's do this. It's f of x at c plus h minus f of x at c, all divided by h. So that's what we would do there. And if we continue, this is going to be the limit as h tends to 0 of f of, now folks, where is my c? Did I say c at b? Yes. Ke a senya jwale, ke ngola ntho tse le c. Hai Sesotho sa ka le sona se tlo nhlantsha e re ke se tlohele. What was x at b there? 2. Okay, right, so this is what we would do. Of course, we would try to do some gymnastics here to eliminate the h in the denominator before we substitute. But this would essentially give us a direction. But since we don't have the function, we are not at liberty to then go and calculate the gradient. Okay, so we will leave it there. All right, okay, all right. Maybe we could even say further, if f of x is, maybe let's put it that way and say if f of x is, excuse me, but this one is not going to work. Hey, let's not do it. All right, guys, so yeah, I'm feeling the heat. I have a lot to unpack, but it's not good. It's not wise to do this. Okay, folks. So this is the end of our notes. Please read your textbooks. Make sure you understand the issue of the limit. I'm not going to discuss that at this point. Understand, what do we mean when we talk about the limit? So my students who attend my classes know exactly what the limit is, because when I introduced them to this topic, we spoke about these limits and what exactly they are doing. Unfortunately for you who don't attend my classes, you will have to go and find out somewhere what the limit is all about and what exactly is the sense behind it, because it's an important idea or concept that gives us differential calculus. Without it, we would not have moved at all in any direction trying to find the gradient at a point. Okay, so folks, now let's take a few examples where we can differentiate. Okay, so let's see. Example 1. Okay, so example 1, we are going to be told to find f prime of x if f of x is x. Let's just say x plus 2. Right, so by using the definition of a derivative. Right, so our answer is f prime of x is the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, let's get to business, guys. So this is the limit as h tends to 0. Now f of x is this x. Where we see x, we put h plus 2 minus the entire function f, all divided by h. Please write the limit as often as you need to. So this is as good as x plus h plus 2 minus x minus 2, all divided by h. Now metrics take place. Now if you're doing right, you will see these things happen. If this doesn't happen, it means something is not correct. So this is the limit as h approaches 0 for hey, yeah, when? Why is this doing this now? Hi. I didn't choose a very bad example now because wow, okay, I did not, guys. Sometimes you panic for no reason. So this is nothing but h over h. So obviously, guys, what happens here? This is the limit as h tends to 0 of 1. Now a limit of 1 is just 1, isn't it? Yeah, boo. And wasn't it true? We knew that the gradient of this function was the coefficient of x, an invisible one. So can you see? This thing is true. So it means this formula is very true indeed, because it gave us exactly the gradient that we expected. So I chose this example deliberately, but then I got lost because of panicking. Of course, guys, write, don't be lazy. In maths, you can't be a lazy bugger. Just learn to write complete statements. This is English, isn't it? This is English in numbers or in some equation form or so. Right. So this revealed that we actually could find that gradient by using this formula. And we know what it is to begin with. And we just played with this to prove if it indeed gives us the truth. And it did. It did give us the truth. Okay. That's the first example, guys. So you may want to write some notes. I will leave that page for you guys to do that. Now let's take a second example, which may be a bit crazy. So let's see. Example 2. I'm not going to do a lot of examples here, but we're going to solve problems from past exam question papers. Again, determine the expression for the gradient of a tangent to f of x is equal to x squared minus 2x plus 1 by using the first principles. Nice. So determine the expression for the gradient of a tangent to f of x equals to x squared minus 2x plus 1 by using the first principle. So you see, we're spicing up how we ask this question, although it's really fairly easy to do it. So let's see, we know that f prime of x has been and I was even writing better. You know, that position provided me a chance to write in a legible way. This is going to be the limit of f of x plus h minus f of x divided by h. So always write the formula. This is key. In maths, we want to see the formula before substitutions. So this is the limit as h tends to 0 of f of x. Now where we see x, we're going to put x plus h squared minus 2. Where we see x, we're going to put x plus h, then plus the constant minus the entire function, which is x squared minus 2x plus 1. All of that is divided by h. Okay, so we're getting somewhere. So this is going to be the limit. As h tends to 0, we FOIL what we see there. So this is going to be x squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x minus 1. All divided by h. Now, folks, there has to be some confidence in handling algebraic expressions, but don't lose focus. It's very important. See, the magics are taking place. If the magics don't take place, remember, it's already highlighting that something is wrong. So the key is to say all f of x must be eliminated if you are doing okay. If it doesn't happen, then you are not doing well. All right, so let's continue. So this is going to give us the limit as h tends to 0 of 2xh plus x squared minus 2h all divided by h. Now we can see h is the highest common factor here. So this is good. Now folks, in maths you can either do this fast and furious, or you can do this, but let me not teach you bad habits. Let's just go through the process. The limit as h tends to 0. Actually, I have shorthand techniques to do this, but anyway, we factorize. So we're going to have 2x plus h minus 2 all divided by h. Now this takes place. We always need to do that. If we did not do it, we are not getting anywhere. So this is the limit as h tends to 0 of 2x plus h minus 2. Please don't rush. Be systematic. Now we drop the limit. Where you see h, you put 0. Okay, so what do we get? 2x minus 2. So this tells us that our first derivative expression should be 2x minus 2. Okay, so what does this tell us, guys? If we differentiate a quadratic, what do we get? We get a straight line equation. And that straight line equation models the gradient of the gradient at any point on that graph. And this would also be the gradient of a tangent at any point. Right, so this is as good as it gets. As I said, don't be lazy. Be someone who is diligent. It takes a lot of, diligence to do this. But do it. Now, in the exam, normally you would get around 5 marks for this business. Let me show you where the marks are. We normally give a mark for substitution into a formula we can see, right? Right. Secondly, remember, we want to be sure that even if your formula is work, we may sometimes give you a mark for substitutions because you substituted into some formula. But the key is that this has to be correct according to the formula that you write. So if you wrote the correct formula, like you see here, if this formula is correct and you do correct substitutions as we have, you get a mark for this. All right? Now for all the troubles of simplification, all of those things, you may get a mark for this too, right? The third mark is essentially, getting that. And the fourth mark is getting the answer. Obviously, this one did not involve a lot of things, so essentially you could score 4 marks for this. Now let's look at the next one. How many marks would you score? For this one, again, correct substitution according to the formula that we wrote. Wrong or right, it will still, be very friendly to you. Now for all the multiplications and what ending up here, you get a mark for this. Whenever you factorize in maths, part of the 3-step approach, you get a mark for this. Then when you drop the limit and substitute 0, you get a mark. And for the correct expression, usually the standard is 5 marks for this question. And of course, depending on the complexity of the expression that you had to deal with, you might end up getting around 6 marks. But I have never really seen this go beyond that. But yes, we can push it to that extent if we want to. All right, folks, so this is what is expected of you. Right. Now let's give you last example before we take on some further ideas. Now let's take example 3. Was it 3? 4. Wait. Oh, that was example 1. So this is 2. So this is 3. Now this one can say calculate the gradient of f of x equals x squared minus 4 at x is equal to 3 by using the first principles. I know you guys don't really get, these kinds of questions usually, and you tend to ignore. You will see how these questions can really horrify you if you don't know. So I'm just going to build you up nicely, folks. Don't worry. We're going to talk rules. We're going to take past exam question papers. And we're just going to make this course as enjoyable as possible. Okay, so let's get to business. We know, first of all, f prime of x is going to be equal to the limit as h tends to 0 of, let's see, f of x plus h minus f of x divided by h. Don't forget the formula. So we go, this is the limit as h tends to 0 of f of x is x. So what do we see? X is 3. Then we add h squared. Okay, maybe let me start by substituting properly. So first we're going to have x plus h squared minus 4 minus x squared minus 4 all divided by h. So this means this is the limit as h tends to 0 of, where I see x, I'm going to put it 3 plus h all squared minus 4 minus, I'm going to put again 3 squared minus 4 all divided by h. Okay, so this is the limit as h tends to 0. We sort this out, we're going to get 9 plus, now 3 times h times 2 is going to be 6h plus h squared minus 4, this is going to be minus 9 plus 4 divided by h. So again, the magics take place. The magic takes place. Right. So let's see what happens. So this is equal to the limit as h tends to 0 of 6h plus h squared all divided by h. Now this is the limit as h tends to 0 of h into 6 plus h all over h. If that doesn't happen, you're not doing well. This is the limit as h tends to 0 of 6 plus h. We drop the limit, so this is 6 plus 0, which is equal to 6. Right, so this implies that f prime of x is this. Now f prime at 3. This changes because it's substituted with a 3. So again, guys, pay attention to what you're doing. Don't be a blindfolded freak who needs to be told, hey, what have you been doing here? So why are you doing crazy things? You need to show us that you know your things, guys. Because we wanted the gradient when f is 3. So can you see, systematically, we're doing our things. So this tells us that the gradient is 3. And I expected a positive gradient. Why? Because this parabola, if I was to look at it on the Cartesian plane, now integrate information, guys. I need you to learn to do this, because if you don't integrate, you will not get anywhere in life. Now this is a parabola where the y-intercept is exactly the turning point. You can know these things because the way this is given is the way you should understand it. So this is our function f. Now, I know that this is going to be a 2 and minus 2, so this is minus 4. So obviously at 3, I expect a positive gradient. I should not be getting a negative gradient. Of course, spare that this is slanting a bit. So I expected a positive gradient there. The tangent at that point is very steep. So the gradient is 6, so I can appreciate this. That the tangent at that particular point, maybe let's make it a bit more. Okay, it hides our 2. Okay, let's get rid of this 2 here. So guys, look at these things good and make sure that your sketch is representative. So if we look at our tangent here, you'll see that it's very steep. It's almost vertical, right? At that point, x is 3. And of course, we know that the x-intercept is at 2. So this is indeed making sense. So always ask yourself, is your answer making sense in terms of what you expect? And no one is going to teach you these things. You just have to be inquisitive. Students who are spoon-fed, is it spoon-fed, or who wait for spoon-feeding are never going to get anywhere. Now there's a few things I need you guys to notice here, because there's something that you need to pay attention to. Do you realize that this is a perfect square? This is a perfect square, right? That's a perfect square. And it continues as such here. It's a perfect square. These are the things I need you to notice, because hey, usengaba sentweni endingayaziyo ndikuxelele mntwana esikolo. Usengaba sentweni endingayaziyo. Ndiyakuxelela. Right, so pay attention to this. So when you've got a quadratic, the very first expression is a perfect square. Right? It's a perfect square. I need you to study these things very well, because some questions will be asked and you end up suffering. Okay? You end up suffering. So you don't want to suffer. Right? Right. Okay, cool. All right, guys. So I needed you guys to pay attention that these are perfect squares. When we've got a quadratic, okay? I need you to remember this. Okay, what happens when it is not a perfect square? Let's go back. What happened when the expression was essentially not a perfect square? Because you need to study this. What do you see? If it wasn't a perfect square, what does it become? It's linear. It's linear. That's another thing that you need to pay attention to. So this is linear. So always study these expressions. Look at what you had and look what you see here. Linear. So this is very important. This is very important. And if it is not a perfect square, it's going to be a perfect cube. And there's a significance to what I just said. But let's just carry on. Let's just say this was the first question. Then the next question says, hence, determine, let me write properly. So the next question will say, hence, determine the equation of the tangent at x is equal to 3. Now, how are we going to do it? First, we need the point of tangency. Which I call the port. So whenever you say things, folks, you want to first introduce it. So the point of tangency is going to be f of 3 is equal to basically 3 squared minus 4. This is 9 minus 4, which is 5. You can say, therefore, our port is going to be 3 is to 5. Okay, so that's the first thing we can say. Then we know that the tangent is such that y is equal to 6x plus c through the port, which is 3 is to 5. We know that 5 is going to be 6 into 3 plus c. Therefore, c is, this is 18. 18 plus 5 is 23, right? So, no. This is 18. When we bring into the other side, it's going to give us minus 13. Therefore, y is going to be 6x minus 13. Right, so this is very important. So you can already see that we can do a lot of things from this knowledge. We can do a lot of things from this knowledge. As you would see, this doesn't belong here. Hi, when? It does not belong there. Haibo. Give me short whites. This belongs here, Bafruits. Okay, hence determine the equation of the tangent. So this is non-negotiable, guys. You need to know it. Now let's make these questions a bit more interesting. Now let's give you an example 4. Okay. Example 4 says for a particular function f, it is found that the gradient at a particular point, okay, it is found that the gradient at a particular point is such that, hey, 6, okay, let's not use this one. Let's say 2 is equal to the limit, excuse me, as h tends to 0 of So this is what we have. Let me just double check something here. Okay, yeah, I'm good. So now here what is happening here. For a particular function f, it is, this is not cool, it is found that the gradient at a particular point is 2 equals the limit of 1 plus h all squared plus 1 minus 1 squared plus 1. Okay, so the question says find the function f. Find f. Okay, let's just do that. So the question says find f, or the equation of f. Let me put it clearly. Find the equation of f. Right? That's the first question. So how will we find the equation of f? Very interesting. And the point at which the tangent has gradient of 2. Ooh. Okay, now we're making it more silly and more difficult. So it says find the equation of f and the point at which the tangent has a gradient of 2. Maybe what tangent? The tangent to f. We need to be clear, guys. I'm just showing you how questions are developed as well. Right, so let's answer this thing. Okay, guys, what do we know, folks? We know that from the first principles, we know that the first derivative of x is the limit of h as whatever x plus h f of x plus h minus f of x divided by h. So remember, this is our knowledge, that when we want the gradient at a point, that's what we see. Now we look what happened here. Look at this bracket. There's an x plus h inside. Okay, cool. And then look at this last one. This is the function f of x, and there's a negative before it. Do you see the negative, and do you see that bracket? So this already tells me that the x is 1. As I can see there, that I have substituted 1. So the x is 1. And if that's the x, remember this one is squared. So that means f of x is going to have an x squared plus 1 over there. Right. And you will see that sometimes the constant may be seated alone outside, like this here. So if we look at that, it just tells us that this usually would go with that. You will always see that what you see here, you expect to see also in a portion of what f would look like. We can say here, from 2 is equal to 1 plus h all squared plus 1 minus 1 squared plus 1 all over h. Of course, guys, I'm just being as systematic as I can be. You don't have to be like this. I know that, therefore, my f of x is going to be, all I know is that I substituted 1 for x. So this must be x squared. Remember, this is what defines f. So this is going to be x squared plus 1. Because the constant is what it is. So 1 only substituted the variable, because I can see this is what is happening. Why? Because this one is the same as this one. So already it means it's part of the expression of f. So this is how you could be asked a question, so that you can be given where there has been a substitution and you are told find the expression for the function, or at least find the function. So I hope this procedure gives you some ideas, okay? I hope it does. Now, let's see. We can say then, by the way, we were not done. So we wanted the point where the tangent will have the gradient of 2, and we know that this is where x is 1. So what do we know? We know that, okay, f of 1 is going to be equal to 1 squared plus 1. Therefore, f of 1 is going to be 2. We can say, therefore, the point of tangency is 1:2, because the tangent has a gradient of 2 there. We can see that. But sometimes we can decide to say something else. Say tangent, the gradient is 4, you know? So when the gradient is 4, it means everything changes. You understand, guys? So be very careful. I can really play with your head here. But for now, I just try to keep as simple as possible. Please be very aware of examples like these. They cause problems for students who are not aware. All right, so this is essentially, folks, where the first principles can take us if we want to go there. Now I want to take another example. This is example 5. Don't worry, guys, we're going to hit those exam questions flying and very angry when we do it. Example 5 says, let me see, find the equation of f if okay, just a moment. All right, guys, so let's carry on. So find the equation of f if, okay, f prime x equals the limit as h tends to 0 of x squared plus 2xh plus x squared minus 4x plus 4h plus 5 minus f of x is equal to h. Umbuzo umile. Now this says find the equation of f if this is what we are given. So what would you do for this one? Now, as I said, always check if you've got the highest exponent being quadratic. You will notice that this is a perfect square, right? So first of all, you look at the highest exponent. You know that f must be a quadratic in this case, right? Right, so what do? We try and factorize this thing. So this implies that f prime of x is going to be the limit as h tends to 0. We see that's a perfect square trinomial. We factorize it. It's going to be x plus h all squared. Minus, we can see there's a highest common factor here of 4. Then we've got x plus h. Right. Is it? I'm not happy here. I kind of messed up. Sorry, guys. This doesn't make sense. It should have been negative there. Okay, cool. Now, when we pull out a negative, this is what we get, and then the constant, and then f of x all over h. Now, what do we know, guys? We know that from the first principles, isn't it? We say. Now we can say since f prime of x is equal to the limit as h tends to 0. I just want to show you something. It's going to be f of x plus h minus f of x divided by h. So this means our f function can be studied here, because we saw that we have consistently been subtracting f of x. So this means everything else on the negative side must be our f of x. And remember, where we saw x, we put, this was for x. The whole expression is for x. And this again is for x, isn't it? So that whole thing replaced x. So we can say, therefore, our function f must be x squared. Remember, x plus h, you replace it with x this time around. You hold x alone. And where you see x plus h, you put x back. So this is going to be minus 4x plus 5. Of course, this is a bit cumbersome. It's not really the best, but I'm just trying to show you things that can help you succeed, if at all. You know, if at all, you should succeed. So I was just trying to give you guys a situation that is probably a little bit crazy, and so that you can see all that is necessary. And who is our informant is the principles themselves. So there's always things we can look at and compare, and we essentially try our very best to learn from the structure that we're given to then decide which direction to go. I think this is it, folks, for now. Maybe let's take one last example on differentiation. You can write some extra notes here. Let's just take one example on differentiation, and yeah, let you be. So this is example. I just wanted us to play with this first principle 6. Okay guys, this course is getting too long. I don't like it. So find f prime of x if f of x is equal to 2 over x. So what are we gonna do here? Maybe let's make it even more crazy. Say x minus 1. Yeah, the hyperbola that is shifted. Let's make it interesting. I know I could have made it very easy, but now I'm making it even harder. But I think this one makes it too easy. This one makes it too easy, right? Is it? Maybe. Let's just take it down and see. F prime x is the limit as h tends to 0 of f of x plus h minus f of x divided by h. So this is the limit as h tends to 0. Now f of x is 2 over x plus h minus 1 minus 2 over x minus 1, all divided by h. Right. Now let's get to business. So this is the limit as h tends to 0. Now we've got a situation over there, right? We've got a situation. Okay, so we need to first sort up this. Remember, this is fractions. Now we need to sort this out nicely. So how do we do it? We know that we need the common denominator, right? Common denominator there is going to be x minus 1 into essentially x minus 1 plus h. Okay, whatever. Then what do we do now? We are going to say, fine, when we divide by the first denominator, literally, but let me put it in a way. Of course, this one goes and then only this one remains. So this is going to be 2 into x minus 1, right? Of course, you can just think of it as cross multiplication. Once you find the common denominator, just cross multiply. So this is going to be 2 into this x plus h minus 1. Now we make this final division thing come up there so that we don't run into problems. Now let's sort it out. So we get 2x minus 2 minus 2x minus 2h plus 2 all divided by, now when we FOIL this one out, what do we get? This is going to be x squared. I'm not happy with this one. I'm not happy with this one. I'm not happy with this one. This one. Okay, so let's do it. It's going to be x squared minus x, right, plus xh or hx, right? And then we're going to get minus x plus 1 minus h. Very interesting stuff. Okay, divided by h over 1. You do get these situations coming up. This guy takes that guy takes that guy. So this guy will always okay. So we get minus 2h all over 2. All over 2. What is this? We know that this dude, so we get x squared minus x is going to be minus 2x, right? Plus 1. And then we've got plus xh minus h multiplied by 1 over h. Right, we know that this guy and that guy will go. So this has to happen, because if this guy multiplies the whole expression, then it kills the whole process. So we're going to get minus 2. Numerators multiply, denominators multiply. So we have x squared minus 2x plus 1 plus xh minus h. This time we can drop the limit. So we've got minus 2 divided by x squared minus 2x plus 1 plus x into 0 minus 0. Remember, when we substitute, we must not get 0 in the denominator. So this is minus 2 divided by x squared minus 2x plus 1. So you could leave it here, or you could go a step further and say, what is this? It's a perfect trinomial, so this is x minus 1 all squared. You could also leave it here. Right. Right. So this one is good. So folks, your answer could be left here, or you can leave it here. It's not a problem. Hahuna mathata. Wabona. So this means we can do these things, even for a hyperbola, even if it's full, we can actually do the first derivative using the first principle. So when you see it, don't scream. Say, I haven't seen this one. You don't have to see it. You just have to know how to apply your knowledge. So this one, let's see, how many marks would you score? First of all, for substitution, 1 mark. Then for all our troubles, guys, ending up here, 1 mark. Is that the one? Okay, maybe this is too soon. Maybe the mark is here. And then when we do the gymnastics and finally drop the limit, so 1, 2, 3, 4. It has to be 5 marks. This would be as good as, factorization. So we should get still 5 marks. So please, guys, don't say you don't know how to do the things. Don't say you don't know how to do the things. You must always do the things. You must always do the things. So I was just trying to get you, one of those crazy questions. They come. And when they come, you must just do the right thing. You know the maths, you know the basics. Go with the basics. Now, folks, we want to talk about the rules of differentiation because, for us to really thrive in this topic, we cannot always use the first principles. There are some expressions which are crazy that don't allow us to, to do some things. So these things can be very bad. So now let's talk about rules of differentiation. Let me write nicely. Right. We're going to talk about some rules because we want to be able to differentiate much faster. As you can see, if we were to do this all the time, this is bad. So what do we do? Well, we've got a power rule. Right? The power rule says if we've got an expression f of x is ax to the exponent n. So this means our first derivative is going to be n times a times x, and we subtract 1 like that. So this is what it means. So it means we multiply by the exponent in front or to the coefficient, and from the exponent we subtract 1. That's the power rule. It's as simple as that. Okay? If we take an example for this, we've got f of x is 2x squared. So this means the first derivative here, okay, is going to be 2 into 2x. We subtract 1. Therefore, maybe let's say this implies and make our conclusion. So this is going to be 4x. So that's basically how the power rule works. And you will see that this is the mainstay of differentiation in grade 12. This is the mainstay. differentiation in grade 12. I'm going to say this because not elsewhere but here. You'll almost always be using your friend power rule. Do you hear? You have to know, okay? You have to know. Now, what is the other rule, Gonch? You have to know these things. What is the other rule? We know that if we've got, but that one is something you just have to know, but I don't want to get to it now. I don't want to get to it, you know. Oh, my Lord. Okay. What is this one, Gonch? Benifuna uthetha something ngetana, but ngoku iyandiphoxa. Iyangiphoxa. Yalokha ingqondo, guys. Lokhile. The brain is not braining. Okay. While it still refuses to brain. Konje benifuna ukuthini? Let me say this as a disclaimer. We'll just say note. Note that the derivative of a constant is equal to 0. Example, if we've got f of x is equal to 2, you can say therefore f prime x is 0. No questions asked. Okay, this is a very important thing to note, that the derivative of a constant is equal to 0. Where does this whole shenanigan come from? Take, for example, we said this is the gradient at any point on the graph. This is the origin. Now we've got a graph of a horizontal line, for example. So this is the line. F of x is equal to, say, 2, right? This is a horizontal line that cuts at 2. What's the gradient? The gradient is 0, isn't it? So the gradient of a horizontal line is 0. So this is why it is so that any constant, when we take the derivative, it's 0. Okay, all right, okay. Again, you can think about it and say, but why is it so? Yes, we understand that when we talk about a straight line, it is so, but how could we showcase this mathematically? Think about the constant. Remember, a constant is a coefficient of any variable. Now we can easily say, well, let's have a look and see. F of x could be looked at as 2x to the exponent 0. Right, because this is, again, the same thing. So we could showcase 2 as just 2x to the exponent 0. And you would know that when you take the derivative, you multiply in front. Then we're going to say 0 minus 1. So, now what do we have? Now 0 multiplied by any number is going to be 0. As long as you're multiplying by 0, you have killed everything. So this is again how we could look at it mathematically and say, okay, all right, we understand now why the derivative of a constant is 0, because a constant can be a coefficient multiplied by to the not power of a variable base, whichever variable you may want to look at. But since we're differentiating with respect to x in this topic in general, we would want to use that variable as x. Bear in mind the exponent has to be 0 for this to happen. So maybe it was the perfect time to use the power rule in this regard here. Okay, guys? So please remember this. Do not forget it. Remember this and do not forget it. Now, folks, maybe I rushed here. When we do differentiation, there's notation here, the issue of notation. Let's talk about notation, because I think it will be very important. The notation, we can talk about f prime of x when we've got a function. We can talk about g prime x. We can talk about k prime x, etc. Right? So this is when we're using the function notation. Now, when a function is represented in terms of y, we can talk about dy dx. Okay? So that's very important. This is when the function is represented by y. And when we are dealing with an expression, not an equation, you would see something like this. Capital letter dx. And then you would have the square brackets and an expression. Okay? But of course, let's just forget. Let's just say dx. This is an equivalent of d over dx, like that. Because this is telling us that we're just differentiating an expression with respect to x. So please be able to not mess up when it comes to notation. It is very important. All right. Good. Yeah, guys, we're building this up. We're building this up. Now, what do we want to do next? We want to talk about the next rule. The next rule that you're going to talk about here is that when you differentiate a polynomial, for example, what do? We know that when we differentiate a polynomial, let's say, for example, what is the term that we can use? Wait. You know, the rule that I showed here is nothing but, I feel like I've already combined the so-called constant multiple rule, but it doesn't matter anyway. Let's leave it. Now, when we differentiate a polynomial, let's say we differentiate a polynomial where we've got f of x plus or minus g of x. Now we can treat this as an expression if we want, because it doesn't matter what is going on. So the answer here, guys, must be the derivative of f of x plus or minus, depending on the signs, plus or minus the derivative of g. Now remember, these may not necessarily be functions. Okay, so another person may even look at this and say, fine, one could easily look at this as equal to f prime x plus or minus g prime x. But of course, this is not necessarily how we look at it, but we can just assume that if we've got a polynomial, hoping that this is just an expression, when we take the derivative, we just take the derivative of the first one plus or minus the derivative of the second one. And again, this is a typical way of differentiating in grade 12. You will see that we often have polynomials instead of a monomial or whatever that is. So this is for polynomials. Well, with multiple variables, of course. Okay. Now there's a few other rules of differentiation that I would like to highlight, just for your sake. Okay. Because these are very important. I don't know why you guys are not being taught these ones. We talk of the product rule. Right? We talk of the product rule. So how do we differentiate a product? Right. Sit with me. Right, guys. So what happens when we've got, the product rule or whatever you call it? Siyenza njani? How do we even have a product? Now let's think about it for a second. Now, let's say we've got a function. Let's say we've got, okay, let's just say we are differentiating a product. So we're differentiating g, let's just say f of x times g of x. So what would be the answer? Now, the product rule tells us that this is going to be the same as, we're going to say, fine, this is going to be the first. Now look at this. The first function is f. So we're going to say this is f of x times the g function, but we take the derivative, right? Plus g of x, the second function, times the derivative of the first function. Right, so the product rule says, I did something incorrect here. This was meant to just be f, okay? So essentially, when we do the product rule, when we've got two functions that multiply each other, okay? So we literally take the first function as it is, we then multiply it into the derivative of the first function, and then we add the second function multiplied by the derivative of the second function. So that's the product rule of differentiation. Ne? Okay, so you treat these as if they were functions, separate functions, if I can put it that way. This is crazy, ne? This is crazy. So let's take an example for argument's sake. For argument's sakes, let's say here, example. Hey, Bo. I think I'm tired now. I'm gonna take a break. Example, we want to differentiate x plus 2 into x squared plus 3x plus 1, for example. Now we can treat these as separate functions. Although you know this is a cubic function, you could actually deal with this nicely, but you actually can differentiate this. You will see that nothing changes. So we know that we're going to say the first function x plus 2 times the derivative of the second. Maybe let's write it where we have space. So we can say this is equal to the first function x plus 2 times the derivative. This is going to be 2x plus 3. The constant is gone, right? Plus second one is x squared plus 3x plus 1 into the derivative of the first one. It's just 1. Okay, so let us see what happens here. Now we can FOIL this out nicely. So this is going to be 2x squared. 3x plus 4x is going to be 7x. And then we're going to have plus 6. This is plus x squared plus 3x plus 1. Sort it out. This is 3x squared plus 10x plus 7. Why do I feel like there's a crime? It feels like there is a criminal. No, there is no crime, guys. It's fine like this. Right, so this is the answer. Right? Right. Now let's say you decided, of course guys, these ones are usually not used in your curriculum. I'm just making sure you know things, okay? I will tell you about this example as we keep going. I will tell you about it. The first thing that another person would have done, just to verify the above, I'm going to put it inside this box here, just to prove that this rule is true. Now we've got dx. Now if you sort this out, this is going to be x cubed, right? And then we're going to have x multiplied by 3x. This is going to be 3x squared plus 2x squared. This gives us 5x squared, okay? Then we're going to have x plus 6x is going to be 7x. Then we're going to have 2 times 1, that's 3. So you literally FOIL this expression out. Now following this rule, where we pretend every term is a function, so this is going to be equal to 3x squared plus 10x plus 7. See? Even if we broke those brackets and then differentiated the cubic expression, we come up to the same answer. Nice, 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 nice. So this is good, guys. So of course this is the preferred way in grade 12. You will see, I will tell you exactly what makes our expressions ready for differentiation in this part where we use the rules of differentiation. Okay, so I will talk about this product rule. Again, here's another rule which is exotic to this topic. We're going to talk about the quotient rule. Okay, let's write it properly, guys. I don't know why my writing just keeps dying. I think I'm tired. In fact, of writing in general. My writing is just dead. Is Fertway. This pen color is not the same, eh? Hipo, kwenzeke ntoni la? Ifuna umnyama man. Ayikho mnyama le. Yibona njani? I think my eyes are crazy, eh? This color doesn't look black. Anyway, whatever. Now let's say we've got a quotient, guys. We want to take the derivative of an expression where we've got f of x on top divided by g of x. Take a hyperbola, for example. A hyperbola where we've got a linear expression on top and a linear expression on the denominator. So how do we handle this? Well, the rule tells us that the answer would be what is on the denominator multiplied by the first derivative of the numerator minus what was on the numerator multiplied by the first derivative of the denominator, all divided by the denominator's function squared. Okay, so that's the quotient rule. So please know these things, folks. There's also what we call the chain rule. But I'm not going to go to the chain rule, but it's another way of differentiation. So let's not get to the chain rule. In metric, you are not likely to be asked something like that. Okay, so this is essentially the stuff. But I think I want to also include something, I want to include something, The last one, let's add this one. We've got what we call the constant. The reason why I'm adding these, you will see where they apply constant multiple rule, right? So how does this one work? Say, for example, we've got a constant c multiplied by f of x, and we want to take the derivative of that. So what does this mean? It means the constant stays in front and it multiplies the derivative of the function only. So I hope these ones, you check them out. Please know these things. They are very important. I'm not going to show you, or maybe I should have shown you an example so that you don't cry and say, I got userobile, mister. I don't want you to say I robbed you. No. Okay, let's start here. Just like we have been doing. Let's take an example. So what would this one look like? Let's say, for example, we've got, take the derivative of 2 over x minus 1. Do you remember that example we did above? Yeah. Yes, this one. So, but I feel like it doesn't fit. It does not fit the things, but let's do it using this knowledge. So what do we say, guys? We're going to say it's going to be, when we do this, we're going to say the function in the denominator, right? First, so this is x minus 1 multiplied by the derivative of a constant is 0 minus what was in front, 2, into the derivative of the denominator. This is just going to be 1, isn't it? All divided by, we take this one and we square it. Now let's see, what do we get? Anything multiplied by 0 is gone. So this gives us minus 2 divided by x minus 1 all squared. Answer. Isn't it the answer that we got? Yes, it is the one. So we got it in a quicker way than having had to go through the troubles of doing the things. All right, I'm not going to take any further examples. You already have an idea of what is going on right now. Now let's talk about the constant multiple rule. Okay. Let's take a derivative. For an example, we want to differentiate this issue here. Let's say we've got 2 into x squared plus 2x minus 1. So this is basically what we're trying to do. When we say f, we mean it's a function of some sort. It's not just a single term. Because if we use it as a single term, we will somewhat lose the plot, isn't it? Yes, we would. So let's have a look. What would be the answer here? So it says the constant stays. Then we multiply it into the derivative of that expression. So this is going to be 2x plus 2. Remember, that one is gone. Then we multiply this constant. We get 4x plus 4, right? That would be the answer. Now, what is the standard way of dealing with this? You will see that in grade 12, we don't do what I just showed you. We do other things. So we would have dx of, first you break this bracket. It's going to be 2x squared plus 4x minus 2. And then this is going to be equal to 4x plus 4. So in grade 12, we don't use this rule per se, but you will see there are some instances where it can be applied. Okay, so this is essentially true. As you could see, that even if we do what is right, simplifying first, we actually get somewhere. All right, guys, so these are the rules that I need you to pay attention to when it comes to differentiation. Excuse me. So I don't know, folks. I'm feeling like I'm talking too much. Anyway, Lisejo wanted a long video. So, and of course, this can be a course that you can sit for. Maybe when you have a free weekend, or maybe you are sick, you are bored at home, you are tired, you've slept, you woke up, you ate, you don't know what to do. You can just sit and watch here and engage your brain. Remember, even when you are sick, your brain still works, okay? So you can do that sometimes when you have a holiday of some sort and you need to practice. You can use these videos to help you out. Now, let's say NB. Now, these are the notes. How to prepare for it. Let's just say how prepare a function or expression for differentiation. Right. How do we prepare a function or an expression for differentiation? First, remove all brackets. Right? As you could see, if you remove all brackets, you avoid things like the product rule, which if you don't know, you could suffer. And yeah, let's start there. You remove all brackets. Secondly, what do we do? What can I say? We can say no x variable or any variable with respect to which the derivative is to be taken must be under the square root or in the denominator. Right. So no x variable, mainly we use the x variable or any other variable for that matter with respect to which the derivative is to be taken, right? Must be under the square root or a radical or in the denominator of the expression. Right, so this means we can't have square roots, we can't have our variable x in the denominator. Now this helps you guys to avoid an issue of the quotient rule, for example. Okay, so this helps us to then use the power rule every time. Okay, and essentially in polynomials. Is there anything else that I should say? There was quite a few things, was it not? Maybe I should have mentioned them separately, but yeah, I think those are the two things, guys. There mustn't be any brackets in the expression. We should avoid x or any variable with respect to which the derivative is to be taken, which must be under either the square root or be found in the denominator of the expression. In this case, we get to avoid things like, what is this? I think the square roots would have been taken care of. Let me think, Kwanjo, which rule would have taken care of square roots? Let's not say too much. I think it's fair to not say too much. Let's not do that, but I'm not too sure. Does the chain rule do that? I don't know. Okay, so this is noteworthy, folks. So whenever you differentiate, I don't know if but I feel like I'm forgetting a third thing. Or is it two things that I put in here? No brackets, number one. No variable under the square root or in the denominator of the expression. This way we avoid all these other rules, because the reason for all of this, we then enable ourselves. This is to enable grade 12 students to differentiate using the power rule in polynomials only. So the reason for all of this is to use the power rule, because we know we don't want errors, because remember those other rules have potentials for some serious problems if you don't know how to perform perfectly. So to avoid you guys failing, of course I accept this, but I'm not happy with it either, because this way we're kind of restrained, or should I say restricted, grade 12 students from performing differentiations, for example, in hyperbolas. Let's say I wanted a gradient at a point on a hyperbola. Now I end up not being able to ask such questions, and yet I should be able to ask such questions. Guys, this is high school. This is not kindergarten. We can't just limit how much you should know because, this is going to be taught at university. Look, at university, we should be teaching you serious stuff. Like big boy and big girl stuff there, not baby stuff still being taught in education higher than matric. Matric should be the ultimate, guys, of school-based learning, if you want to call that. When we go beyond matric, we should be figuring out the world, as best as possible. So I don't like the way this is designed because I know it's designed so that many people can pass matric, but we don't care about numbers. We only care about quality because that's what moves the country. Remember, the country is not moved by a multitude of people. Others are just good as workers who need to be told what to do, how to do it, when to do it. They are not very innovative people. If we were to have innovative people in numbers, imagine the chaos that would result. The propaganda, the fighting. Because look at the countries that keep fighting each other. This is the people who have multiple smart people who do, creative things. At the end, they get bored. They start creating, weapons of mass destruction because they are bored. They have figured out a lot of things. They quickly become dangerous. This is why we say, again, too much knowledge is dangerous. This is why we need a few people smart, because remember, if we've got a few people smart enough to create things, they will be afraid of the multitudes in going against them. Whereas the multitudes depend on those people for a direction. Again, if we have too many leaders, we end up with a confused society, isn't it? Look at how popular politicians are. Look at how confused citizens are as a result. But when we had a few figures to look up to, everyone was pulling in the right direction, you see. So, unfortunately, guys, for these kinds of subjects, we cannot really celebrate numbers, no. If we start to have that, we are just creating an abnormality. These subjects are not for everybody. Even those who do them, they still don't understand them well. That's just the fun part of it. They live their lives trying to figure out the entire science, and they never get to that. But of course, their strides against and beyond the limits are going to keep pushing the limits higher and higher. And who knows, one day, we might even know who God is and maybe shake his hand directly. Okay, guys, I think you can see how everything works nicely, and you start to understand why we push you guys into this restriction, because we are restricting you to this to help you to pass, because there's lots of room for errors in the other techniques that I have shown you, and you can see really the beauty of what we are talking about. So when you differentiate, stick to the power rule, and to make it work for most of the expressions you will be asked, you do this. Get rid of brackets, take away square roots, remove variables that we need to differentiate with respect to if they appear in the denominator. So we use our exponential rules to do that. And that's it, guys. That's it. Now we are ready to demonstrate some of these things so that you guys know what to do. Okay. So now I'm going to take a few examples where we can use our rules of differentiation. Remember, we are done using the first principles. I've shown you all the secrets about it. Now we want to take some examples where we can use our rules of differentiation. Then after this, we're going to go at past exam question papers in this section. Then after that, we are going to go into the cubic function. I'm not sure if I should discuss the cubic function before we take some past exam question papers, maybe. But I think if we do them section by section, it's going to be much better. Okay, I think let's just do them section by section. First, we can just say differentiation is what we want to play with. Take some different exam questions and maybe sit there. Then we get to the cubic function, we play with it. Then we leave it there. We get to optimization, we play with that, and we leave it there. So this video, guys, is going to be some video. So stick with me. Let me just go make myself a cup of tea so that I don't lose my strength, so that we can take our examples. Or maybe let's take the examples now. Then I drink my coffee and then I look at the examples that we should take from past exam question papers. All right, guys, let's take some examples where we can use the rules of differentiation. So let's get to business. Let's take one example. So let's call this one example 1. Here, the note is to use the rules of differentiation. Essentially, we mean the power rule. Because we are not doing anything bigger than this. So example 1. Say find the derivative. Find the derivative. Actually, let's just say example, not examples. Hey guys, angikwazi ukubhala man. Yo. My brain is fast, man. And I don't finish my writing. That's why my writing is dying. I'm moving faster than my hand. It's not nice. Now let's see, guys. We've got A. A wethu ngubani? 2x squared minus, is it 2x squared? 2x cubed minus x squared plus 1, right? B, we're going to have f of x is equal to 3x into 2x minus 6. C, I've got y is equal to 2x cubed minus 4x divided by 2x squared. Ne. Yeah, D. Ringaifing f of x is equal to 3 root x minus 3x squared minus 6x plus 1 all divided by 6x squared. Okay, let's take the last one. Maybe let's make it nice in 5 examples so that you guys get an adequate. So g of x is equal to 1 over 4 root x plus 1 over x root x. Right, so our job is to find the derivative of those expressions. Okay. Now, folks, I'm just trying to highlight how the suggestion above here that if we do this, we avoid these other laws. in which case you can try them, you know. There's what we call addition rule, there's what we call, you know, subtraction rule or minus rule. Anyway, if it's minus, remember, let's just leave it, guys. The minus and the addition rule are not really a big deal. Okay, now answers. To the writing bengihleli kahle la ngibhala kamnandi andazi vele kwamoshwa yini. Hayi nale bhedi yami seyisisikebe nje ndisezingubeni. Okay, bendisezingubeni andisekho sezingubeni. Okay, so let's do the answers, guys, nicely. A. So we need to take the derivative. So what is the notation? The notation is dx. So do not forget, notation is key, because we can't just differentiate that expression without writing it in the correct notation. And then the answer is, now we're going to have 6x squared minus 2x. Remember, the constant is nothing. So this is very simple, guys. So obviously you'd get a mark for each of the derivatives. And we move on. B. We have f of x. So once we have f of x, we're going to write f prime. Oh, wait. F of x is not ready for differentiation. As much as we can use the product rule, we need to avoid it. So f of x is 3x into 2x minus 6. Therefore, f of x is going to be 6x squared minus 18x. Therefore, our first derivative is going to be 12x minus 18. Nice and easy. So for writing this, we get a mark and a mark for each derivative. Not a problem. You can think about, why would you get a mark here? If, of course, you use the product rule. By substituting into the product rule, you get a mark. So this mark would have been given for that if you had to use it. So you can see quickly, we don't have to run into the problems of, you know, those rules. I've already shown you how they work, so I'm not going to show you here. Your job is to play with those rules directly without doing this simplified version of things, just to test your knowledge and see if you mastered everything. I cannot spoon feed you. You either learn or you don't. Right, so let's look at C. We've got y is equal to 2x cubed minus 4x divided by 2x squared. Now we can see that this expression is not ready. It's going to force us into the quotient rule. We don't want to go there. So what do? We just say this is going to be 2. We factorize this expression. The highest common factor of the numerator is going to be 2x into, we get x squared minus 1. No, you lie, minus 2. Divided by 2x squared. Actually, this one doesn't work, eh? It doesn't do the things. Okay, this factorization, because it doesn't eliminate my denominator, I might as well not do it. Sometimes you have to use your rough work so that you don't make mistakes like this and end up scratching. We know that this denominator divides each one of the terms in the numerator. Minus 4x divided by 2x squared, because we are doing a decomposition of that fraction. Now we start to see that, okay, x squared will take the cube and leave 1. Then 2 will take the 2. Good. 2 takes 4 to 2. And then we know that that x takes the square. So we know that our y is going to be x minus 2 over x. Right. So therefore, y is going to be x minus, we don't want the variable in the denominator, so this is going to be 2x to the minus 1. Now we are ready to differentiate. So this is in terms of y, so we're going to say dy dx equals, the derivative is going to be 1 plus 2x to the minus 2. Now you've got options here that you can do. You can just simplify this to 1 plus 2 over x squared, because in maths we hate negative exponents. You can leave it like this, or you can leave it as we have found it. It's not a big deal. So you either leave it there or you can take it down here. It is absolutely you. So you get a mark for this simplification, and you get a mark for, actually we get a mark for this, and then we get a mark for each of the derivatives, depending on which one you chose. So this would be 3 marks. As you can see, it's getting sweeter and sweeter and sweeter, right? I hope so. So wayendikhalela ukuzibhala apha ezezinye nazo. Hobaneng ke kgalla ho di ngola mona? Nilaba kothi tsala. Yeah, my Tsonga is not strong, so don't laugh at me. Don't laugh at me. So we've got D. Now let's look at D. D is also not ready for differentiation. So we're going to have f of x is equal to, this is going to be 3 times x. We remove the square root. We've got a rational exponent there. So for this one, we're going to have 3x squared divided by 6x squared. Remember, that denominator divides each term on its numerator. Right, so perhaps let's put a bracket, because this negative is going to mess with us. So this is going to be minus 6x divided by 6x squared plus 1 over 6x squared. Now a few magics will take place. This takes this one to 2. The square takes the square. It's gone. So 6 takes 6. X takes the square. Right. So we've got our f of x is 3x to the 1 over 2 minus, in the bracket we just have a half, minus 1 over x plus 1 over 6 x squared. So obviously we don't want brackets. F of x is equal to, this is 3x to the 1 over 2. We FOIL this out, it's going to be minus a half. This is going to be plus, we move the x to the numerator. This is also going to be negative. We get here a 1 over 6 x to the minus 2. Okay, so this is good. So we can say therefore the first derivative will be 3 over 2 x. Now a half minus 1 is going to be minus a half. Right. Minus x to the minus 2. Remember, this one gives us 0. We're not going to focus on it. It's out. And then we're going to have plus 2 over 6 is 1 over 3 x to the minus 3. Now, this is good enough, guys. But if you want to drag it to this, in maths we hate rational exponents and negative exponents. So if you look at this, this is as good as 3 over 2. Now this is going to be a positive x to the half. This is as good as root x. We don't also like rational exponents. Minus, this is going to be minus 1 over, this one is going to be x squared, plus 1 over, this is going to be 3x cubed. So if you like, you can bring it down here. As you can see, it's a bit technical. You don't have to. But I'm just showing you because at times you may be asked to say, show that the derivative of a particular expression is this answer. Because when we want this answer, we can force your hand. Okay? So this means you need to know how to do this. Okay? All right. Okay. Whew. All right, we've got it. So what else do we need? We've done it. So let's mark it. So how many marks would you score for this? Obviously, we get a mark for writing our expression nicely. And then we get a mark for each of the derivatives. So yes, we're a bit stingy. But hey, we can't give you many marks for this. This is very simple. All right, so let's take the last one, folks. And hopefully you guys are going to really enjoy this. Did I say f of x, g of x? This is 1 over 4 root x plus 1 over x times the square root of x. Okay, so obviously guys, I'm going to just jump for the jugular. I hope you will know what I did. So this is nothing but a quarter of x to the minus 1 over 2. If you didn't catch it, hey, hi. This one is going to be x to the minus 3 over 2. How did I get that one? Do you know? Well, you find out. Do go through the steps, but I am moving fast now. Okay, I am moving fast. Right, so let's do the derivative. So therefore g prime x is going to be, now when we multiply there, we're gonna get minus 1 over 8 of x. Now we're gonna say minus 3 over 2. Right? Then this one becomes also minus x minus 5 over 2. Of course, this is the answer, guys. But if you like to do some gymnastics here, you could easily say g prime of x is minus 1 over, this is going to be 8. Now, as you can see, this is the square root, because the 2 in the denominator will tell us this is the square root of x cubed. Right, minus 1 over, again, this is going to be the square root of x to the 5. You can bring it down here to showcase your skills, but it's not necessary. As you can see, it gets technical. It gets technical. I'm feeling tired now. Maybe I should take a break. All right, so what is it? We get a mark for writing our expression in the correct format for the two derivatives, whichever you chose to give. So most likely you're going to get marks like this, folks. As you can see, this avoids all these other rules we could easily have used. It simplifies our lives into just using the power rule. So I guess that's the intention here. But you should know about all these rules of differentiation. So folks, we have completed the basics of differential calculus, and I hope you understand them all. So I will stop here for the basics. Now we're going to get into past exam question papers on the same topic. Okay, so we're going to use the past exam questions to handle the same business. Don't worry, we're not going to do anything fancy. I just want you guys to get the feel of this situation. Now I'm going to have to select some nice questions that we're going to go through. So I'm going to take a pause and look at some nice questions to then get ourselves moving. Of course, we're not going to sit a lot on these. They are for you to practice. So I'm going to attach this document in the description, as well as the documents or the question papers or question bank that we are going to take our questions from, so that you can practice the rest, so that you are in a position to do your work. Okay. Yeah, I hope I wrote it in a way that you can read it. But of course, if you struggle, you can just ask a question. You can just ask a question. All right, guys, so let's go and check out some past exam question papers in this sphere of knowledge and play with them. All right, guys, so we've found this document. I'm going to share it with you guys in the description below. So it has every topic for paper 1. And these are all the trial papers from each province. I don't remember which year it was, 2021 or so. Anyway, let's get to this business, guys. So we're going to take this question 1. This is from Limpopo. At this point, I'm not going to specify which one it is. Right, so we've got 1.1, where we are told our f of x is equal to 4x squared minus x, and we need to differentiate from the first principle, so we know what to do. This is equal to the limit as h tends to 0 of f of x plus h divided by that. So we always write this expression. This is going to be equal to the limit as h tends to 0. We substitute. For where we see x, we put x plus h Then it is squared, where we see x, we put x plus h, minus, we put the expression as we know how. Right, so let's keep moving. Prime x, this is going to be the limit as h tends to 0. This is going to be 4 into x squared plus 2xh plus h squared minus x minus h minus 4x squared plus x, all divided by h. All right, so f prime x is the limit as h tends to 0 of 4x squared plus 8xh plus 4h squared minus x minus h minus 4x squared plus x, all divided by h. Now the magics happen. This and that go. This and that go. If it doesn't happen, it means we have a problem. Right, this is 8xh plus 4h squared minus h, all divided by h. So simplify stepwise. Don't be in a hurry. You will see that when you jump steps, mistakes occur. You can't trace the mistake, you end up doing too much work. Now we factorize h. Okay. Divided by h. So it should be really flowing, guys. The h goes. This one is going to be the limit as h tends to 0 of 8x plus 4h minus 1. Now we drop the limit. This is meant to be f prime x. Okay, when we drop the limit, what happens? We substitute with 0 where h is. Therefore, f prime x is going to be 8x minus 1. Remember, when you differentiate a quadratic, you expect to get a linear. And from the power rule, this was meant to be 8x minus 1. So you already know the answer. So you cannot present this answer blindly. Do the power rule on your side, then do the differentiation. If you don't get the same answer, then it means you've made a mistake in your principle. Obviously, we get a mark for substitution into this. We get a mark for our simplification. We get a mark for factorization. We get a mark when we drop the limit, and the final answer. So that's how we score those 5 marks. Nice and easy. So 1.2 with 1.2.1. Now we need to do dy dx. Of course, you write the expression first. So this is minus x cubed minus 16x squared plus 6x. So we can say therefore dy dx is, we use the power rule, this is going to be minus 3x squared minus 32x plus 6. Answer. This one was straightforward, so we get our marks for each of the derivatives. Now the second one is silly, so this is 1.2.2. We know that our f is not in the manner that we can differentiate, so this is going to be 4 over 5 x cubed minus, now this is going to be 3x to the minus 2 over 3. Okay, I'm moving fast, so you should go through the steps as well, but I'm just going to move fast to save some space and time. Of course, try to use your head as much as you can, but don't cut the corners. You will run into problems. So what does this become? This becomes 12 over 5 x squared plus, when you multiply there, we get 2 x to the minus 5 over 3. Right? Right. It's done. At this point, I'm not going to show you extra stuff. Says here, move much. We are in the exam, so you get a mark for this, then you get a mark for each derivative. Of course, go through the steps, guys. At this point, we are not wasting time. We are moving. Okay? We are moving. There's no room for errors. Now, okay, all right, okay. So let's just keep going. Let's just keep going. Do I want to do these ones? Okay, let's just do question 2. If I feel overwhelmed, I'm going to break this video into 3 sections. This one, the next one, maybe the cubic, then the last one, optimization. Well, sometimes it's much better to split it into 3, you know. I think it would be nice like that. Yeah, why not? So that the videos are not too tiring. Maybe that would be the best plan. I'm thinking about it. We will see. So, but I wanted to do a complete course, you know. I actually wanted to do a complete course where we do everything. But anyway, let's see. I don't have to rush it. My worry is that time is the problem. Okay, so 2.1 is f of x is minus 2x squared plus 1. So we know that the first derivative is going to be the limit as h tends to 0 of x, f of x plus h minus f of x divided by h. Yes, this is boring, guys, but it's mark worthy. So I'm going to not show you laziness. So we substitute x. So this is 2 into, then we get x plus h all squared plus 1 minus into minus 2x squared plus 1 all divided by h. So I have to show you the steps so that you don't say I did not. So I know already here I'm going to have minus 2x squared minus 4xh minus 2h squared plus 1 plus 2x squared minus 1. Of course, I'm moving faster. You have to at some point, guys. You cannot be choking on basics. Simplification of algebraic expressions, you've been doing it since grade 10. So you cannot tell me that you're going to choke on grade 10 issues in this scenario. If you do, you don't deserve to be doing maths. I'm sorry. So this is going to be minus 4x. Okay, my 4 just didn't want to come up. So this is minus 4xh minus 2h squared, all divided by, all divided by what? Yeah, divided by h. Okay. Guys, I'm thinking of other things as I'm going through this. So this is going to be minus 4x minus 2h, all divided by h. Just factorize, okay? Just factorize and avoid issues. So we know that f prime x is going to be the limit as h tends to 0 of minus 4x minus 2h. Now we drop the limit, 4x minus 2 into 0. Therefore, our f prime x is going to be minus 4x. Yes, from the power rule, we expected as much, that this is going to be minus 4x only. So if we get it, we know we are good. Of course, you're using the power rule to check yourself, because you don't want to present an answer that is wrong. You lose marks, guys. 1 mark for this, 2nd mark for that, factorization, dropping the limit, and our final answer. So usually this is the standard number of marks that we could get. Now let's get to 2.2. We've got 2.2.1. So we've got f of x. This time I'm going to write it properly. Okay, maybe let's write it as it is given. So this is 1 over 2 x squared minus 5 over x. Therefore, f of x is a half x squared minus 5x to the minus 1. Remember, we're trying to avoid other issues here. So we can say, therefore, the first derivative is going to be x plus 5x to the minus 2. At this point, I'm not interested in showing you everything. You can explore it for yourself. Get a mark for this, guys, for each of the derivatives. Remove. So we've got 2.2.2. So we've got to deal with this expression, minus 2x squared plus the 4th root of x, all divided by x squared. Okay, this implies that we are doing the derivative of this expression minus 2x squared divided by x squared plus, convert this is going to be x to the 1 over 4 divided by x squared. You can say this implies that we're doing the derivative. Now we know what happens here. This guy takes that guy. So we've got minus 2 plus, we're going to have x. We move this to the numerator, subtract the exponents. So this is going to be x to the minus 1 over 4. It's a quarter, right? Am I right? Let's see. 1 over 4 minus 2. Yeah, it's wrong. 4 by 2, that's 8. So it's minus 7 over 4. Okay. So it's minus 7 over 4. Cool. Now we can say this is going to be equal to, maybe let's even make this a conclusion. You can say therefore dx, this is just going to be minus 7 over 4 x. When we subtract 1 there, it's going to be minus 11 over 4, right? Because if you subtract 1, this is going to be 4 by that. So minus 7 minus 4 is minus 11 over 4. Yeah. At this point, I'm not interested in other issues. You figure it out for yourself. So what do we get here, guys? We're getting 4 marks. So what happened? We get a mark for this. Right? Right. We get a mark for that. Yeah, we don't have a choice. We get a mark for our derivative. And perhaps for this conversion. There should have been 3 marks though, but it is what it is. So let's get our marks and go. Right, folks. So that is how that question is to be answered. Of course, folks, under this circumstance, I may be under pressure. Remember, under pressure, everybody buckles. Although I try to contain the pressure, but I'm not a robot. Even a computer freezes and does miscalculations when the program just fails. So who was I? Even something made to be perfect is imperfect in its own perfection. So if you spot a mistake, don't shy away from, letting us know in the comment section. But at the same time, I would say to you guys, do not focus on the actual answer. Focus on the method of getting those answers, because that's the intention of these videos. It's not necessarily to give you, perfect answers for a particular question. It's just to give you a solid approach to solving problems. And you will see some of the flaws are the common mistakes in any case that you guys go through. And sometimes it's just the silly mistakes that you don't know why they keep coming, but they just do. Anyway, for me, I can justify them by saying I'm thinking a lot of things. So it's easy for me to think of something else than what I'm doing, and I end up just, carelessly putting a value that is not supposed to be there. But for you, you have nothing to think about. You're not someone who works. You don't have a child to take care of. You only have your studies to mind. So you are not at liberty to make excuses. I am. You are not. Okay, let's look at the Northwest. Okay, I can leave this space here, guys, for you to just, enjoy writing some extra notes and doing something by yourself. So let's look at question 3. Now, question 3 says 3.1. We've got f of x is 1 minus x squared. Right, so first derivative is going to be the limit. This is the last one I'm doing from the first principles. You guys can figure out your way forward by doing the rest. I'm just going to focus on the rules of differentiation after this. Okay, so this implies that f prime x is going to be the limit. As h tends to 0, we substitute. This is 1 minus, where we see x, we put x plus h, minus 1 minus x squared, all divided by h. F prime x is the limit as h tends to 0 of 1 minus x squared minus 2xh minus h squared minus 1 plus x squared all over h. So this is going to be the limit as h tends to 0. Of course, the magics must happen. If they don't happen, it means something is wrong. Okay, so we've got minus 2xh minus h squared all over h. So this is the limit as h tends to 0 of h into minus 2x minus h divided by h. Just get used to the habit of factorizing, but don't skip steps, guys. This is the limit as h tends to 0 of minus 2x minus h. We drop the limit, minus 2x minus 0 is going to be equal to minus 2x. Right. And of course, from our power rule, this would have been minus 2x. Indeed. So the answer we got is what we expected. Of course, substitutions, factorization, dropping the limit, and getting the answer. Here's how we score the 5 marks. Okay. Right, so let's look at 3.2 with 3.2.1. So here we need to take the derivative of an expression. Can you see I'm tired, guys? He. Now this implies that we're taking the derivative of 3x squared minus 2x to the minus 1. So we can say this, can make a conclusion. It's going to be equal to 6x plus 2x to the minus 2. Now we don't want to complicate this. We leave it like so. So you get a mark for this and for each derivative. Nice and easy. Now let's look at 3.2.2. We've got y equals the square root of x into the cube root of x minus 5x. Okay. Now we've got a situation y is equal to x to the half into x to the 1 over 3 minus 5x. Therefore, y is going to be x. Now, when we add the 2, what do we get? We're going to get 5 over 6, isn't it? Moving fast, buffet 2 minus 5x to the 3 over 2, right? Right, so I hope everything is doing the things. Okay, we can say therefore dy over dx is going to be 5 over 6 x. When we subtract 1, this is going to be minus 1 over 6 minus, this is going to be 15 over 2 x. When you take away 1, we remain with a half. Good. I hope it's good, guys. But of course, you know what to do here. If I've made a mistake, you correct it. Please. Purisman. Now, folks, because this is a bit naughty, I can freely give you marks there. Or in fact, excuse me, this is a mark. This is a mark. Yikes. We can say for these two exponential rules, you get another mark. Okay. Nice and easy, guys. Nice and easy. All right, so this is cool. Bafethu, these questions are nice, you know. These questions are nice, but I think you need a chance yourselves to get your hands dirty. But let's just pick up the Gauteng one for the sake of 4.2. Please, for this point, I'm going to skip this one. Ignore this one for now. Okay? Ignore this one for now. We will talk about this at a later stage. So I'll just say ignore for now. Ignore Baloyanjan. Ignore for the time being. Don't try to do it, okay? But I'm interested in that 5-mark question. What's happening there? Because I know you guys get scared. Right, you really do get scared. Yeah, I think we are doing fine. Okay, let's leave this one for some notes. Question 4. And of course, guys, I'm not gonna do this one. This is for you to do. I'm only gonna focus on 4.2 this time around. So we've got f of x is 2 root x minus 1 over x all squared. So we don't want brackets. F of x is going to be 2 x to the 1/2 minus x to the minus 1 all squared. Now let's do the FOIL. So we can say therefore f of x is, we square this thing. So when you square this thing, it's going to be 4x. Once we square this, you know what happens. It's just x. Or you can say it's half plus half. It's going to give us 1. Okay? Minus. Now this guy times that, it's basically a half minus 1, which is minus a half. So it is going to be itself to the exponent minus a half. Then we double that. So it's going to be 4x to the exponent minus 1/2. The last one, we square that. It's going to be plus x to the minus 2. Right. So of course, guys, go through the steps nicely, but sometimes develop the muscle to move faster. So f prime x is nothing but 4 plus 2x to the minus 3 over 2 minus 2x to the minus 3. At this point, we leave it here. We don't want to cause any trouble. So obviously, guys, we get a mark, and a mark if everything is good. You know, Moss. Yeah. So what else? We get a mark for our expression. For converting the radical, I suppose. Or even this guy. At this point, it doesn't really matter. I think that guy doesn't matter, but more the radical. Whether we do it later or we do it within the expression, that's literally how that one goes. So folks, that was the only question that was interesting me. So this one is for you to do. I have shown you the skills on how to survive this. This one from the Eastern Cape is for you guys to do. You should know what to do. I've shown you all the skills so far. KZN, again folks, this one is for you to do. I have shown you everything in here. Okay, so do largely this question, but perhaps I want to show you that question because that's where most of you would fail to see what to do. So let's look at question 7. So we're going to focus on 7.3. Okay, so this one was meant to be as h tends to 0. Right, so we've got 7.3.1. Okay, maybe let's first write the expression that is given. So we're told that the derivative of a function, so once we say it's a derivative of a function at point P, what is it? This means it's, if we say this is the function f, it's going to be f prime at what? X at P is going to be the limit as h tends to 0 of 2 plus h cubed plus 1 minus 2 cubed plus 1 all over 2. All over 2. This is okay, actually this is fine, we don't need this. The manner in which it's given, it's complete. So it says the limit as h tends to 0 of whatever we see there is 12, meaning the gradient at P is 12. So we know that this guy is the gradient at P. Okay, so let's have a look, guys. From our first principles, what do we know? We know that f prime x is going to be the lim as h tends to 0 of x plus h minus f of x divided by h. So what do we see there? We see that there's this thing in these expressions, okay? So this must be a term in f. Now what else do we see? Well, we will see there that what is this number here is now a base here. So this must be the replacement for x. And we can already see that this bracket is cubed. So this means where we see anything with h included, it replaces x. Right? And obviously, that x is going to be replacing that number. So we understand that we can easily just write down as they suggest. It says write down the equation of f. F is nothing but x cubed plus 1. Easy 2 marks there. So just inspect and look and see as we have shown each other. So 7.3.2 says a tangent is drawn at P. Determine the equation of the tangent. So we know that, okay, we've got the point of tangency here, pot. It's going to be such that we've got f of 2 because we see the x value is 2 there. It's going to be 2 cubed plus 1. Therefore, this is going to be 8 plus 1. This is 9. So therefore, our pot is going to be 2 is to 9. Good. So we can say then the tangent is going to be y. The gradient is 12. We look for c. So from the pot, what are we cooking? Therefore, C is, this is 24 when we transpose minus 24 plus 9 gives us minus 15. So therefore y is 12x minus 15. Nice and easy. Right, so this is very easy. As you can see, we're getting 3 marks here. So what is this 3 marks? Yikes. It's getting the point of tangency, the substitution of the point, and the final answer. So easy stuff. So guys, practice, 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 practice. Now we're going to get to the cubic function. So this is the end of some basic differentiation business. Now we're going to enter into the cubic function. So as I said, we want to make this easy and understandable. So we're going to do the cubic function. F of x equals ax cubed plus bx squared plus cx plus d. So that is the cubic function in general. That's what we're going to discuss next, but let me take a small break and breathe. Maybe chow something and we get going. Right, so we're going to discuss the cubic function. Again, here we're going to talk about some basic stuff, show you how things work, options on how to work those things, interpretation, all the knowledge behind the interpretation. And then from there, we will then take past exam questions in that regard. And then hopefully it builds your knowledge enough. Remember guys, we can try to be as exhaustive as possible, but we will never really be. There's lots of questions that one can imagine. But I'll do my best to show you as much as I can. And please, whatever I show you, make sure you have got it in the bag. If not, you're going to look for it in the bag during the exam and you're not going to find it. And remember, you need to familiarize yourselves with everything that I'm showing you and practice it in every example that you can find. If you don't find certain questions that I will show you, try to create those questions. As you will see in some of my videos, I show you guys how I create questions and how to then answer those questions. All right, let me take a small break, maybe 30 minutes. Then we're going to discuss the cubic function and take some examples. Then we're going to move on to optimization. And of course, in that topic, I will try my best to show you as many examples as possible. But what is important is to understand a few issues there. All right, let's meet in the next 30 minutes and discuss the cubic function. All right, guys, so we are back. Now let's talk about the cubic function. Okay, so we know that the standard form is ax cubed plus bx squared plus cx plus d. Now there's a few things that we need to understand from this standard form. So when a, the coefficient of the highest power, is greater than 0, we know that the shape of the function is expected to be of this form. Okay, so that is the shape that we expect, meaning between the two turning points, the function is decreasing. but it's increasing everywhere up until those turning points. Right, so that's the first thing that we need to realize. And of importance is that if we look at this graph, by drawing tangents to it, you will see that a tangent at perhaps that point is positive. Okay? So when the gradient is positive, the graph is increasing. But at the turning point, if we draw a tangent, it becomes a horizontal line. So the gradient is 0. Now we're talking about gradients. And we know what the gradient is the first derivative function. So again, if we draw a tangent in between these turning points, we will see that it is negative, right? At this turning point, if we draw, it's a perfectly horizontal line, so the gradient is 0. Draw a tangent, at that line it is positive. So we can already see that there is a trend here that we can see, is that the first derivative function is positive on the first part when a is greater than 0, then it's 0 at the turning point, and it is negative between the turning points. It then becomes 0 again at that turning point, and it becomes positive. So all these positives, guys, I'm talking about, this is the first derivative function, which is the gradient. This is f prime. So try to relate this to the gradient at a point. And we know that f prime is from differentiation, when we differentiate our cubic expression. Okay, that's the first thing that we can say. The second thing that we can say is that what happens when a is less than 0, which is the highest, the coefficient of the highest power. We know that the function is expected to behave in this manner. Let's try again. Okay, so the graph is expected to behave in that manner. Now, what do we notice? If we draw a tangent to this side, we know that it is negative. Of course, this is the first derivative function. At this turning point, perfectly horizontal, that's 0, talking about the first derivative. If we draw it between the two turning points, it is increasing again. It's positive. We draw it at that turning point, it is 0, perfectly horizontal. If we draw it on this arm, it is perfectly negative. And we're talking about the first derivative here. Right. So I hope we understand what is going on. So we draw tangent lines to tell what is happening to the graph at different points. Now, this is fine. So we can already see that if we are looking for the turning points, what happens at the turning points? At the turning points, we know that the first derivative is 0. At the turning points, the first derivative is 0. So this is what we can use to find the turning points of a cubic function. To find those x values, we can use the second derivative. So that's the first thing that we can actually get into. So we can easily say here, therefore, at turning points, we know that for a cubic function, the first derivative is 0. because we know that the first derivative gives us the gradient at a point, and those points are turning points. So we will use our knowledge of differentiation. This helps us to find the x coordinates. Helps find the x coordinates of the turning points. So this is very interesting. Now, of course, how about the intercepts? Well, we already know that for intercepts, with the axes, right, we know that the y-intercept is going to be essentially f of 0, which is going to be d, isn't it? Whatever d is, because d is a constant, it will always be d. So that's the story. But the x-intercept is a different ball game. So we know that the x-intercepts are going to be f of x equal to 0. And we need things like long division, right? Or any variation of long division. Sometimes one may think of what we call synthetic division. Be very careful of the synthetic division, hey? I'll put an asterisk on top. Be very careful of it. It's not as easy. Or sometimes which we can solve by inspection. Inspection, or let's just say two ways. Let me think. Okay, let's start here. So first, the first thing is to use the factor theorem, right? We need a factor. So we're going to apply the factor theorem. This may involve a bit of trial and error. Right? But you've got calculators that can help to avoid this step. You can say avoid with your calculator. Avoid by using a calculator. Okay, so you can avoid the trial and error by using a calculator. But remember, a calculator is good to use, but first understand the concept before we can deal with the calculator. Right. So now, after the factor theorem, we've got a few options now. We can either factorize by inspection, right? Or we can use long division. And if we don't want to use long division, we can also use synthetic division. Now this one is quite a tsunami if you don't know what to do. So I'm going to put an asterisk onto it. So for the x-intercepts, it's a bit complicated. We need a few things. The factor theorem, which may involve a bit of trial and error, or we can avoid this by using the calculator, which I will show you how to do. And of course, we can then factorize either by inspection or by using long division, or it's, shorthand version, which is the synthetic division. So now let's get to work, guys. Let's get to work. Now, that's essentially what we're going to do for the x-intercept. Now, let's think about it. We also talk here about the point of inflection. So the point of inflection is where the concavity changes. Right. So the point of inflection is where the concavity changes. Now if you think about it, remember we had our turning points, right? Now we know that essentially the point of inflection is an average. The x value is an average between these two turning points. So if we decide that point of tangency is our point of inflection, for example, so it means from that point of inflection going to that x value, and from that other one going to that x value at the turning point, those distances must be equal. This means, remember we said when we differentiate, right? If we differentiate a cubic, we get a parabola. So as you can see, those intercepts, those x coordinates of the turning points are essentially the intercepts of the first derivative function. Okay, because we said the first derivative function must be equal to 0. So when we solve for x, we get those x values at the turning points, which are the x-intercepts of the first derivative function. Now this would mean this is the x value at the turning point of the first derivative function. Now, this already tells us that if we're looking at that, this means the second derivative, because when we differentiate a quadratic, we end up with a linear. So this means here, the point of inflection is found when we look for the second derivative and we equate it to 0. Why? Because the x-intercept of the first derivative becomes the x-coordinate of the turning point, of the point of inflection of the cubic function. Right. Now, the issues that arise with this is that one case, we say the graph is concave up when the second derivative function is greater than 0. Okay? Very important, meaning it is positive. And then it will be concave down when the graph has the second derivative less than 0, meaning negative. Okay, so these are some of the issues that, folks, arise in these questions. Very interesting. Very interesting. If I can just go back to the issue of turning points, since we saw that the second derivative gives us the turning points, I want to comment also on issues of the second derivative, but anyway, let's leave it. Now let's talk about the increasing versus decreasing nature of this graph. So the graph, we can talk about increasing versus decreasing. Just want to get these topics out of question. So we know that this graph will be increasing when the gradients are positive, right? Now, what does this mean? This means the first derivative must be greater than 0. So when the first derivative function is positive, it means our graph is increasing in that segment or section, right? Because when the first derivative is greater than 0, it is literally positive. So we're saying this is increasing when the gradients are positive. That is, the first derivative must be greater than 0. Please don't forget this, because sometimes you get questions without the graph of the original function, but you are asked a question about something that you can easily answer using the first derivative function. Okay, so when will it decrease? It is decreasing when gradients are negative. That is, the first derivative function must be less than 0. Again, this is very important. This is related to gradients. Now, how would you know what is happening to the gradients? You should already know now that to check the quality of a gradient, you just draw tangent lines on the graph and you check what they look like. Are they positive versus negative? We're just looking at their nature. We don't care about the values. All right, so this is very important, guys. Now, the last part of this cubic function, we're just going to talk about concepts so far. When we talk about maximum versus minimum turning points. So this is related to the turning points. When do we say the turning point is a maximum? Let me write better. Versus minimum, the turning points. So when do we talk about this? Obviously, guys, if at a particular turning point, let's just say a turning point, let's just say we've got turning point 1, let's just say TP1 is basically A is to B, right? And then we say turning point 2, we've got I feel uneasy. Okay, let's not complicate it. Let's just say turning points such that the turning point is given by A is to B. Right. Now, when will we talk about it? Now, this is in relation to the x-coordinate, because remember, turning points have something to do with the first derivative. So anyway, this is related to the x-coordinate at that turning point. We know that this will be a maximum if, is it if? Yeah, when. Now we talk about the second derivative test. I hope you guys understand. This is going to be a maximum, this turning point, if the second derivative of A, what must it be? When it is less than 0. Now, this is what we talk about. This is what we say. This is the second derivative test. Right? Technically, that's the second derivative test. So if a particular point is a turning point, and you do a second derivative of that x value of that turning point, and it comes up negative, it means that would be a maximum. Okay. Right. So why is it so? Remember, we said when the second derivative of any value is less than 0, what did we say? The graph is concave down. When this parameter is met, the graph is, we know that f is concave down. Now, if this is a turning point, it means the graph is like this, isn't it? So, if the graph is like this, and we know that here we've got x value being a, I mean, you can already see that there's nothing beyond this point. So that has to be a maximum. So that's the maximum. Right? Because the graph is going down. So concave down. So when it is concave down, that's why we say at that a value, the graph will be a maximum if the second derivative is less than 0. Why? Because the graph would be concave down. So it is based on the concavity of this. I hope this makes sense, guys. I know sometimes these terms tend to twist your necks. This becomes a minimum when the second derivative of a is greater than 0. Right? Right. Why? Because of the same thing. We know that when this graph is greater than 0, the second derivative function, but this one didn't come out nicely. Sometimes my writing just changes. Second derivative of that x value is greater than 0. We know that the graph is, we said when this is greater than 0, the graph is concave up, right? So when the graph is concave up, do you see it's something like this? For this x value a, right? So can you see there's nothing below this, so this becomes a minimum. So this is the idea behind all of this business. So folks, there's a few things to consider. Let's just recap, because I know these things are very easy to lose. A cubic function, the standard form is ax cubed plus bx squared plus cx plus d. When a, the coefficient of the highest power, is greater than 0, the graph has that shape, right? And we traced the tangents to this graph, and we know that tangents at any point is the first derivative. So we looked at them. So that tangents on the first part, when it is in the format a greater than 0, they are positive from negative infinity up until the first turning point, when they become 0. Then between the two turning points, they are negative up until they are 0 at the second turning point. Then beyond the second turning point, they are positive up until positive infinity. And now we said, when this is less than 0, it is the shape that we see. And of course, if we trace these tangents, we will see that, well, between the two turning points, this time the gradients are positive, whereas they are negative everywhere else, and 0 at the turning points. So this told us that we can use the first derivative function to then find the x-coordinates of the turning points. Because when we equate this to 0, it literally gives us the x-intercepts of the first derivative. And these become the x-coordinates of the turning point. Right, so that's the most important part. Then we said, fine, how do we find x-intercepts? Well, x-intercepts, we have to equate the function to 0 and literally use factor theorem to find a factor, which may involve error, trial and error of course, but sometimes you can just use your fancy calculators. But always try to practice by using the trial and error method so that it doesn't escape your mind. But then for efficiency in the exams, you may use the calculator. Of course, knowing why you are doing what you are doing, or at least knowing what the calculator is doing. Now we can either factorize after that by inspection, which is much more quicker than to have to do long division. Or a better technique that is relatively shorter as well is the synthetic division. But I will put an asterisk on that because there are some issues with that if you don't know what you're doing. Now we talked about the point of inflection. A cubic graph, we saw that it changes concavity. If you look, one part is concave down, the other part is concave up. So in the middle, where it changes this concavity, we talk of the point of inflection. This is where concavity changes. Now, when does this happen? We noticed that technically this will happen at an average of the two x-coordinates of the turning points. This is essentially the turning point of the parabola, that is the first derivative of a cubic function. So we can easily see that, okay, well, we can easily equate the second derivative function to 0 because that x-intercept becomes the x-coordinate of the turning point of the first derivative. And essentially this becomes the x-coordinate of the turning point. Sorry, of the point of inflection, excuse me. Now, everything related to the point of inflection would be the concavity change. The graph will be concave up when the second derivative function is positive or greater than 0. It will be concave down when the second derivative function is less than 0 or essentially negative. Now we said, fine, we need to also comment about issues of increasing. Now increasing and decreasing, guys, is related to the y values of f. Okay, so this is related to the y values because this is what we are talking about. What is happening to the y values? As you can see, when we say this portion is increasing, you can already see that as we move from left to right, the y values are going up. So literally the increasing thing, it's literally, let me even say literally related to the y values. But in principle, we can use the gradients. So this is literally related to the y values of f. Okay, so the y values are climbing as we increase the x values from negative infinity approaching the first turning point. So that's what we mean by this increasing and decreasing. And of course, when it's decreasing, it means the y values are taking a dip as we move from left to right, from one region to the next, okay, or between 2 points. Now we said this graph is going to be increasing when the gradients are positive, or this is when the first derivative function is greater than 0. So this means we can use the gradients as a surrogate if sometimes we're not too sure, especially when we don't have the graph of the original function. We can predict this using the first derivative function. Then they are decreasing when the gradients are negative, and this is when the first derivative function is less than 0. So this means, again, we can use the gradients as a surrogate when we don't have the actual graph where we can see what the y values are doing. All right, so that's another issue. And then, of course, we will never finish if we don't talk about maximum and minimum turning points. So once you say maximum and minimum, this is related to turning points. Now, let's assume that in principle or in general, we've got a turning point A is to B, right? So we know A is the x coordinate. Now we said this graph F will have a maximum turning point if the second derivative, remember this had something to do with concavity. So when the second derivative is less than 0, we know that the graph should be concave down, meaning at that turning point, we will not see the graph above that turning point, essentially, in that region. So this means this should be a maximum. In fact, we call these local maxima and minima because they're not true maxima and minima. So there's a qualification there that needs to not be forgotten. These are local maxima and minima. Why? Because if we look back, you will see that as much as we're limited here in this first stint, but the graph actually does go beyond this point elsewhere. So this is why we call these ones local maxima and minima, because they're not true maxima and minima. Okay, I hope this also is clear. And then, of course, we said if we say that turning point is a minimum, is when the second derivative of a, that x value of the turning point, gives us greater than 0 for that function. Why? Because we know that when the function is concave up, it has a minimum value at that turning point. All right, folks, so this is the basis of optimization already. So I hope we are on point. Excuse me. So I'm going to leave this space for you guys to write some notes. Now, let's start with some serious issues. Now, folks, if, for an example, this is a special case. If, for an example, we've got f of x is equal to ax cubed, and there's nothing else. And, of course, we've got a greater than 0. So what would be the graph expected to look like? It has what we call this type of a function, the mother function. This is the cubic function you should have been studying grade 10, right? Of course, I don't remember us drawing the graph, did we? I think we did. Yeah, we did. This is the graph we drew in grade 10, standard 8, we said. I don't know if you still do, guys, but of course, this one we needed to just use points. We just give some random values for x using integers. Then we put it on the rule, use our calculator to find the corresponding y values, and then we follow the shape that we get. I don't know what you do nowadays. So this is what we call the mother function, or sometimes we call it the parent function. This is the beginning. Everything else is built from here. So what would it look like, guys? So what is expected is that, of course, if a is greater than 0, the graph should be increasing. But it increases to some point That would be the inflection point. And then, of course, what I normally do, I just do this with my good stuff here. So this graph would be doing more or less stuff like this. So this is the shape we expect. So when we have a mother function, this is what we have. So it only has a point of inflection, but no turning points. Right. So this means the graph before this point is concave down, and the graph like that is concave up. So what does this mean? It also means that this first derivative function equal to 0 is undefined. Right? So you will see that when the first derivative function equal to 0 is undefined, we end up with just the point of inflection. I hope we understand each other. Okay. Yeah, that's the very important thing. And then, of course, guys, we can talk about, okay, let's just take this and hoy it here. Right, let's hoy that there and say that's what we're going to expect. But this piece actually belongs there. I just don't want to end up saying a lot. So that's the mother function, and the shape that we expect is that. And then, of course, when a is less than 0, what do we expect? The graph is going to approach our point of inflection like so. And yeah, guys, kuyafundwa manje akudlalwa. Late makunje. Akudlalwa. Again, this is the point of inflection, POI. Okay, so in these two scenarios, I'm saying POI is the point of inflection. Nice. Just so you are not confused, what is boy? I say boy like Lokshin Dal. All right, so this is cool, guys. So that's essentially the story that you can say about the mother function, and everything else becomes a horizontal shift of the mother function, a vertical shift, or both horizontal and vertical shifts. This is when we get the typical function like we spoke about here. These kinds are the shifted mother function. It's either shifted both in the horizontal and vertical axis or in one axis. So you will see what actually happens. All right. Excuse me, guys. Now, you may also want to perhaps create a cubic equation, because from here you can actually do it. But of course, others may not necessarily, work the way that you wish, because others are just purely composite functions of other functions, a cubic function and another. Then we end up with a composite function. So I would love to indulge you here on how to create this so that you can appreciate what happened. Although I'm not going to exhaust everything, let's just say we are creating. So I need you guys to be also creative. Remember, we don't teach you guys to be robots and rattle this thing. You're just creating. Creating cubic equations. I'm just gonna say equations now, or let's just say cubic functions. Remember, when you study your craft, guys, you take your time, you don't rush. Hey, I can say f of x is equal to, we can just say, let's just say f of x. I hate it. Okay, let's just say f of x is gonna be x minus 1 all cubed. Let's just take a perfect cube. Okay, so what do we get? F of x is gonna be x cubed, right? Then what happens after that? Okay, by the way, a difference of, hey, conjugating land. Hey guys, I forgot these things. Hey man, conjure, what do we do here? I forgot the theorems now. Yo, how can I? I just revised these theorems, conjure. We cube this one and then okay guys, it's fine. Let's just go about it the ugly way, because sometimes, you know what, we will remember though. Just bear with me for now. So we're gonna take this one and say fine, it's gonna be x minus 1 into x minus 1 all squared, right? That's what it's gonna be. So f of x is gonna be x minus 1 into x squared minus 2x plus 1. Therefore, f of x is x cubed. Now we're going to say that it's going to be minus 2x squared minus x squared is going to be minus 3x squared. And then what do? We're going to take the x and multiply. There's going to be x. And then this 1 times that is going to be 2x. So this is going to be 3x. And then Huirahalang biano. Huirahalang. 1 times 1 is 1. So do you see we've got our cubic function in standard form? Can you see we only got it when we transformed this graph by 1 unit to the right. So we took f of x, perhaps must have been g of x is equal to x cubed. Then when we transform this by 1 unit to the right, we saw that we get our typical cubic equation. B, I'm not going to go beyond the second example. So of course, guys, if you want to remember the rule now, you will see that you cube the first, right? And then you multiply this to that, right? It's going to be minus x. Then you square it, right? And you multiply it by 3. So you get that 3x squared. And then, of course, the other one, you multiply this by that, it becomes just minus x, and then you times it by 3. There it is, right? But I'm not sure if I'm saying the right thing, but yeah, whatever, guys. It is what it is after all. We will remember these rules, but go and revise. I cannot teach you everything in one video. Now let's take a second one. This one is going to be a composite function where we have another function perhaps added or subtracted. So we can say, well, this could be easily x plus 2 all cubed plus x minus 5, for example. So can you see I'm adding a linear function to this, sometimes to create some different equations. Of course, you can add or subtract another function. It could be a parabola, it could be anything, okay? So let's go for it, folks. This is going to mean f of x is equal to, let's see if this is going to work, that rule. We're going to say this is going to be x cubed. Just want to see if it's going to work. Sometimes you check yourself even during the exam, you know, sometimes it's easy to forget, but basic ways of handling business, you just try. I'm going to say x times 2, this is going to be 2x, right? But x we square, then we multiply by 3. So this is going to be plus 6x squared, right? And then we multiply this by that, it's going to be 2x times 3 is going to be plus 6. And then we're going to say 2 cubed is going to be plus 8. And then plus x minus 5. Let's just check what we just did. This one is going to be x plus 2 into x squared plus 4x plus 4. This becomes x cubed plus. This times that is going to be 4x squared, right? 2 times that is going to be 2x squared. 4x squared plus 2x squared is 6x squared. And then x times that is 4x. 4x, ne? X times that is 4x, and then 2 times 4 is 8x. So 8x plus 4x is 12x. Okay, I completely missed it. 8x. So it goes to 12x. So wrong. Okay, and then the last one is going to be plus 8. Okay, we kind of messed up the second one. So see, the rule didn't come back nicely there. Something is not right. We will talk about it and see what else to do. I think the first one, we square the first. We just say this squared times 2, then times 3. It gives us that. The second time, we say this one squared. I think that's how it goes. Yeah. First, we say this cubed. Ne? Second, we square this and then we multiply it by 2. Then times by 3. It gives us 6x squared. Third, we're going to say this number squared is going to be 4 times x is 4x times 3 is 12x. Yeah. Yeah. So this should have been 12x. Okay. And then we cube the last one. So basically the rule, now I remember, if we have, just remember the rule. If we've got a plus b all cubed, the answer is going to be a cubed plus 3a squared times b, right? Right. Plus 3ab squared plus b cubed. So that's the rule. So that's something to remember. Can you see? You can remember it by just doing some basic calculations, basic works. They should be able to take you home. Okay, so now let's conclude our function. You can say therefore f of x is x cubed plus 6x squared. So 12 plus x is 7, it's 13. And then 8 minus 5 is 3. So that would be the function f. As you can see, some functions are composite functions, others are just simply perfect cubes. Okay, so that's as simple as that, guys. So I just wanted to show you a bit of the creative side of things so that you can understand how certain things have been created. How did we end up where we ended up? Okay, you know, all those kind of things, folks. And you can see that technically here we equated two functions, right? Because once you get a composite functions, it means two functions were equal or they had a point of intersection, right? For example, the other function would have been minus x plus 5, whereas the other one is the perfect cube. So when you move that to the one side, you know that x becomes positive, the plus 5 becomes negative. So you should already see that composite functions are achieved when we equate two functions and then we move everything to one side to write it in standard form. So I want you guys to have this in the back of your mind so that as we solve these problems, you can start to see some of the patterns that sometimes will give you information as to how it came about. So now we're going to stop with the creativity. How guys, kanti ke kwathini la? Oh, siyasayifaka phakathi nendawo. Kodwa befanele uba siyifake last ke le yona. This was meant to be the last thing ever. Qha ke ngoku ndiye ndacingela uba sesigqibile. Eish. Qhela kabi nale we. Ya man, bendiyifuna apha le nto le. Kimoki batlang. So be creative, bafethu. Don't be robots. Don't just waste your time on your textbooks and just study the stuff that is there and then that's as far as you would think. No. Play with the knowledge that you have already acquired so that your brain is just as wild as a Mustang in the US, isn't it? A wild Mustang. If you become a wild Mustang, you become what we want. Okay, a true scientist. Someone who studies as they learn, you understand? Yeah, sometimes you study during the exam. As you can see, I forget some of these rules, but as soon as you think about what you are doing, you can already read the rule from what you are doing if you understand your basics. All right, guys, I think now we are coming down to example 1 of the cubic function. Of course, folks, I'm only going to draw one graph from basics, okay? And then we're going to do the rest from past exam question papers, okay? I cannot show you everything that I wish, but I'm going to try from this very first example to ensure that we do everything there is to be done, okay? I'm going to make sure that we do everything there is to be done. Maybe we want this guy. Is it gonna work? Is it not gonna work? You see, sometimes I don't want graphs that won't work. I'm thinking about it and I'm like, let's see. It's not gonna do me good. It's not going to do me good. Okay, let me just try and find a nice example. All right, so let's say draw. Okay, let's just say given f of x is equal to x cubed minus 6x squared plus 9x minus 4. Right. So this is what we are given. So there's a few questions we want to answer. First, says determine let me write better. Let me just try and relax, okay? Determine the x-intercepts of f. Okay, so we're going to do this question by question. Answer. What are we going to do? We know that f of x must be equal to x cubed minus 6x. Man, what am I doing? We know that f of x must be equal to 0. So this implies that x cubed minus 6x squared plus 9x minus 4 must give us 0. Now folks, through trial and error, we want to check. Now remember, this you must do on your rough work. You don't have to do it on the main you don't have to do it on the main business. Ne? So from our rough work, we check what is cooking there. You don't need to show the checking. You just show us what happened. Now, let's see. If we put 1 in here, so this is 1 minus 6. This is going to be minus 5. Minus 5 plus 9. It's going to be 4. 4 minus 4 is 0. So we can already see that f of 1 is equal to 0. Of course, you can just do it on the calculator, but you just guess a value. So in this case, you already know that this concludes that x minus 1 is a factor of f. So this is literally the factor theorem. Right, so when we say factor theorem, when we substitute a value for x on a function or an expression and we get 0, we call that a factor. So it's part of the factor theorem, meaning the remainder must be 0, right? Because when something goes easily, let's say 2 goes to 4 and there's no remainder, right? Meaning there's no decimal, then you will see that there would be 0. So after this, we take our factor and we hoy it there. So this is x minus 1. We know that the other factor is going to be quadratic, isn't it? Why? Because we saw when we created our perfect cube, one factor is quadratic, right? The highest exponent is 2, while the other one is that. See, again, we can create a cubic equation by applying a product of two functions, a linear and a quadratic. That's another way you can do that. It can be a product of two functions. Yes. Siyafunda namhlanje ne. Hey wena hana ke mang? Wena Lesego. You woke a dead beast now. You woke a sleeping beast. Now for me to get a minus 4, obviously guys, I'm making a mistake. Now if we factorize by inspection, we're going to say, fine, if this is x, this one must be x squared, right? Because we know it has to be quadratic. Now if I've got minus 1 and I need minus 4 overall, so this must be plus 4, isn't it? So that when I multiply this minus 1 and this, I must get that. When I multiply this x and this x squared, I must get that. Now, I can choose to focus on this one. I'm going to show you two ways here. If I focus on the 9, now I'm going to say this x will multiply that 4. Gives me 4x. but this 1 must multiply some number here. This number, whatever it is, let's call it b. Whatever b is going to give me, in fact, let's say bx, right? Whatever that bx must be, so I'm going to get essentially minus bx. Let's just say so. Let's say this is a plus bx. Remember, when you don't know the sign, you put a plus. So if you put a plus bx, what must I multiply that with so that when I add, I get a positive 9? So this already tells me that this number must be negative, so that this negative makes it positive. So this must be a minus bx. And now, once we multiply that with a 1, we must get some positive bx. Now, these two, we add them together. So it means bx plus 4x must give me 9x. So this means bx is going to be equal to 5x. Ha ha ha. Interesting. So this means there I must have minus 5x. Right. So the job is done. Okay, guys, you don't need to do these equations per se, but I'm just showing you the more crude way of doing it, but you can do it smartly in your head. So fine, if I wanted 9, I already have a 4x. I need a 5x. But now this one must match the sign. So if this is negative, it also must be negative. So that is sorted. And we can factorize further the second one. So this is going to be x into x. So this must be minus 4 minus 1. Now we see there's a repeating root here of some sort. So we can say therefore x is equal to 1 or x is equal to 4. You can just say therefore x-intercept such that we've got 1 and 0. You can just even indicate that there's a repeating root here. And we've got 4 and 0, isn't it? Because the y value is 0. But bear in mind, there's a repeating root. Now, what happens when there's a repeating root? This is very important to note. Of course, guys, you learn these as you solve. Once you've got a repeating root, it means the x-intercept is also a turning point. Essentially, it becomes tangential. Or we can say the x-axis. Are tangential to the graph at x is equal to 1. So these are things, folks, you need to know. That if there's a repeating root in your graph, this means, 1, that x-intercept will also be a turning point. Maybe let's write it properly so that you know. Okay, guys, maybe I'm too relaxed. I don't know. I'm feeling like I'm not moving as fast as I want. But I want this knowledge, guys, to really sink into you, because these skills I'm not going to repeat again. So since we wanted to create a course, we might as well know what is necessary and how to play with it. So this becomes a turning point. This means that the x-axis become a tangent to the graph at that x value. Again, these are some of the wordings you would be given And you should understand that when we say the graph is tangential, the x-axis are tangential to the graph at a point so and so, it already tells you that that's a repeating root. So when you write it back into the expression, you're going to write it with this one as x minus 1 all squared. You must remember this. If you forget it, you are dead. I promise you. And I will be the first to kill you, even from a distance. My hands are going to reach out of the screen, grab your neck, and squeeze the life out of you. And by the way, I am a witch doctor who is also a doctor. So I can do it always. I can bewitch you to come to the hospital and then I finish you off. Okay, so don't try me. You're going to be in trouble. Get loads hair. Why? Now let's talk about long division. Because guys, you need to know it. You won't survive exams like the NBTs if you don't know this, dude. Oh, but of course, folks, it all starts with the factor theorem. You cannot avoid the factor theorem. So what have we found to be the factor? I'm just going to go for it now. So this is x minus 1. So this is what we call a divisor. The factor becomes the divisor. And then the expression that we are trying to divide is the dividend. Know these terms. This is mathematical language. It's not gibberish. So do not try me. I will be angry. So how do we do it? We ask, how many times does x go to x cubed? Or you can say x cubed divided by x. This is going to give us x squared. Now whatever you get, guys, you multiply first to x, so we get x cubed. Secondly, you multiply to the number, we get minus x squared. Of course, you write it underneath the x squared, something that looks like it. There's a negative hovering around. So when you bring in that negative, this one goes to 0. You don't write the 0. Then this one becomes positive. So minus 6x squared plus x squared is going to give us minus 5x squared. We drop the next term, 9x. Again, we do the same questioning. How many times does x go to minus 5x squared? Or you can say minus 5x squared divided by x. So the leading term of that binomial. So, well, it's certainly going to be minus 5x, isn't it? Do the same, minus 5x times x, it's going to be minus 5x squared. Minus 5x times minus 1 is going to be plus 5x. Again, there's that negative hovering around. Right, so this goes to 0. You don't write it. This one becomes minus 5x. So 9x minus 5x is going to give us 4x. We drop the last term. So it's going to be minus 4. We ask again, how many times does x go to plus 4x? It goes how many times? Plus 4 times. Then 4 times the first is going to be 4x. 4 times the second is going to be minus 4. Again, there's that negative hovering around. For the last part, there has to be nothing. If you get a remainder, then it means that guy is not a factor. So for this dude to be a factor, the remainder must be 0. Okay, that's when we said if you substitute by 1, you must get 0, meaning that 0 means the remainder would be 0 if you divided that expression by that. Meaning it goes nicely. You get some number, a whole number. You don't get decimals. Once you have a decimal, it means you've got a remainder. Nice. So what were we looking for, guys? We were looking for this factor here. This is the second factor. Because our remainder theorem, whatever you call it, we know that our dividend, from here we know that our x cubed minus 6x squared plus 9x minus 4 is actually the product of these two factors, because the quotient and the divisor, when you multiply, you get the dividend. So wasn't it what we got? Yes, exactly. And you can take it a step further if you like and say x minus 1 into x minus 1, x minus 4. Fact of the matter is we have fully factorized our expression. And from here, knowing that this must be equal to 0, you do your thing. So all I was just trying to show you guys was how to get the factors using the factor theorem and long division. So you've got the gymnastics now. And you'll see in the NBT course that's coming up today that the long division I'm showing you becomes a nice model when you've got big numbers that you can't handle without a calculator, and you break it down into numbers that you can handle in your head. You can still do the long division there. And some people are going to be praising you. Yeah, this one's a genius. You just think about it and you do it. Now you're actually doing long division in your head. All you need is just the concentration, the attention, have the steps going down. I used to solve these in my head when I was you. Now I can't. There's too many things that are interfering with my brain. And maybe I chose to relax a bit as well. But I would go crazy if I could do it all. I would be mad. Trust me. I am already feeling mad right now. I don't feel normal. Now, folks, there's a third technique that you folks need to know. Or, there's what we call a synthetic division. So this one, I would reverse the long division. Now, what do you put? Of course, it all starts here too, in the factor theorem. But this time, you focus on the number that you added to get 0, or the number that you substituted for x to get 0. You take it as it was there. Now what we do next, we look at our expression there. We take the expression as it is. But now we focus on the coefficients. The x cubed had a 1. So this was a 1. The next term, you take the sign and the coefficient, so minus 6. The next term, you take the sign and the coefficient. The next term, you take it as it is, the constant. So you take them as they come up, but we use coefficients here. Use coefficients only. Okay, right, from the original expression. Now we always let the first one through and put it down there. Then we say this number times that number, right? This number times that number gives us 1. So this is a positive 1. So we put it underneath the next term. Then we add the 2. Minus 6 plus 1 gives us minus 5. Then we say minus 5 times 1 gives us minus 5. We then add those two. Plus 9 minus 5 is plus 4. Then say plus 4 times 1 gives us plus 4. You add those last two, you get 0. If you don't get this 0, it means whichever number you used here is not essentially a factor or an x-intercept. Because the last part tells us about the remainder. As you saw, the last thing in long division is the remainder. So this is the last thing again. So this is again another technique. As you can see, it's much quicker than you would do long division and sweat and die. Now guess what? These numbers here, the first is the coefficient of the highest power. Remember the second, or the quotient here, because this is linear, the quotient is going to be quadratic. So this is x squared. This is the coefficient of the highest power, x squared minus 5x. Minus 5 is the coefficient of x, and 4 is the constant. Right. Now, this is the factor that you were looking for, the quotient. Essentially, you can then come back and say, therefore, we know that x cubed minus 6x squared plus 9x plus 4 is going to be, think of the factor this time. The second one is x squared minus 5x plus 4, and of course you can take it a step further. Right. I just moved too fast for you there. But the key, or the main reason for us to go through all of this, was to fully factorize our cubic equation. So now, folks, I've shown you all the techniques that you can use to find the intercepts of a cubic function. And as I said, I recommend the inspection technique. It's quick. I also recommend the synthetic division. It's quick. But I fully recommend long division. Remember, guys, we need to sit with concepts, the original. We cannot take fake things and pretend we are good. I mean, there are people who buy cheap things and then they pretend those things are rich. They brand them and do all things. And again, do you know that the very rich things you guys are so much after are actually cheap things, but they just got branded so that you can foolishly buy them thinking you're buying quality. Anyway, human beings will always be stupid after all. I'm one of them. I'm very stupid because, I bought an expensive car. Now it's chowing me an arm and a leg to fix. I bought an expensive bike. It's chowing me an arm and a leg to maintain and to fix. Although I enjoy them. So, if you get something out of something, doesn't matter what it is, I guess so. But try to be reasonable to yourself, though. Don't choke yourself with things that you don't even need in your life, because you're not going to die if you don't have them. And if you ever want to be rich in this life, do not waste your money on cheap things, because those are just fake nonsenses you are spending your hard-earned money for, only to remain poor. No, man, don't do it. Rather, first become stinking rich. Wherever you are, you smell money. Even from a distance, you just smell money. Then you can do whatever you want with it, because, what's the point of having a lot of money if you're not going to enjoy some luxuries it can buy you? But at the same time, there's good causes you can spend your money on, rather than to waste it on things that, if I was to be rich, I'd surely open an academy, teach people things, have them taught things in the best way possible. We can even defy the rules that have been made to constrain your thinking, to make your thinking as wild as a wild horse, because we want you to run to the limits, guys. That's the goal. Otherwise, why are we doing this? Because, come on, everybody for themselves after all. But we're pushing you because we know we're going to leave children behind. You guys are going to be the custodians of knowledge to those kids in the future. So technically it's an investment. I'm telling you. Right, folks, that's about the x-intercept. Okay, we are done. So we've answered it long ago, but I was just showing you the techniques to go around. Of course, I'm just breathing as we do this. B. The second question says, find the coordinates of the turning points. Of the TPs. Excuse me, guys, I can't write. I hate to write. I could have easily typed these things anyway, but yeah, whatever. So this is where the differentiation comes in. That's why we did differential calculus. This is where it comes in. So we know that here f prime x must be equal to 0. Why? Yes, at the turning points, the derivative or the tangent has a 0 gradient. Now let's differentiate. We know first of all that our f of x is, now there it is. Let's just differentiate, guys. So when you differentiate this guy, what do we see? We know that this implies that we've got 3x squared minus 12x plus 9 is equal to 0. This is divisible by 3, so this is going to be x squared minus 4x plus 3 equal to 0. Always simplify things enough to do the gymnastics. Otherwise, you end up falling into the trap of a quadratic formula, which is going to waste your time, and you might actually make a mistake. Factorization for me is perfect. It avoids unnecessary mistakes. So we can see, guys, that x is going to be 1 or x is 3. Look at that. What did we say? The repeating root. The repeating root. Do you see? We said it. That x value will also be the x coordinate of a turning point. Right, there it's coming up. Now what do we do next? We can say then f of 1, we already know it's 0 because it was an x-intercept. F of 3, you may want to go and check. Now I'm going to do it on the calculator. But of course, guys, I'm not going to show you the substitutions. I am not interested. Okay, maybe let me show you. Hey, I know you guys. Sometimes we always assume you guys know or you can follow, only to find that, yay, nina anilandeli kwasanix. Niyabona nje. Amabhunga yes. Mhlambe nibona nje amabhungane nje uthi hayibo sekwenzeke ntoni ba. Right, masinganibonisa amabhungane ke bantram. Sinibonisa mathematics ayisandle subject kodwa kama cry nice lento le. Kamancamnce amanandi nice. Ongayiqondiyo le ndaba ndiyamsizela. Ulihlwempu lengqondo. Yeah. Mathi xa unengxaki nawe uzazi uba ulihlwempu apha engqondweni. Anditsho uba ulihlwempu apha ebomini, ndithi ulihlwempu engqondweni, undive kakuhle. Singaxatyaniswa ngumoya. So therefore turning points is 1 is to 0 and 3 is to 4. Es klaar. Es klaar. Now, folks, I didn't show you how the marks are done, but anyway, let's just leave the marks for now. It's not a big deal. We'll talk about marks when we simulate an exam. Right. Yo, guys, this lesson is super duper long. I'm tired. It's already 5. But I didn't relax. I got cool. What I've been fun is bambi listen to, guys. You have to. Then Dianikopa, kyalikopa, nianikombela, minikombela. Kahle. Wawan? Yeah. Don't you be sifuna kanene? Next one. Draw the sketch graph. Yeah. Draw the sketch graph of f. Yeah, let's just say draw the sketch graph of f. I'm not going to say a lot. We've done what we need to do, so we just need to complete. We just need to complete the dot. You see, most we've got the dot in the dots. Right. Now we know that this graph is doing the things. So at 1, there's a situation happening. So of course we're going to approach let's just assume our 1 is over there. So so this is 1. So we know that our graph is approaching 1 from negative infinity. By the way, lapho wethu positive or negative? Negative. So this means our y-intercept is negative. I'm not going to show you how to find the y-intercept. You should know. Okay, diazilibiza papela. Okay, Asia. Hisala, esanaso, osanaso, osadaso, sala. Yes, it looks funny. What I gave a face. So this sketch, Muslentolena, is not accurate. That's F. We know that this is 4. Let's total 4 one. Yeah, we got 4. So there we have it, guys. There we have it. That intercept is at 1, and we know that the y in tones is at -4. At this point, don't worry about the scaling factor. If you show these things, yeah, izosichana ngokomthetho bekufanele uba ingabinji. Yeah, sendiyayibona ingxaki yam uba izobaphi. Ndiyijongile. You see, the y-intercept is at the same level as our turning point. So let's try and see what we can do. In fact, let's just draw a line that we can get rid of. So always try your best, guys, to do a perfect, did I say perfect? A near perfect sketch. You must, by all means, do a near perfect sketch. Ayikuyabona ngasengiqhela wena man. Sike wantlwaela wena man, o batla ho nketsang jwale. Hayi wena man sengiqhela. Sukundiqhela man, ihlika man, ihlika. Yehlika tyhini, awufuni ukwehla. Ufuna ukwenyuka ngoba kwenze njani. Hayi sizamile bafowethu, sizamile. But sekethetha isiXhosa ngudiniwe. Eqonda mas into okuthetha hours and hours, guys, is not normal. Now we know there that we're looking at 3, and this one goes there, okay, to -4. If you like, you can write the coordinates there. I hate to write coordinates like that, you know. I feel the sketch gets dirty. I don't want it to be dirty, so this is the one, guys. The graph is done. A sketch is not drawn to scale, but it must give the information needed. Siyigqibile, guys. Siyigqibile. Hayi, sendiniwe futhi ngoku. Ingathi asizolasta ntwana yam. Okay, masiye kujikeleza. What was the next question? Now, folks, we're gonna get some interpretation type of questions. We must get the interpretation. Nikarele sweswi. Kanje sobuza uphi umbuzo ngoku. Where. Let's start with the silly questions. It says, for which values, sometimes they say for which value or values of x is f concave down. Right. So, for which values of x, value or values of x, will the graph of f be concave down? So we already know that, well, we need to find the point of inflection, right? Where is the point of inflection? We know that it's going to be the average of these two, right? Because the average of the turning points is going to give us that. So we can just say, well, x must be less than the x value of the one turning point plus the x value of the second turning point divided by 2. It's an average, right? Because when you've got a graph, why suffer? You can say, therefore, x must be less than, okay, maybe let's just go through it. Of course, this one, you can do it however you choose. Answer only if you want, or you do it. So the first one is 1 plus 3. The average you add and then you divide by 2, right? So therefore, x must be less than, this is 2. Answered. So an answer only is accepted here because you may get 2 marks for the answer only, or we can split the mark if you've shown the steps and the question allows you to do so. For example, let's say the question says calculate. Now, when you have to show a calculation, you don't have an excuse, right? Now, you can also use the knowledge of the function as we said. We said the graph is going to be concave down such that the second derivative is less than 0. Right? That's the principle. Now, the second derivative, we just differentiate the first derivative. So when we differentiate this, it's going to be 6x minus 12. Less than 0. Right? And then we solve. So 6x is less than 12. When we transpose, the inequality doesn't change. Therefore, x is less than 2. Again, when we divide by a positive number, the inequality stays. So you could use the principle, or you can just use the turning points. Again, I'm showing you 2 techniques to handle a question of that nature. Now, you can answer for me this one, E, for which value or values of x is f concave up. Right. Tell us, comrade. This one is for you. I'm not going to answer f. Okay, why not? You can just say x must be greater than 2. Isn't it? Yes, that's it. F. Now I want a question also on f. You can say for which value or values of x is f increasing. Nice and easy. This is a very nice question. So when do we expect this graph to be increasing? Now this one is going to be a bit tricky. Yes. It's not that tricky. We just look at the graph. When do we see tangent lines? So if you draw a tangent, for example, here, you can see it's positive. So when it registers positive tangents, then it means the graph is increasing. At the turning point, the tangent has a gradient of 0. Now we're talking about gradients here. And then this time is decreasing, so this is what you do. It's going to be negative. At the turning point is 0. The tangent elsewhere is going to be positive. So we can already see that, the turning points are the critical values for this. So this means x must be less than 1 at the turning point, or x must be greater than 4, not 4 but 3, excuse me, the other turning point, because it's 0 there and then it immediately becomes positive, 0 there, it immediately becomes negative. In between, the graph is negative in terms of the gradients, so that means it's decreasing. And as you can see, the x values increase between 1 and 3. The graph is taking a dip. Right, so easy stuff. So when you use the graph, guys, this is the quick answer. No issues. But another student may be like, no man, I know my maths, so no one is going to tell me anything. Hayibo. So yadelela we-student, sijwayela kabi ngiyakubona. Or the other way, you can say the first derivative must be greater than 0, isn't it? Because we said when the first derivative is positive, then we know. Remember, the first derivative means gradients or tangents. So what is it? We saw that this was 3x squared. 3x squared minus 12x plus 9 greater than 0. Ne? Yeah. So we saw that we can divide by 3 first. It's a positive number, so we get x squared minus 4x plus 3 greater than 0. The inequality doesn't change. You factorize. Right, now what do? Either you use the graphical method or you use whatever comes to your mind. Graphical method is the quickest, provided there's a deep understanding of these functions. So I already know that my axis of symmetry is going to be positive because my roots are both positive. So my turning point is positive, my y-intercept is positive. So I've got a function that behaves like this on the Cartesian plane. Right. So this is the critical values. This is 1. This is 3. Okay. So when is this graph positive? It's positive over here for all these x values. This graph is positive, and for all these x values going to positive infinity, that graph is positive, right? In between, it's negative. So I don't want this. I want these x values. So where are those x values? Therefore, we write x must be less than 1 or x must be greater than 3. Nice and easy. So you can already appreciate that the inequalities you are taught in algebra or that you do in algebra are your friends here. So you also need to know this because sometimes it gets so hot that you need to get to this. I don't know why. I was just wiping the screen, you see. But now it's taking a screenshot. So you can see, guys, you can use algebra inequalities to sort this out. Because your maths cannot be forgotten. Ne? It cannot be forgotten. Right. Now, folks, here's the other question that you need to answer for yourself. This one is weak now because we already spoke about it. F, G, for which values of x is f decreasing. Sometimes you'll hear the word strictly decreasing and things like that. Okay, whatever. But anyway, let's leave that for later. So of course, guys, if you know, you know. If you don't, you don't. So we said the answer here should be less than 3, greater than 1. Done. If you don't understand how it came about, you are a dead fish in the pond. So you can see there, if we use that sketch, this is when the first derivative function is negative, isn't it? All those x values give us that, if you wanted to use the inequalities. Right. So this is when you chose this technique. First derivative must be less than 0. Right? So this means whatever we found, x minus 1, x minus 3, must be less than 0. So x is trapped between the critical values there. Otherwise, we can use the graph and say, look, when did we see negative gradients? We saw them between the turning points. So that's the decreasing section. Right. Now when we start talking about issues of strictly increasing, strictly decreasing, yay. Politics, the politics. All right, guys, now, right. Okay, all right. I think we are creeping towards those fancy questions. Now we're going to creep into those higher grade questions. Do we have space? So I'm going to ask again, for which value or values of x is f of x less than 0? When is f of x negative? We look at that graph and say, hey, wena tlakwana, re batla ho shebella haufinyana mona. If we look at our graph, guys, you will appreciate that this graph is 0 there, and then it's negative here. So it's all from negative infinity until that x-intercept, right? But past that, it's still negative up until that turning point, and then it's negative again. So literally, this graph is negative from negative infinity, excluding 0, because 0, it's neither negative or positive. And then it's negative again up until that don't. So how are we going to write this, guys? Well, I can choose to just take it from negative infinity up until 3 and exclude 0 if I like. So I can just write my answer like so and say, well, x must be less than 4, greater than negative infinity, where x is not equal to 1. Because at x is equal to 1, the graph is not negative. Ne? Yes, you can do that. Or one can write x must be less than 1, greater than negative infinity, right? Or can write x must be less than 4, greater than 1. That's another way. I used to know how to write this infinity business. Now it's starting to irritate me. Sunqhela wena. Sunqhela. Zoqhelwa into engathethi. Right, so you can write it like that, guys. Of course, some of you like the interval notation. At this point, I'm quite interested. Aban, akunataba le ntho eo. Ko file fela nna dintho tsaka. Ko file. Or, how would you do it? How would you do it? How would you do it? Actually, masiyithathe le question ibalulekile. Let's come on, man. Yara doch. Diliga. Diliga ntaba sibonane. Diliga ntaba sibonane. How else would you have done it? Yes, f of x less than 0. Now the factorized form, guys, x minus 1 all squared into x minus 4 less than 0. So you'd have to factorize. Now you've got options, Buffet, but the best option here is the Tafel Matot. So you're going to have x minus 1. Okay, let's just do the Tafel right underneath. So you would then have x minus 1 all squared, x minus 4, fundi maths ngoku, guys. Hlalwa late xa kunje. Akukho mnandi kubi. Betata. So we're doing a product. So we list these in ascending order. Now we ask, this is a perfect square, so it's always positive, right? Or it can be equal to 0. Do we really need to think about that? Okay, all right, okay. I think there's a portal la. It is 0. And then it's positive everywhere else. I forgot that. Now this one is going to be 0 there. And positive one side, then this side must be negative. It's a linear expression. So the product is negative. Product is 0. Product is negative. Product is 0. Product is positive. So we want it to be negative, less than 0. So we don't want equal to 0. So these are open circles. Less than, in between. Less than, that way. So our conclusion is that therefore x can be less than 1 or x must be less than 4 greater than 1. There are many ways of writing the same answer, guys. It's otherwise the same answer as above, isn't it? The same answer as those ones. Same answer. Different ways of writing it. Wabon. One tall. So as you can see, having factorized stuff above, you can use the advantage of the factorization because it gives you critical values which can help you solve a problem that would otherwise have been a tsunami if you had no idea what to do. Okay, guys, so this is also cool. So now I want you to answer this question quickly. Banlo being H. For which value or values of x is f of x greater than 0? Guys, I'm just pushing you now. I'm really pushing you. Because I want you guys to really be the masters of these questions. Because I know you all panic when you see these. Now, since we've done the job, when is it positive? Obvious. Obvious. This is this direction. This is where the product is positive. So you can just easily say x is greater than 4. If you didn't have it, you could look at the graph. You would see that the graph is positive when x values are greater than 4. And if you didn't know the first part of the table that we constructed here, you could easily do it, and then these are the answers for you. Okay, so I hope you understand what we are doing over there. I hope you follow. I hope you follow. Right, what other question must we ask? a very important question. So HI, it says determine the equation of a tangent to f at x is equal to 5. Right. So this is a very important question, which is going to lead us to one other question. Of course, guys, I'm not going to exhaust all of them. Other things you will see when we do the actual exam. But I just want to show you a few things. Mainly here, it's an issue of transformations that can be asked in a very silly way. Yeah, talking about nature of roots, relating to transformations, but mainly translations, because a reflection here, okay, we can have a look at it, but yeah, let's just say transformations in general. Now we want the equation of the tangent to f at x is equal to 5. So first we want the gradient of the tangent. It's going to be the first derivative when x is 5, isn't it? Yes, so this means the gradient of our tangent is going to be 3. Where we see x, that's what we do. Konje ngibani enye sendiyilibela. 3x squared minus 12x. Where we see x, we put this one. Plus 9. That's the one. So guys, this gives us the gradient. Maybe I should have looked for the point of tangency first, because I mean, this is towards the end. Hold on. So we know that f of 5 is going to be equal to, guys, you know what to do. Okay, you don't. So this is going to be 5 cubed minus minus 6x squared. Minus 6 into like that. Konje being 9 plus 9 into 5 minus 4, right? So we can say therefore f of 5 is, now don't crack your skull, although you may want to try to be reasonable to it. Sometimes certain operations are going to tax it unduly, so do not allow it. So the gradient is very high, too, so we can say therefore the gradient of a tangent here is 74. Right. Ah man, sungiqhela wena, sungiqhela. Kwenzeke ntoni apha? Yabani. I'm making a meal of a simple situation. No, man. That's not what I'm doing here. Plus 9 into 5, man. Aye. Oh, minus 4. I sent Katele, guys. It's 106. Makes sense. It's a positive thing. So we have a language to tell. We say also the gradient of a tangent. This is 3 into 5 squared minus 12 into 5 plus 9. We get 24. Again, it makes sense. We expected a steep gradient. So we can say then the tangent is going to be y is equal to 24x plus c. Now, we forgot to make a conclusion. The part here is like that. So through the part, what are we cooking in this pot? Okay, so let's see. 106 minus 24 into 5. It's minus 14. Hey, therefore y is going to be 24. Man, come on. 24x minus 14. For me, the gradient is positive and it's very steep. Y-intercept is negative. I accept. Okay, I truly accept. So, of course, if we drew a tangent at where we expect this to be 5, maybe right around there, you know, maybe right around there. So if this is 4, yeah, a tangent would do such a thing. Let's not waste time. We are losing it very fast. Okay, so this is something we need to know, guys, that we can do. Okay, this is something we need to know that we can do. I hope we are clear. Let's take another last one, an interesting one also. I want to use this tangent, God. Could I use the tangent? Hlabelela kumhlaba zokulingana. Hlabelela kumhlaba zokulingana. Hlabelela kumhlaba zokulingana. Okay, it's going to be complicated if we use this one, I'm thinking. Okay, now folks, this is the last question you need to answer. And again, I need us to spend a bit of time here. J. Uthini ke ngoku here? J tells us, Hij, says for which values of k? Abantu basiyabuza. Value or values of k. is f of x equals k, for which values of k will f of x equals k. Okay, let's start all over. I want to make it even more interesting. For which values of k will f of x minus 4 equals k have, do you want 2? Okay, maybe let's say 3. We'll have 3 real and unequal roots. Sure. Yeah, these are those naughty questions indeed. So for which value or values of k will f of x minus 4 equal to k have 3 real roots? Whew. I want you to know about hayibo. Suwenza into asukwenza izinto endingakuthumanga wena. Yebani. Sungiqhele. Okay, so we made it a bit interesting, right? Interesting. God, I feel like ndimoshile man. Kisense waits. Yeah, man. Yeah, maniac. I did not do the right thing, did I? The question andifuni wathi ndisokolise, yazi ingxaki yami ilapho. Andifuni kusokola. Uyayibona lento. Yeah. No, to avoid suffering, guys, masithi positive, yabo? Yeah, masithi plus. Yeah. Masithi plus, mhlambi izoba ncinyane. But even if we said negative, even if we said negative, we can leave it like swa. Ay, man. I'm saying they're panic, much. I'm panicking. So what happens, guys? Some things are gonna happen. Oh, Lord. Now I need you to notice that k is just a horizontal line, isn't it? These are two functions. We are transforming f by moving it 4 units down, and k is just any line y is equal to k. So we need to think of two things here. We need to think of f of x minus 4. So what is this going to be? Now on the Cartesian plane, I'm going to take you through the graph. I need you to master the graph because it's easier with the graph. In fact, let's do this. Let's do this. I don't know if it's gonna work, but let's try. Let's avoid working too hard. Yeah. So there's our graph of f. Now I'm gonna remove most of the stuff. So we already know what we know, right? Great stuff. Now folks, I don't know if it's gonna cut, but let's try. Ingathi izokwenza hayi wena man, tyhini nabafondini ibonayo ngendiqhela kabi. Iyandiqhela, ndazile nje uba ayizukwenzeka le nto endiyifunayo. Yeah, it's refusing. It's just catching strays. Okay, it's not doing what I want. Let's just leave it. Okay guys, so if we move this graph down by 4 units, that means every point is going to move down by 4 units. So this means if we can just try to mimic this graph now, and let me use a different color. I don't know why I chose to struggle. I've got the means, but then I chose to suffer. Now if we move this graph down, guys, by 4 units, everything shifts like a SWA. Right? Right, we end up with this graph looking like that. Right, so this is f of x minus 4. Now what happens? The y-intercept goes to minus 8. That's the first thing. That turning point goes to 4. And of course, this one goes to minus 8 as well. As for the x-intercept, we're not interested because we're not looking for values of x. Now if we draw this function y in purple, this function y, we've got f. In fact, we can even say this is perhaps g of x is equal to k, meaning it's a horizontal line. So it can be here. Just need to extend our axis. It can be there. It can be right through the turning point. Okay, remember this is 8 minus 8. This graph can be, remember this is in reference to the new graph. It can be right on that turning point. Remember that's minus 4, right? It can be anywhere in between right? Anywhere in between. It can be anywhere above this turning point. So remember, this is in reference with the green graph now. So this is essentially the graph of G is equal to K I just need you guys to grasp this one. I don't know, guys. I've lost so much time doing one thing. It's boring, eh? Now, when do we see this graph intersect 3 times. When do we see this graph intersect 3 times? I mean the green graph. So we see it here. 1, 2, 3. Right? At the turning point, it intersects 1, 2. 1, 2. And then here only once. Then there only once. So when does it intersect the graph? 2 times between these turning points. And this is between minus 4 and minus 8. Right, so we can say therefore k must be less than minus 4 but greater than minus 8. Because if that's the case, this is the graph that we're looking for. It ticks all the boxes. The others do not. So that's how you answer this question, guys. Of course, I will demonstrate with other examples as to how one can use this and how to really reason around it. Now, folks, yeah. I can feel it. I am tired. I am tired. Okay. So let's see. What is this? Right. The trabajo is trabajoing. The trabajo is trabajoing. Ne? Yeah, guys, and cartel. But I tried to show you most of the questions you're going to come across. And of course, you will see with the different questions. I think this preparation is perfect. I cannot cover everything, obviously, but you will just appreciate these things as we go along. I think that should be it. Although I'm itching for one last question. Yeah, let's just do this one last one so that you can be familiar with this totally. Now this one is certainly Hij. K will say, for which value or values of x is f prime x times f of x less than 0. Okay, maybe let's start it small. Let's start it small and say, well, when is this going to be x times f of x be less than 0? That's the first question. So I just want to make you think of what happened. Take any point x is to y. We know that this thing represents y, and this is any x value. Right? And we know that x here is an element of real numbers. Right? And these are the corresponding y values. So basically what we did, we took the x coordinate and multiplied by the coordinate. So we're looking for xy. And we're saying xy must be less than 0, basically, when we multiply those points. So when we write it in function notation, this is x into f of x less than 0. So I need you guys to understand how these questions were created so that you can answer these properly. So now we want a point on this graph, or a set of points where this property is. Obviously, guys, it's either the x is positive and the y is negative, or the y is negative and the x is positive, isn't it? Yeah. Now let's go and borrow the sketch because it's too far away. It's too far away. Now if we look at this sketch, how do we answer this question? So we're taking any x value. So what I normally taught my students was that just imagine you've got a ruler or any vertical line. Now remember, when we read, key thing is start from left to right. Don't do otherwise. So just take our ruler, just any line, we move in. So okay, fine, there we are. We move in until we intersect the graph. If we check there, what are we going to see? We notice that, hold on, at this point, the x value involved in this particular point is negative. But the corresponding y value also is negative. So I've got a negative times negative, which is going to be positive. Now a negative times negative is greater than 0, isn't it? But we said less than 0, so we're not going to take any point where x is negative in this graph. Now what happens when this is 0? We will see that x is 0, y is negative. So 0 times any number is 0, but this is not included. So we're not going to take 0 either. Just past 0, we will appreciate that the x value is positive. The corresponding y value is negative. That product is certainly less than 0. Okay, this is good. So this means this is going to work up until we start from here. Then we go on, this happens. And then again, here we get 0. We don't want 0. So this is not accepted. We're not going to take that interval. But what happens when you go this way? It's good again, right? It's good all the way up until we get to 0. Right, so which intervals are good? It's this interval and that interval. Because here the x value is positive, the y value is positive, so it's not going to work. So let's write the answer. So we know that our x must be less than 1, greater than 0. Is it greater than 0? Yes. 0 is critical there. Or x must be less than 4 or greater than 1. So that's how you answer this question. Very nice. Again, you had to understand the function notation, interpret it in terms of why are we doing this in the first place? What are we getting to? Now you know, right? So let's ask the last question. Then I can take a break and then we start tackling some past exam questions on cubic functions, because you will get questions where you've got Okay. Yeah, there was more I needed to do though, but I don't want to do it. I don't want to do it. Some of the things I'm going to let, the exam questions guide us. I'm going to let the exam questions guide us. They must guide us. Okay, guys. So let's look at the last question, which is KL. So again, this is going to say for which value or values of x is f prime x times f of x. Let's make it even more complicated. Divided by x be greater than 0. Yo, sendikubulele fi go tsetetse jwale go tsetetse. Hi, if you find yourself rising, I just know you are a ghost. You are an ancestor. Yo, let's go and borrow the thing. Let's go and borrow the thing. I hope you guys are getting along with this, because I know it's a lot of information. In fact, I think we're going to cut it with the cubic function. We are going to cut it with the cubic function. Because ndenze ntoni? Hayi, yabona undiyaphapha ngoku. I was supposed to copy this thing, man. Hayi. Xakiwe ngokutheni sendingagqibi. Utheni sendingagqibi ngoku? Xa kuyintoni? Right, there's our graph, guys. Now we need to answer this question. So what do we know, folks? This is the gradients. Right? These are the y values corresponding to any x value. Right? So we're taking a point, basically. We're saying the y value divided by the corresponding x value, and then we multiply by the corresponding gradient. Yay. Again, we said we read from left to right, guys. We don't read from right to left. So we come and say, okay, fine. We wait until we get to this graph. What do we see? You will notice that the x value here is negative. The corresponding y value is negative, right? And the gradient is positive, because for this particular point, so we're looking at a point. At this point, we're looking at three things: the x value, y value, and the gradient. So what we notice is that the x value here, if we look here, the x value here is negative. Okay, let's say this is the function. Okay, let's just write it nicely. So here the ratio, the gradient is positive, multiplied by the y value is negative, the x value is negative. So what is this? Positive times negative is negative, divided by negative, yes. Negative divided by negative is positive. Is it good? Yes, it's good. So we know that, okay, for this situation, as long as we're coming from negative infinity, intersect before this critical value, this is the case, okay? Right. But what happens when we get here? Well, what happens when we get here is that the x value is 0, the y value is negative, the gradient is positive. But the problem is that x is on the denominator, so we cannot divide by 0. So this is undefined, so this becomes an asymptote in here. So we cannot allow this on this line, right? Actually, I don't know what I did. Right, we want to drop it here, and then we copy this. Now let's see what happens when we move just past. X value is positive, Y value is negative, gradient is still positive. So what we end up with is a positive, positive gradient at that point, multiplied by a negative Y value, whatever the size is, divided by a positive X value. So this is going to be negative divided by positive, which is negative. Now that's not less than 0, so we don't want that. So this means in this region, from here all the way to this turning point, we can't take those values because in that interval the behavior is continuously going to be the same. And that includes that it's an asymptote because we can't take that, right? So I hope you guys can see. Copy, paste. So what happens over here? If we look here, we've got a negative gradient, negative Y value, and a positive X value. So what do we have literally? We've got a negative gradient multiplied by a negative Y value, all divided by a positive X value. So this is going to be positive divided by positive, which is positive, and that's good. So this means we will be good here all the way from this turning point up until that turning point. But at this turning point, we cannot include it because the gradient is 0, and we don't want that. Let's park it here. Here we've got a positive gradient, right? Negative Y value and a positive X value. So this is going to be something like that, which never worked. Positive gradient, negative Y value, positive X value is not good. So it's not going to be good up until we get here, right? And remember, 0 is not included. So we can't have a 0 there. So all of these points are literally asymptotes, these ones. We don't want these. You can think of them as not allowed. But where did we say we win? We won over here. This interval was good. This one was bad. This one, don't lie. We first did not like the first one because positive times negative is negative divided by negative was good. Ne? So this interval there is good. Going this way, we were good. We actually won because we said the gradient is positive multiplied by negative Y value divided by negative X value. It's going to be positive, which is good. So that interval was good. Then we came down to this portion right here. What did we say there? We said the gradient is positive, the Y value is negative. Essentially, and the X value was positive. So this is, I actually confused myself here. No. So this one was the first instance. This one was the second instance over there. So We've got a positive gradient, negative y value, and a positive x value. It didn't work. It did not work. Excuse me, guys. So as you can see, it gets complicated. And then what did we say? This one, we've got a negative gradient, right? Times a negative y value, that's already positive, divided by positive. So this is the one that worked. So this one actually worked. So this is the interval that we wanted. And then this one failed, right? Because it's a positive gradient, negative y value, positive y value. So this became negative. And then this interval all the way also passed because everything was good. So of course we do the sign check here. As you can see, of course, this is all done when you have a bit of time, guys. And of course, these are the questions you would rather you answer while you're still fresh, because and so we know that x must be less than 0, or x must be less than 3, greater than 1, or x must be greater than 4. That's the answer. So that's how you would answer a question as crazy as that. We can do a lot there. We can put square roots, we can add, we can subtract, we can do a lot of crazy things to twist your neck. So what I'm trying to show you guys is the element of creativity that you should develop in your brain. Be able to ask yourself any question you can imagine. You will do well in mathematics. Don't rely on just the questions that I am showing you or that the book will show you. Yes, exhaust them if you can. Check past exam question papers. But remember, the question you're going to answer in the next national examination, you may have not seen it before or anything like it. This is why you need to go wild in trying to create questions. But of course, you will see some of them are going to be faulty, full of misconceptions and full of problems. But that way, as you learn to create the best of questions that transmit the right message according to mathematical concepts that have been proven true, you then become that person who cannot be stopped by an exam in succeeding. You can say a lot of things about smart people, but smart people is not who you think. You know, smart students are not students who just read, cram, regurgitate. No. Work hard like ants, and, you know, at the end of the day, you get crushed and you're like, what is happening? Smart students work smart. And working smart means understanding everything you do, however small, however big. But remember, big things are very hard to understand if you don't understand the small building blocks. So what I would suggest to you guys is that to really get to that definition of being smart in your exams, it's not because what can I say? Maybe the element of being gifted is there somehow. But when you're gifted, to be really seen as such, it means with less resources, less exposure, you can still perform over and above those who have the best of exposure, the best of resources. Then you can say you are gifted. But you don't have to be. Being smart is not really being gifted per se, but it's a quality of gifted people. But anyone can have it, can possess it. And the best way to do it is that when you're shown something, explore that something enough to know when it works, when it doesn't work, when is it best to consider, when it's not best to consider, and what you can do with it and how far you can go. I promise you, come hard questions, they will look like, candy. They will look like candy. Candy, 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 candy. All right, guys. So I think let's stop here with the cubic function. I know there's a lot. I wanted to talk about when given a graph, how you would go about working the equation. Maybe let's just do that and leave the interpretation questions and just design a question where we are given a graph and then see how we can use it to find the equation, because I think that's the most important. But at the same time, I wanted to say, how could we use a graph to say something about the original, But I think these kinds of questions are best looked at when we see them. Let's not waste time on basics now. Okay, guys, I'm going to stop here with the basics of a cubic function. I hope I have said everything. Now we're going to start doing past exam questions from here. So hang in there tight. Now let me just take a break, watch a race. I think race 2 is about to hit the ground now. The Superbike racing on Motorsports channel, DSTV. Let me go watch my race of Superbikes, although it's boring. There's no challenge for the winner there. The winner is just running away into the sunset with no obstruction whatsoever, and then they will call him the best. How lousy. Anyway, whatever. We're just gonna go and watch the rest of the race, I guess, because obviously the first position is already clear who's going to have it. But yeah, I'll use it as a break, and then guys, we're gonna take it down to past exam questions. So we're gonna start dealing with past exam questions. Right, so we're gonna go to our document and start playing with the past papers. Of course, I'm not gonna do all of them, folks, as much as I wish I can. Otherwise, it's immaterial to do so. So I just need to take maybe 2 or 3 questions, and then we should end it. You do the rest. They are of many different forms and flavors, but I cannot exhaust all of them. You do the part of doing that. Yes, every now and then I'm going to drop some short videos on a particular question on any topic that came to my mind. So I'm going to just start throwing random stuff from now on. Okay, so be capable of using this. So literally after this, guys, we will have done most of the work for paper 1. But I think I still need to take you through functions. Yeah. Now that we have what we have as grade 12s, functions forecast for grade 12s, okay? Yeah. We're going to start dishing up information on functions like a short course like this. And then, yeah, we then start dropping things, just going to be dropping things after that. It's either you catch it or you don't. It will be up to you, my students, but I wanted you guys to really have the best of the experience of your matric without fear, but with more vigor, enthusiasm, eagerness to take it to the limits and survive the onslaught with a smile in your face, not anguish and pain and anxiety. No. Even when it takes you down, you're like, try again. Try again. All right, guys, I'll see you in a moment. All right, guys, so welcome. Let's continue. Now we're going to take some past exam questions and handle them, right? So as you can see, the first question is not the nicest. We're going to look at questions like that at the end. So let's just remember we've done an example already where we have an equation. We then had to work out the graph. Now, I'm not going to repeat that kind of an example, but we're going to focus now on having a graph and see what we can do about it. So we're going to take this question 2 from Mpumalanga, from the east. Right, in the diagram, f of x is minus x cubed plus 5x squared plus 8x minus 12. So this is the standard form. And we can already see that the coefficient of the highest power, which is x cubed, is negative. So we expect the graph to look like this indeed. Right, so that's exactly what we expect. Okay, so already from looking at the equation, we can already see that d is going to be 0 and minus 12. Remember, the y-intercept will always be the constant. So these are quick things, guys. Don't look around too much. Is drawn. Okay, A, B, and C are the x-intercept. Now, of these x-intercepts, we can appreciate that B has all the coordinates. So this is already good because we don't have to go through trial and error and look for some possibilities. Right. And then what else? T is a point of F and G is a point on the x-axis, okay, such that TG is perpendicular to the x-axis. And we can see that, so this means this is parallel to the y-axis. Right, D is the y-intercept of F. Nice, so we already could tell the points there. So let's just get to business here and not waste time. Now let me just tell you something. Let's just imagine B was not given. So how would we find the x-intercepts? Let's just look at that. So we've got F of x is equal to minus x cubed plus 5x squared plus 8x minus 12. Now, folks, the best thing, wow, screenshotting again. So the best thing that we need to do here to figure out how to find these values. Now, what is important, guys, is to look at the coefficient of the highest power, which is x cubed, and we look at, the last term. So this can give us the range of possibilities for the x values that would give us 0. Okay, so this essentially gives us possibilities. We can just say a range or an interval of possibilities. Sometimes when I say range in the concept of functions, so this gives us interval of possibilities of the zeros of f. Okay, now this interval, this is just to say how far can you take a trial and error. Well, we look at the factors of a, so we can see that whatever a is, this interval or this range is given by minus hey, awuthi siyibone ithe ngathi ndiyayibhuda nje konje siqala ngephi. Okay, maske siyibone, plus or minus, gonna say a over p, right? Not sure if I'm writing it well. So the ratio of the factors for these is going to help us. Of course, here we've got minus 1. What are the factors of minus 1? Is essentially minus 1 and 1. You can just say minus 1 times 1. That's all we have for that. Then for 12, what are the possibilities? Is 2 times 6, right? It's basically 3 times 4. And it's going to be 12 times 1. Right, so we look at all of those possibilities and see that, okay, for 12 it's 3, it's 2, it's 3, it's 4, it's 6, and 12. Including 1. Okay, it's 1 times 12. Yeah. So let's have a look. So this means, guys, we would have plus or minus. Let's consider 1. So this is going to be 1 over minus 1. Right? Maybe. Then this could be again 1 over minus, sorry, this is plus or minus. Then again, this is over 1, the other one, right? And then we'll look at the other one. Kimang. This is going to be plus or minus 2 over, we can divide by minus 1. Again, we can check it over. So this is going to be plus or minus 2 over. But I think I'm really prolonging this, ne? Why am I repeating? I should not repeat here. There's no need. Why it's the plus or minus already covers that. It's just 1, guys. And that's why it is agegis. There's no need for what I'm doing. Okay, so we don't need to repeat. Plus or minus 3 over 1 plus or minus 4 over 1 plus or minus 12 over 1. Okay, so that is what we can do. Of course, guys, other things we can reverse them. We can easily reverse these, you know. Would we be able to? I don't think so. So this means, guys, check these values. So this is how you can narrow the stuff that can give us what we want. Of course, these are possibilities of the zeros. It's not definite. Some may work, some may not work. This is what helps you to look. Of course, you can just say integers from 0 to 3 and 0 to minus 3. Usually you will have found what you need. But if you're not sure and you're getting something strange, if you take the ratio of A over P, I'm not sure if I'm doing the right way, then we should be able to get somewhere. This is just to give you some insights, but that was not what we were trying to do here. That was just insights on how to look for the factors to use. Okay, let's get to business. 2.1 says, calculate the coordinates of C if B is as is given. So already, this tells us that we can either use the synthetic division here, or we can use inspection. I think inspection is going to be better. So we know that C is such that f of x is equal to 0. So this implies that minus x cubed plus 5x squared plus 8x minus 12 is equal to 0. So this implies that we've got we can factorize it now using what we know. So the factor here is going to be x minus 1, so that it solves to 1. We know that the second factor is quadratic. So what must we multiply x minus 1 by to get minus x cubed? It's going to be minus x squared. Then we say what must we multiply minus 1 with to get minus 12? So plus 6. Then we want to look for any of these. Either we look at that or we look at that. This time maybe let's just look at that. You can either look at that or you can look at that, whichever comes first in your mind. Since we used this in the first example, let's look at that this time around. So how do we get 5x squared? Of course, this is going to be x squared. So we just need, if we already have x squared, we just need 4x squared. So this means it's going to be x times something here that should give us 4x squared. Automatically, it's going to be 4x, right? So that's good, because when we say x times 4x is going to give us 4x squared, minus x times minus x squared is going to give us x squared. We add those, they give us 5. And look, it will give us 8, because this is going to be 6x. And then this is going to give us, hold it, hold it. How do I get my 8x now? Hey boo. It's not happening, pal. Yes. Did I do the right thing now? Did I do the right thing? But yeah, man, it's working. It's working. Oh yeah, made a mistake. This should be 12. That's why I was wondering. Ooh, bad stuff here. But a silly mistake after all. So now this works, because this is going to be 12x minus 4x, which is going to give us 8x. So this is proper. Just a small glitch. You can see, guys, when you're tired, things start to happen. Now we can factorize the second one further. So this is minus x, this is x. For us to get a 4, factors of 12 is going to be what? 6 and 2. So which one must be big? Is 6 and then 2. The big one must be what? Like so. So that I've got minus x times minus 6 is going to be plus 6. This times that is going to be minus 2, which gives me that. So we are good. So now the x coordinate of c is the biggest value. Now we don't need to worry about the others. We can say x at c is 6. We can say then, we know that f of 6 must be, I'm not going to show you the substitution. We just substitute into the original f. So this is minus into 6 cubed plus 5 into 6 squared plus 8 into 6 minus 12. So this gives us a zero. Ah, Lord, come on. There was no need for this. No man. We already know that this is when y is 0, my Lord. So therefore c is the 0.6 is to 0. Done. All right, so what do we do here? We're getting 4 marks. So, well, folks, it's quite strange, you know what? So this is a mark, ne? Yeah. For the quadratic factor, yeah. For the factorization of the quadratic factor, yeah. I would suppose for knowing that that is a factor as well, perhaps That's how we score the 4 marks. But remember, we were asked the coordinates, not just one coordinate. So we need to eventually write point C like that. If not, we will lose a mark here. It doesn't matter that they are all correct. We did not answer the question. So instructions, guys, are strict. Don't play. Determine the coordinates of E. So we were told that, how, guys, they don't tell us anything about E. This is not good. Well, we can already see that E is the turning point, but we need to be told that, because sometimes it may just be the point before the turning point. But I think they made an error of not explaining that E, the turning point, or at least in the opening statement, we should have something that tells us that E is the turning point. Either way, we know what to do. So we know that E will be such that the first derivative of f is 0, because this is the turning point. We differentiate, we get minus 3x squared plus 10x plus 8 is equal to 0. We factorize this thing. Sometimes we can, sometimes we can't. How do you check if you can factorize? Check the discriminant. You've got tools, guys. I've shown you these all along. So to decide if this is factorizable, the discriminant has to be a perfect square. But let's just take a chance and see. This is going to be 3x. Factors of 8, it's 2 and 4. So I'm going to put a 4 there and a 2 here. Now I need a plus. So this must be sunqhela. Awuze kahle kangaka. Why? Okay. Bad factors, bad positioning, I think. The 3 must coincide with the 4 for this to work. Like this. Now, these ones must be both negative. Then we get 12 minus 2, that's 10. Cool. Therefore, we know that x is going to be minus 2/3, right? Or x is going to be 4. Now, if we look, the point E is on the positive, or it's in the 4th quadrant. X must be positive. So we're not going to choose the negative one. We're going to say, therefore, x at E is 4. Now we go f of 4 equals. Now we go back to the original. So this is minus into 4 cubed plus 5 into 4 squared plus 8 into 4 minus 12. So this gives us 36, which makes sense. It's a positive answer. So we know that therefore point E is the 0.4:36. Very easy. Very easy. So we just substitute that x value into the original f function to get the corresponding y value. Right, we're scoring 5 marks for this. First and foremost, to know that the derivative must be equal to 0 is key. To do the actual derivative, this time you don't get a mark for each differentiation of that polynomial, but the correct final answer there. Then we get a mark for factorization, we get a mark for the x value, we get a mark for the y value. But the question needs to be presented properly. Remember, this is a point on the Cartesian plane. of the graph. So it has both x and y values. Unless it is clearly stated, look for the x coordinate. If we didn't say that, then we want the point in full. So you can see, guys, this is nice. This is easy because we were ready. 2.3 says, for which values of x will f be concave up? So we can already see that we need to find the x coordinate, the point of inflection. Now we found out that this guy is 4. And we also found out that this guy is sitting at -2/3. Right? So we want the point of inflection. So we can already see that it will be all the x values less than the point of inflection. Right, so we can see there that, well, this is going to be x less than the first x. We can just say x1 plus x2 because we didn't name these points, over 2. Now the first x here is -2/3 plus 4 all divided by 2. Perhaps I should write this one in line with the division. Right, we can say therefore x must be less than, with 3 there, 12. 12 minus 2, that's 10. Right? But this is going to be what? Wait. Yeah. 12 minus 2, that's 10. 10 divided by 2 is oh yeah, Gwenj is going to be 5/3. So this is going to be 10/3, not 2. So this is 10/3, and then the 3 multiplies the 2, that's 6. So 10/6 is 5/3. Of course, guys, engage your brain when you can. There's nothing that stops you. Now, if you look at the x1 and the x2, these are the x coordinates of the turning points. Here, I can even explain and say where x1 and x2 are the x values of the turning points, just in case. You know, sometimes there's nothing wrong in writing a complete statement and say, this formula is informed by this piece here, so that no one asks, hayibo, wenzani lo mntwana? Uyakopa. Babonisa ukuthi ndiyayazi lento endiyithethayo, andixoki. Now, folks, we've got an option. We know that the graph is concave up when the second derivative is greater than 0. Right? Now let's differentiate. You can use that. So we differentiate the first derivative. So this is going to be -6x plus 10 greater than 0. We transpose. We then divide by 6. Now we know when we divide by negative, the inequality changes. Then 2 goes 5 times, goes 3 times. So we can either use the graph or we can use the principle. I prefer the graph when you have it, but don't forget the principle. So we get just 2 marks for this. So usually answer only, guys, is good enough. But because you've shown how you came about it, I could easily say substitutions into some valid structure would be good enough. If you chose to show this one to know that the second derivative must be greater than 0. So here you're getting a mark for differentiating and writing the inequality, right? And for the solution. But as I said, answer only is acceptable. Mind you, acceptable. I did not say accepted. So answer only is acceptable. Same thing here. We can take it. Right. Okay, guys, so we're doing fine. So let's look at 2.4. 2.4 says calculate the length of OG if the tangent. Now, can you see we want this length from O to G? That's what we want. If the tangent to the curve at T is parallel to the tangent of the curve at D. Hey, this is the question. As you can see, there will always be a question on the tangent, trust me. If there isn't, just know you did not do a cubic graph exam question. So we want to know that if the tangent at T, let's just do it. Say there is the tangent at T. So if the tangent at T is parallel to the tangent at D, like this. Simkhwela okay, let's just see that they look like that, and we want to know that length. So as you can see, we were told that these must be parallel. So what does it mean? When you've got parallel lines, this means they have the same gradient. Now you have to bring in the knowledge of analytical geometry from grade 11, because even here you can bring it from grade 12. I mean, it's the same thing after all. In fact, it starts in grade 10 lately, which is fine. Okay, so what are we doing now? Well, we already know something about point D. We know that point D, is this the last question? No. Okay. We already know that point D has an x value of 0. So we can take the advantage of that, because we know that the gradient at D is going to be the same as the gradient at T. So this means the first derivative at T is equal to the first derivative at D. So that's what this means. So let's go for it. So it means here OG is such that first derivative at D, right, at T, because that's what's going to give us OG, must be equal to the first derivative at D. Now, what is the first derivative in general? We saw that this is minus 3x squared plus 10x plus 8. This is going to be equal to minus 3. Where we see x, we're going to put 0. Now we can already see that if we put 0, it's going to give us 8, isn't it? So let's not even waste time here. So when you put, okay, let me show you just in case you don't know what's happening. I know you guys, I will assume that you follow only to find that you don't. For now, we're just trying to build our momentum. So this means minus 3x squared plus 10x plus 8 is equal to, if we look at that, this simplifies to 8. So this means the gradient of a tangent at t is equal to 8. Don't forget, this is the tangent at t as well as d. But now, we want to solve for the x value there. So we just simply equate these two and solve the quadratic. So what is nice is that this guy goes away and that guy goes away. Because when you transpose this back, remember this is still quadratic, so we write it in standard form. Transpose this to the other side, they cancel. So we end up with minus 3x squared plus 10x equal to 0. We want to solve for x. So we know that x is the highest common factor. We get minus 3x plus 10 equal to 0. So look at that. So x is going to be equal to, now we were looking for x at t. Okay, maybe let's start by saying x is equal to 0, or x is, transpose the 10, it's going to be minus 10 divided by minus 3, so it's going to be just 10 over 3. Now, which one is it? We're looking for the x value there, so the x value must be clearly 10 over 3. But do you see that this is true? Because when x is 0 in the original function, the gradient was also 8. Can you see there that at point D, x was 0? So that comes up nicely, but we're not interested in that. But now look, folks, g is just the horizontal distance from the origin. So from here, you can just easily say that OG is basically 10 over 3 units. So remember that. Nice and easy. So that was a very interesting question. Okay, not one of these easy ones. Find the equation of the tangent. Something that messes your head up a bit. So you need to know the relationships of things. How many marks? 5. Yeah, it deserves such. I think to know this, guys, is important because parallel lines have equal gradients. Ne? So that's the idea here. Parallel lines have equal gradients. Right. We get the first mark there. And to get the gradient was key, 8, however you got it. Well, I can just give marks nicely here. So to factorize, yeah, to find the x at t, I suppose. But this looks like I'm giving you a mark twice. So how do I justify this? Well, that was a means to an end, so it doesn't really earn a mark. But we can safely say perhaps the substitution of that point D to get the gradient is perhaps mark worthy. Yeah, maniac. It's done, guys. It's finished. So let's do the last one. So 2 point, you know, most this guy will always do things. Okay, let's see. This is 2.5. Right. So how do we handle this? It says determine the value of m if y equals mx plus c intersects f perpendicularly at x is equal to 5. So obviously we know that perpendicular lines, if we've got a line segment A, B, and then we've got C and D, we know that the gradient of AB multiplied by the gradient, run out of space. Let's start by saying it again. When we've got lines that are perpendicular, it doesn't matter in what regard. Let's say this is B, this is C, A, D, E. So if these lines are perpendicular, it is such that the gradient between AB multiplied by the gradient between these DE should give us minus 1. So this means if we can find the gradient at x is equal to 5, then the value of m, the line that is perpendicular to that point, will be the negative inverse. So now let's just see it. We know that the first derivative of 5 is going to be minus 3 into 5 squared plus 10 into 5 plus 8. We can say this is the first derivative. Therefore, f prime of 5. So we just want the gradient, because whether this is a long, lengthy business, we are not interested. Minus 3 into 5 squared plus 10 into 5 plus 8. So this gives us minus 17. We can already see 5 is going to be a negative gradient, so it makes sense. Right, we can say therefore m for this line, which is going to be perpendicular to this gradient, it's going to be the negative inverse. So it's going to be equal to, now the negative inverse is going to be 1 over 17. I hope I did my maths correctly. Correct. Is it correct? It looks correct. It looks correct. So if it is correct, we move. So do you see, if you multiply those gradients together for those perpendicular lines, we should get minus 1. And it is what it is, right? Right. Very easy stuff, guys. It looks complicated, but it's not. So basically, substitution, this one, getting the answer. You can go about it this way and show us that this is what was your thought process, but if you understand the concepts, I promise you, sometimes you can even find it easy to just cut the corners a bit. Remember, in the exam, for exam efficiency, you revise some of these concepts in your head, but you try to write a very nice and clean argument that you have checked it's correct. As you could see, I knew that my minus 17 is definitely possible, because let's say 5 is here, right? We can already see that the gradient at that point is going to be negative. So if I'm getting a negative answer, I'm happy. As for the value, it just tells me the steepness, in which case I probably exaggerated the point. This one is fairly steep, so probably somewhere around there, somewhere around there. So this is a fairly steep gradient that is negative. All right, guys, so nice and easy, and we're gonna keep it as simple as this. I don't want to but sometimes there's no chance, guys, to give, there's no chance to give okay, let's just ask an extra question, because we need to keep the lights on, right? We just can't move past. This is an opportunity to do this. So for which values of x is the square root of f of x plus 5 be greater than 0. yeah. Maske siyeke lapho nje sithi greater than 0. Let's not include 0. Although I want to, but it's going to cause problems if I include 0. So, umbuzo ubuziwe, guys. So I can ask anything here. I can even decide to multiply by the gradients and divide by y values. It's up to me what I want, but let's keep it simple now, just not to cause you too much pain. Now, by definition, a square root must be positive. So first of all, we know that what is under the square root can either be two things. It's either 0 or greater than 0, right? But we can already see that for us to get a value greater than 0, we cannot include 0. So this already tells us that the expression under the square root must be positive. Now 5 is a positive number to begin with. So this already tells you and I that we are only interested in f being greater than 0, because when f is less than 0, it will depend, of course, on... Yeah, I think I got myself in trouble now, because we then moved this graph 5 units upwards. You know, we have moved our graph 5 units upwards. So this means, okay, let's leave it as it is. This means we need to find out when is f essentially 5. Ne? Because when this is 5, wait. Maybe minus 5. Yeah. We need to find f. Yeah. What we need is to find, because of that positive 5, we need to avoid 0. 0 is the only critical value here. So we need to then decide when is our f function minus 5, right? Because that is going to work. Because we need to avoid that. Yes, f of x must be greater than 0. Okay, I think our interpretation is a bit strange. Maybe let's not interpret it like that, because it's not supposed to be possibly positive. It can take some negative values as long as they're not going to be less than minus 5. So we can just say, well, f here, what makes f? It means f here must be greater than or equal to minus 5. Because for this to work, when it is equal to 5, this is 0, but 0 is not included. So this means this one must be greater than minus 5. But minus 5 being, you know, the limit. Okay. Can you see? Not so easy. Not so easy. So now let's find out when is f equal to 5, for example. Now that is going to be a tsunami. Sorry, minus 5. That is going to be a tsunami. Let's just have a look though and see. I'm saying here minus x cubed plus 5x squared minus 12 is equal to minus 5. When we bring this in, we get minus x cubed plus 5x squared minus 7 equal to 0. Now when we try to factorize, let's see who gives us 0 this time around. I'm just gonna use the calculator. I think I missed something. Yeah, I missed a term. So this one is minus x cubed plus 5x squared plus 8x minus 12. So this is going to be minus x cubed plus 5x squared plus 8x minus 7. Now let's see what would work. So you can use your calculator under these circumstances. You just go to mode. As I said, I'm going to teach you how to use the calculator. You go to mode. And then what happens? Then you'll see option 5 on my Casio. Option 5 says EQN. That's equation. You hit that. And then when you hit that, you will see in mine, option 4 gives me a cubic, ax squared plus ax cubed plus bx squared plus cx plus d. Now all you do, you just punch in. Once you press this, it's going to give you a chance to put in the a value, to put in the b value, to put in the c value, and finally the d. So this one does what we would have had to check, because now you want to be exam efficient. So option 4, then my a is -1 equal sign. For b it's a +5 equal sign. C is 8 equal sign. D is now -7. Then we do that. So the first x value where this happens is very strange, very, very, very strange. So my x1 says, this is the first value of x. It says 6,12. This is what would give us a 0 now for our new equation, in which case that would give us a -5. Yeah. I'm not happy with this calculation. Why? Okay, let's say 6. Fine. It would give us a -5 on the other end. Because we know that, indeed, past 5, what was this value here, Gonch? 6. Ne? Gonch, what did we get? Yes, we got a 6. So 6,12, it means it's definitely going to be negative beyond 6, because at C we see 6. So it makes sense, okay? It does have a potential after we've moved that point up. Okay, that's fine. So that is cool. Now let's look at the second one. The second one is 0,65. See how the calculator becomes very good. 0,65. Okay, is there a third one? Yes. A third one is -1,77. Okay, so this is essentially a question that demands a little bit of calculator skills, because you don't have time to waste anyway. So folks, we know that at those x values, this function of f, when shifted upward by 5 units, is essentially going to be -5, which means it gives us 0 there. So we don't want that. We really don't want that. So those x values that we found, what are we going to say about it? Okay, let me try and figure out how we're going to answer this question. First of all, the best way to answer is to say, well, we want to find out f of x plus 5 equal to 0. It is such that x is equal to 6,12, or x is equal to 0,65, or x is going to be equal to minus 1,77. Those would be the new intercepts once we shift that graph upward by 5 units. Now looking at those, what do we want? We want the value to be positive, essentially. So what happens to this graph after those points? For example, I am very clear about this one. After 6, the graph essentially is giving me a negative answer. Because once you put a value greater than this, we will get a negative answer, and we can't take a square root of a negative. So this one says we cannot go beyond. So there's a lot of thinking. So we cannot surpass. We cannot surpass. We cannot surpass. So we will say anything less we can take, because anything less than this will then give us, what we want. It's going to give us what we want. But now, what is the limit to this? Again, the limit to this would be the y-intercept. No, not the y-intercept, but remember the shape. I forgot. Remember the shape. This function, its shape is going to be like this. Now let's look. This is the x-axis this time around. I'm just going to look at the x-axis alone. So these are the values. This is the 1. This is the 2nd. This is the 3rd. So I'm just going to put 1, 2, 3. But remember, these are not the values. Now we can already see that this graph is positive between these two. So this is what we want. But it's negative between these two, so we don't want this part. This part is what we don't want. But below this, so let me shade the parts that we want. These are the parts that we want. Of course, the zeros are excluded. So, how do we write? You can say, therefore, x must be less than minus 1,77, or x must be less than 6,12, but greater than 0,65. Because remember, the zeros are not included. And when this is the case, you will see that indeed our graph is looking good. So it means we also need to think of the transformation and think about working things out. So obviously, guys, all of this is our rough work. We don't need to show it. Answer only is good enough. As you can see, this was not a question I thought about before I did it. I just thought about it now. As you can see, it takes me from pillar to post. But eventually we got it right. So learn to master, not just to do routine. As you can see, it can get hot in that seat. Now let's look at this one as the second example. So I'm going to leave some space for you guys to write notes. Question 3 says, the graph of f equals ax cubed plus bx squared, and it has stationary points at P, and at the origin. So the origin, we can see that it's two things. It's an x-intercept and it is an x-intercept as well as a turning point. Right. So be very careful about these things. They are quite an interesting issue. I'm going to highlight a few points about this at the very end. I just hope it will make sense. Yeah. So let's just get to business and not overly generalize. So we've got our f of x equals ax cubed plus bx squared. Now we need to find the equation. Basically, this is to say you can be given a graph and one of the turning points and an extra point. We should be able to find the graph. This one highlighted the fact that you could be given the intercepts or just one of the intercepts and another point indirectly, because I mean this could work of course with the equation at hand, but at times you can either be given all the intercepts and an extra point, or you can be given one of the turning points and a point, as it is the case right here. Right, so let's respond to 3.1. So 3.1, we know that, folks, at the turning points, now we need simultaneous equations. The moment you see these, the step that is going to be good, we need simultaneous equations. But these ones you're going to derive. Remember, there's a difference between differentiation and derivation. To derive is to bring forth something. But again, differentiation, if you look at it again, you took an expression and derived another from it. But we call that derivation, specifically differentiation. So don't confuse that with when I say you have to derive an expression. To derive is to use given information to then model an equation. That's what we call deriving. But when we take something and we see kame, take for example, if you take a towel and you tumble it, isn't it? You create something else that was not there. It was perhaps a square sheet that could be laid horizontally on a flat surface. But once you start stumbling it and you create something else, okay? So you would call that differentiation. But now when you have to take pieces of wool, right, or cotton, whatever you call it, you sew them together into the towel, you would call that deriving a towel from raw materials. I think I made my example much better. If not, and as now. Now, folks, we know that two things happen here. We can take a point, P. This is the turning point. There's two things happening at P, right? That point belongs into the graph. So we can substitute that point into the graph and see what happens. So we know that P, which is 2 and minus a third, essentially tells us that minus a third is going to be a into 2 cubed plus b into 2 squared, isn't it? Now we can work out a nice expression. So minus a third is going to be 8a plus 4b. Now we can already see that this is crazy. So if it is not linear, let's try to make it linear. Minus 1 is going to be equal to 24a plus 12b. That's much better. Okay, that's much better. Then we can say this is equation 1. So can you see we derived an equation from just a set of points and an incomplete equation. This is like sewing something to life. We also know that guys, I'm gonna have to really move faster now. But anyway, I think after this example I should take maybe 2 more, because I'm worried my time for the class is about to start, so I need to freshen up before the class so that I'm fresher. We also know, guys, that at P, the first derivative of 2 must be equal to 0. Why? Because that's the turning point. So the gradient at the turning point is 0. So we differentiate our expression. So in fact, you can even write here f prime x is going to be 3ax squared plus 2b. Is it 2b? 2bx. Yeah. So that's what's going to happen. So we've got to have 3a, where x is 2, squared plus 2b into 2 must be equal to 0. So this means 12a plus 4b is equal to 0. Huh? Ndiyaqhelwa. Hey, mandingaqhelwa bo. Hayi bo, mandingaqhelwa bo. 10 ngoku. Oh yeah, ndiyabhayisa. Look, I thought this is gonna be 12. I'm crazy. I am crazy. Now, bafowethu, we can do some gymnastics here, right? The gymnastics is that we can isolate either one of these or we can do elimination, but I think let's just isolate 4b. 4b goes nicely to 12, so it's nothing really bad. But anyway, what we can do, let's just leave it like this and say this is equation 2. Let me show you techniques so that you learn. You can just say now, folks, if I want to eliminate here, I already want to eliminate something. So this means I can decide to eliminate A or eliminate B, whichever I choose. But I think let's just eliminate A. Now what's going to happen? I'm going to say equation 1 minus 2 times equation 2. Why am I multiplying by 2? So that I can eliminate. So equation 1, I'm writing it as it is, minus 1 is equal to 24a plus 12b. Then I'm going to subtract equation 2. I'm going to write it so that it's like that. 2 times 0 is 0. 2 times 12 is 24a. 2 times 4 is going to be 8b. Nice and easy. So in maths, we can do anything. So distribute the negative, we still get minus 1. 24 minus 24, these ones go away. And then 12 minus 8 is 4a. Superb, 4b. Right, so we can already see there, guys, that b is going to be minus a chord. Kitching? Say shayil. Therefore a, or therefore, we know that, okay, maybe let's just say then we know minus 1 is equal to 24, but why am I choosing this? Nieman, that one is complicated. Let's look for this one. So we know that 12a plus 4, instead of that we put a quarter, is equal to 0. Guess what? The things. So this implies that 12a is going to be equal to 1. Therefore a is 1/12. Seyigqibile. So you can see, guys, hey, kuyasetyenzwa la akudlalwa. Siyaspana bafethu, siyaspana. So you can see this is an essay in maths, unfortunately, and there's no escaping it. First, I would say this equation, however we got to it, we have to appreciate this one. We have to appreciate the method, the method. And then the rest, guys, straight last. So you can say, fine, 1 mark for your troubles to show us that you got it like that. Or we could consider substituting, we could consider that 4th mark as substituting that first point. But yeah, it's really not that much of a big deal. So I hope you guys are learning. Let's do 3.2. 3.2 says find the x values for which the graph will be concave down. Can you see? Now you've got two options. You can use the principal or you can use the graph. I'm going to usually use the principal here. You know why? Because but we also know the other turning point is at the origin, so this is good. So we know that this is going to be concave down when x is less than x1 plus x2 all divided by 2, where x1 and x2 are the x values of the turning points. So be as elaborate as you can, because sometimes what you're coming up with, we don't know, we've never seen, So just don't assume we know. Right. So this means our x must be less than 1. Done. Okay. Now you already know the other way. I'm going to put it inside a box to show that you don't have to present both. We know that the first derivative must be less than 0. Yes, because for the graph to be concave down, first derivative must be less than 0. Now this demands that we write our f. Now we know that our f is 1/12 of x cubed, right, minus 1/4 of x squared. So that was our equation. So let's differentiate this. So 3 there is gonna give us 1/4 of x squared and minus 1/2 of x less than 0. We take 1/2 of x as the highest common factor. What do we end up with? We end up with 1/2 of x minus 1 less than 0. Then we divide by a positive. Okay, we cannot divide by this. Anyway, guys, this one will force you down the graph path. This is x, this is the origin. I already know that this graph is going to have x value at the origin and at 1. Right. Is it 1 or 2? Emanyana. What happened? Ingathi ndithola u-2 mos. Why am I getting 2 now? Hey. Skankira biana biano. Skankira biana biano. Wabona biano. I won't get the sharp. So our graph looks stuff like this, guys. Oh yeah. Deyibona ke ngoku le ngxaki. I can see the problem. I can see the problem. So this is what it would look like at the origin and 2. Right. But now, what are we saying? Yeah, we don't want 0, right? Hi man. Why is it solved kagbi kanje? I did the first derivative. I'm surprised. Yeah, now guys, I'm tired. I'm no longer functioning well. I tried to take breaks, but yeah, this lesego umpolaile ngwana motho. Empa he ke a tshepa hore o tlo bala ntho engwe le engwe e ke buileng mona. It's the second derivative, man. So the first derivative is what you saw. It's going to be 1/4 x squared minus 1/2 x. Now we differentiate that the second time around. So this is going to be 1/2 x minus 1/2 less than 0. We transpose. Then after that, we cross multiply, if you will, because we're cross multiplying 2. So this means x will be less than 1. Hi, I was surprised, man. Yeah, but I'm happy when I get stuck and you can see. And you see exactly how I unentangle myself, because remember, you guys learn best by observation. I know we always assume you guys are proactive. You're not. You guys need to be prompted. But at grade 12, you should be independent of your teacher or your tutor. And the independence is gained by using your study materials, your textbooks, your internet. Everything, guys. Let your teachers play a supplementary role. Let your tutors play a complementary role. Huh? Yeah. Okay. Let your teachers and tutors, complement your proactivity. But who's the supplement? A tutor. Maybe a tutor must be the supplement. But your teacher must be a complement. Ne? You understand what I'm trying to say? You see. It says now determine the equation of the tangent at x is equal to 2 in this form, linear form. But they decided to write it in a way that you're gonna cry, but this is still mx plus c, baba. Right, so this one is easy, guys. So we know that the gradient of the tangent is gonna be the first derivative at -2. So I'm going to just substitute. First derivative is 1/4 x squared minus 1/2 x. Now, what I'm going to do, I'm going to substitute now. Sadlala undize nani. Akibabali macashelana lilina bana beso. Kyamuva jwale. This is going to be minus 1/2 plus 1, which is going to give us 1/2. Does it make sense? At x is -2, we see a positive but fairly gentle gradient. So we could assume that, yeah, sounds right. So this is good. We now know, we rushed. we also need the port. We need the port qala. Masiqale sipheke imbiza singaphaki umoya, suphaka umoya boy. So let's start. F of minus 2 is, at this point guys, I'm not going to show the substitutions. Angisenasikhathi manje. Sekulate kakhulu. Okay, mangabe too much. So we saw that this is 1/12 of minus 2 cubed minus 1/4 of minus 2 squared. I senzala ngo-0 guys, senzala ngo-0 manje. I guess I want a logic guy. Go back, mode, computing. You see, I was just mixing things here. Okay. I see. Abungakhala. Akuzukunceda nix ukulela. Anovela uthule. Sisebenze mntwana enkosi. Uyaphinda umthole umuntu ozawuhlala nawe kakuhle kamnandi kanje. -5/3. Ozahlala kakuhle kanje akunikeza course mfana mahala kanje. Sacrifice icawe yami yonke. So therefore the port is -2 is to -5/3. Can you see the skills you were being taught, guys, are focused? It's not just some random business being given to you. Some serious BSach 8 this so. You take it for granted at your parish. Then we know that our tangent, our tangent is y equals a half of x plus c through the part of -2 and -5/3. What are we cooking in this pot? We're cooking amanqina. Plus c. Therefore, our c is what? So this is 1. -1 going that side, it's +1. -2/3, this one. So therefore, y is equal to a half of x minus 2/3. Hey, is that swa? Is that swa? Hey, iyaphosisa. Ayisoze y-intercept ibe njalo pa balezo mqalama apha. Ndibale esomqalam apha, ndibale esomqalam. Yeah, kodwa ke the truth mfethu is the truth. What do you say? But I don't trust this. I know the gradient is good, but the rest I corner. The y-intercept can't be negative. Never. Hell no. Hell no. Let's check, guys. Something is not right. Yikes. Yeah, man. The gradient is wrong. Yeah. That was meant to be squared. You see? You will always know, man. You will always tell, I man. Something is not something here. Something is intashigana. Yeah. This one is 4, so this is 1 plus 1. 2. Itsho le ndaba. Sekuyatshintsha ke kanjalo. Sitshintsha amagiya. Re tshentsha dikere kaofela. Hobaneng ha o kwatile o kwata bosiu. konje ithini la ngoma hayi ke lebetse ntloeleng hape nne ke bapalla fela nne ke ipapalla bana beso ne ke sa batle ntho tse ngata ne ke ipuela ntho tsaka jwale re a tseba hore e tlo ba -4 ha re isa ka nqane e tlo ba +4 3 times 4 e tlo ba 12 then re fa 7/3 wa bona jwale e bua nnete jwale ha e sa bue mafose mona ha re batle maka man wa bona re rata nnete re bana ba modimo o halalelang ke yona he a le nna ke thabile jwale hobaneng my y-interceptor e tshwa jwalo hore e tshwanetse hore e be tona ntate e ska ba ke e tshehadi mona ha re batle ntho tse tshehadi mona re tla di sebedisa ka nako tsa teng ha ke di emenyana hona tjena ha rena nako ya tsona wa bona o ska lla he nna ne ke ipuella fela haeba wena o tlo ntse o lla he ka baka la go bona wa qhetso wa wena o lehe seruenyana se itseng ka mona o tlo ishwela o le 1 nna ha ke kene mono finding the port yes finding the gradient yes substituting the port yes getting the actual equation of the tangent yeah man that's how it works mos here yeah esincada igotes 3.4 yo hayi bafethu ngeke ayikhona ikarele sweswe nilaba kuyentlela man use the graph to determine the values of k for which we will always get a question on nature of roots guys you might as well get used to it. So it says now use the graph to determine the values of k for which that one. Now what is it? Excuse me. It is a vertical shift, but the vertical shift might not be very nice, It may not be very nice. So that we will have 3 real roots. So the best way I transpose, so I'm going to have 1/12 of x cubed minus 1/4 of x squared, and I transpose k because I want k to show up on this side as y is equal to k. And I know that this is my f function, so I just want to leave the function where it is on the Cartesian plane. And then I start playing that this is a horizontal line. For this to intersect this graph twice, it has to be a horizontal line first. Now I'm going to answer this fast and furious, guys. And sadlali nix manje, sadlali maqashelana. Wena osafuna udlala undize. Hayi zingxaki zakho ezo. Na undiyeke apho. It has to pass through the turning point okokuqala ne. Okwesibini. Intoni ngo. Tyhini nabafondini. Angaqhelwa. Ske antlwaela jwale. Nna ha ke a ijwetsa hore etse ntho tsena. The second one must pass through the other turning point via the origin. Now the other one must be where? Yeah, it must be somewhere in the between, right? Because la ingekho in the between, ayisoziwenza umsebenzi. Now if you look at this one in the between, in between, apha khalintonga bafethu, khalinduku. Holla sephadi fela ditsebeng tsa motho. Wa ibona yena e bua nnete hobane e etsa exactly ntho ene re batlang. Ne re batlang hore e khathe our graph of f hararo ngwana batho. Yes, e yentse jwale. Ho tsho hore e correct he yana. Empa ena e khatha habedi fela, wa bona? Jwale ha e etse ntho ne re batlang. Le yona ena e khatha habedi fela. ha e etse ntho e re batlileng. Jwale he re tlo re ai ho bohlokwa hore re hlokomele hore ntho ena e betere ha re sheba ka di-y values ya turning point ena le y value at the origin. Ho tjho hore re tlo re k tshwanetse hore a be less than 0 empa a be moholo le 1/3. Then taba ya rona re qetile, se re buile re qetile. Le haeba wena wa lla kampa wa reng ha re sana taba. Re qetile, re ile ehlile. Setse o le mong mono mafifing hona mono. Haeba o rata mafifi, o tlo ba o le mong mafifing mono. Rona ba di-mathematics se re ile. Re tla le bona hape ka le leng hana le reng re tla le bona hape lemong se tlang. Haeba re tla be re santsane re phela hobane bophelo ke nthwena ba e bitsang ke semphego ntate. O ka se tsebe hore e tlo tla le eng neng jwang hobaneng. O tla bona dintho o tla bona masingita, o tla bona nemihlolo nakudzela ntiyiso ngazodlala. Hayi bafethu senihlanya kakhulu, hlanyiswa kukudinwa okudibene nokuxaphuka. Now guys, I just showed these techniques sparingly. Those who attended my classes when we dished knowledge on differential calculus, you already know these things. I've shown you how to shift the graph vertically when this happens. I've shown you how to use a horizontal line that is moving up and down to really get the sweet spot. So at this point, I'm just trying to help you revise. And hey, Lesego, you hit a nerve, my little friend. You hit a nerve, my friend. You made me start talking, Yeah, and I am talking. Wana ngo ndiyacula ndithi sikuyo indlela. Ayi angeke ndiyeke eGauteng. Kaloku matric wami ndawenza eGauteng bafethu. Xa ngabe ndifuna ukwazi isikolo sam, ngiyafuna ndinihlebele isikolo sam. Isikolo sam kukwaThema eSprings. Zimnandi ke ezi questions bafethu. Funa ungiqhatha. These are the best questions, but I think I covered these questions in one of my functions videos that I did in the channel, I hope. But I'm not sure if I included differential calculus. Did I? Zimnandi ke ezi questions ezimbini is from Uoskapi and the Natal there. Hayi. Esincada ikhutes. I feel like it will be a crime to jump these two. But ixesha likho bafethu yo. Hayi kodwa andiyitsibi iRhawuti, never. iGauteng is one of those crazy provinces. Yabona le province. Yabona this one and this one. Ngamahlanya ke aba when it comes to maths. Baseta ezinye izinto engingazazi. So if ukula province ezi2 uyazi into ba uzokhala uthanda ungathandi. Naba ndikubonisile, naba ndikubonisanga, hayi uzolila qha. Excuse me guys, I apologize for speaking the vernaculars. Now when I'm tired I resort to talking gibberish. And yeah, it's showing. Now folks, I want to show you something. When you are not given the graph of the sketch, what? When you're not given the sketch graph of the equation given, but rather something related to it, how do you respond? That's the reason I'm doing this. Okay guys, now I'm gonna move. F of x is that one minus this one plus these ones. these ones. Yeah, we can see what is happening. Then we are told here that the derivative of f, this one, is the sketch that is shown instead, not f itself. Points A, B, C are intercepts of the first derivative. Yes, we can see that. Now, special things are going to call for special dons. Number one, write down the coordinates of A. So how will we write the coordinates of A? Now, what is A, Qal? Is the y-intercept of the first derivative. So the y-intercept of the first derivative is going to come from here. When we differentiate, it's going to be plus 12. Ayi, bona ngosesiyagawula siyawarhuqa ngoku. If awuyazi uba besithetha ngantoni, hayi usengxakini umntwana esikolo. Masiye, u-A ngu-0 no-12. Qaba. Yeah, ndiyakuxelela. Okay, mandikusizele just because nguwe. Oh, guys, I apologize again for those who don't understand the Xhosa. Yeah, I see this is my language, this one. So we differentiate that expression, get minus 6x squared minus 6x plus 12. So do you see? It becomes the constant. So whenever you get this, you don't even have to write this first derivative. You just go and look there and see, like, the one that goes with the x is going to be the y-intercept of the derivative. So sishayile. 2 marks are 1 xa, niyasiqhela. So 4.1.2 says determine the coordinates of B and C. This one, easy. What are we going to do? First derivative equal to 0, and we this. So we know that, well, first derivative is equal to minus 6x. Let's not even waste time. This must be equal to 0. So this implies we do it minus 6x squared minus 6x plus 2 equal to 0. We divide by minus 6, we get x squared plus x minus 2 equal to 0. Simplify as much as you can and try your best sometimes to engage your brain so that it doesn't switch off, ne? Because that brain can switch off. So don't allow it. So therefore x at B is going to be minus 2 and x at C is going to be 1. But now we know that B is going to be minus 2 and 0. And C is going to be 1 and 0. Remember, this is on the first derivative function. So don't be mistaken. Don't be mistaken. We're still talking about the one in front of us. Not other things. So the differentiation, equating it to 0. Hey, when? Never look. Differentiation, haibo. These x values, but. The thing said coordinates, not just x coordinates. If you don't present the ordered pair, you lose 1 mark. So you get 2 out of 3. We are very strict with simple questions because, I mean, if you choke on simple questions, why are you even here? Okay, maybe you want to learn. So learn as much as you can. Which points on the graph of f? Which points on the graph of f will have exactly the same x values? X values at, as in B and in the original. What will be these ones? The turning points, because you know that these are the x coordinates of the turning points in the original function. So it's going to be the turning points. Right. Can you see, guys? Easy 1 mark. Asadlali manje. 4.1.4 says for which values of x will be this thing is increasing. Do you see we don't have the sketch of the thing, but we are asking a question. When is this thing going to be increasing? What did we say? When the y values of the first derivative function are increasing. So this is going to happen when f prime of x is greater than 0. Now, f prime of x greater than 0 means y values of the first derivative. So when is this? Is here, Baba. So this graph is going to be increasing between these 2 points. So we're going to say x must be less than 1, greater than minus 2. So that graph is increasing in between those two in the original, because we know if we overlay this, this would be the turning point, but I don't know if it is, okay, it's a maximum, I know. So if it is a maximum, this one starts with a minimum. If we can do it, it's going to be a minimum. You know, if you overlay it, you will see that the turning point becomes a max. That point becomes a min. That's if we've got real roots. I don't know if we do, so don't ask me. So I'm just trying to help you. When you can't figure it out, overlay the function. You saw this technique worked very well. So sometimes you just have to resort to overlaying by knowing the shape. So you know that the 2 marks in the back, 10 zabantathu ngo. Oh yeah. Ndilibele ubandisalwa ngobani na. Ndilibele ubandisalwa ngobani. 10 izoba yi-3 kodwa. Hi guys. Ayikwazi by 3 marks kaloku lento. For increasing, the graph only increases between the turning points, man. Ay, suka. Uyabona ke. Andiyazi 3 marks ivelaphi, guys. I don't know. Because 1 mark is for the inequalities, the 1 mark is for the values. Asizingena lento yabo. Ayikho futhi enye point where that is the case. So, see again. Velani nisiyeke. Hi guys, the Xhosa is just coming out. I don't intend to tell it, but it just tells itself. Determine the y-coordinate of the point of inflection. The point of inflection. We will find the x-coordinate of the point of inflection, the x-coordinate of the turning point of the first derivative is the x-coordinate of the turning point, of the point of inflection. So this was minus 2 and 1. When we add the 2, we get minus 1. Divided by 2, we get minus half. So that should be the 1. Okay. So obviously, folks, we are getting how many marks? Marks is ngaka. Second. We need to do the things. So we're going to say, well, the x is going to be equal to minus 2 plus 1 all over 2. Therefore, the x value here is going to be minus a half. You can say now f of minus a half is what? Let's go and substitute minus 2 into minus a half. I'm just trying to be as thorough because the mark allocation is telling me, remember guys, for 4 marks, you can't just write an answer only. It's not acceptable. I'm not saying it is not accepted here. I'm saying it's not acceptable. Pay attention to the angles. Do not pay attention to other things. Ne? Yeah. 2 into minus 1/2. Yo guys, angeke bafethu, ngeke lentsotsi idiniwe manje. This tsotsi. I thought this thing was gonna be a walk in the park, but it's proving to be a nightmare right now. Yo, banna we o no nagana go tlo etsa jwang ngwana motho o nagana gore ke papadi go etsa di-videos tsena and then ha le qeta mono ha le mfe le di-thumbs up le a shebella fela no thumbs up tlo qabana ke a le jwetsa tlo qabana. This is 27 divided by 2. As you can see, we take the x value, we substitute into the original. Remember, we were looking for the y value of the point of inflection. So this was the target. We are done here. We don't have to write the coordinates per se. That was the target. Finding this was part and parcel of the job. Substitutions into the original was part of the job. And the method of finding that x coordinate is also part and parcel of the job. But if you didn't know what to do for the first part, you take the derivative, second derivative. So second derivative must be equal to 0. We already know that. So when we differentiate that, we get minus 12x minus 6 equal to 0, minus 12x equal to 6. Therefore, x is going to be minus 1/2. After this, we go straight into the next step. Unfortunately, that next step cannot be skipped. It's the final Gorman pathway that takes us to the answer. Now let's finish this thing. Inkathazo ngoba kuseGauteng vele phandenza imetric yami eGauteng guys. Siyakhala kula province. Ke maboneng man. Ha re dule mafifing Gauteng kwana. Re dula maboneng le bosiu o tshwana le motshehare. Hey. Ho potlakiwe hampe man. The tangent at P, which is this point, so of the curve is given by this. The tangent at point P, which is 3 and minus 10 to the curve, is given by y is equal to minus x squared minus 1. So what is that? This is the first derivative. Because if it's not the first derivative, I got a guys, it's a right question. But again, but know what a tangent is always a straight line. You see the things I told you before that, yes, in general, we assume that a tangent is a straight line, but it may very well be not. And you can see this is a quadratus. Quadratus is not a straight line, but it's a tangent still. So it's a ring here. How not your next? It's let's overlay. I think the overlaying is gonna overlay things. Does it have real roots? At this point I'm nanjaba. So we said our graph. Is it our graph or is it our graph? Let's overlay just to get the vibes. Just to get the vibes going. So this P is a point in the, yes, fourth quadrant. Is in the fourth quadrant. We saw that this one was what? This one was 1. So we can say, yeah, man. Therefore, this means 3 is here, somewhere here. This is minus 10. Now, what is happening now? We want this tangent here. So let's draw this tangent. The tangent, is it a straight line? No, it's not. We can see that this is a quadratic, but this quadratic is a grumpy face quadratus. Grumpy face quadrat. So the quadrat is quadrating. So what does this mean? It means this lovely tangent is probably, this one is one of those that have a minimum value at -1. So this thing is like this. Yeah. I'm just doing it bad now, guys, but it's supposed to be nice, but yeah, it's not as nice as I wanted. Yeah. But you get the feel. Hi, this is a parabola with a minimum value of -1. You know almost this one. Right there, we're sitting at -1. Can you see it is a tangent? Because it's touching. Now, these are the two curves touching at one point. Siyathintana, siyahlebelana. Zithi, hayi man, khoniphendule man. Usazondibona nini kaloku? Masifuna ndikucenge kaloku. Nandicengi kaloku, uyandazi mos. Ndingababhuti baphambeneyo. Cinga niyarhudisa mos. Iyarhudisa. Oh. Funa urhuda thina. So this is the things. Can you see? How things are crazy. You never saw a tangent that is not tangenting. But it's tangenting even though it's not the typical tangent. Right. Now it says line PT. I did the constructions. Line PT drawn perpendicular to the x-axis with T on the x-axis. Hey, line PT. So this is the point P, the point of tangency. This one was the one. Now we've got PT on the x-axis. And this is drawn perpendicular to the x-axis. So this means the T is right there, where that is. And this point is 3 and 0. Yo. There is it. So sithetha ngalomca. This lane. It says now, okay, determine the length of RT. Yawena. Hey. Where is RT now? Emanya. Intersects the x-axis at point R. Hayi ke ngoku sesiyaqabana ke manje. Awana he manje riyaqabana jwale. The tangent at P to the curve is given by, yes, intersects the x-axis at. This graph does not have x-intercepts, Mos. The graph of the tangent doesn't have x-intercepts. Yabona ke Gauteng niqalile undihlanyisa ke nini. Yabona yonifuna undigulisa ke. Yabona useniyandigulisa ke. Phela that equation of the parabola cannot intersect the x-axis. It has irrational roots. The discriminant is negative. So what do you mean? Yabona ke. Yabona ke ngoku. Nansi ke ngxaki. So many marks is such a good question, poorly referenced. Because, wow. What a wow. That parabola will not, guys, so tingengu. I'm not happy. I am not happy. It would have been a nice question. Determine the length of RT. I'm trying to figure out what are they trying to get to. What are they trying to get to? But this whole thing has failed now. Yo guys, it's been 8 hours of talking. I'm just trying to find a way of persisting, to do this, but it's not doing it. It's really not doing it. Because these guys have lied to our faces now. They have lied to our faces. But what I'm going to do, I will do something rather decent. You see? Let's do this. Let's modify that graph of the tangent. Yes, the point of tangency has not changed, but we're just changing this and saying +1. I suppose they wanted to say that because, if the minimum value is already negative, it means irrational roots, it's flying. So we know that, okay, let's assume, what did we say the coordinates of A were? It's 12, okay. Fine, we can just say, fine, this graph looks stuff like this now. Right. Okay, that's the point of tangency, and we know that the y-intercept is also the turning point at 1. Okay, this is the tangent y is equal to minus x plus 1. Right, so we can see that the x-intercept is going to be r. And what we were being asked is this distance. What is it? So meaning we need to find, but again, this question sucks, guys. Determine the length of RT. Why not RP instead? RT is too obvious. It's too obvious. The x-intercept is going to be at 1 and at -1. So are you really asking me for 5 marks this question? Nah. Nah. Oh, wait. Wrong impression. You are not needed here. Okay, now I can see why. Everything is correct. Wrong interpretation. As you can see, guys, when you're tired, there's nothing you can do better. You just suffer. Okay, now this is a totally different question. It has nothing to do with 4.1. Oopsie. Forgive the guy. So we've got y is equal to minus x minus 1, minus x squared minus 1. Ne? Yeah. What touches the x-axis is the tangent, not the graph. Okay. Right, so let's draw the graph. So this graph, we saw that it's a parabola with a minimum value that is here. Right. Okay, so that is the graph. And then there's a tangent at point P. Now we're going to assume this is our point P. There is the tangent. Doing the tangent things. Right, this is the tangent. And this point, the point P, which is 3 and minus 10. Okay, so this is -1, the minimum value of that function. So this cuts the x-axis at r. Now, I get it, guys. You see, you can't do these questions when you're tired. I advise against that thinking. If you are thinking like that, just drop the thought, guys. It's going to cause you problems. Don't even think about it that way. So we were told that this is point T on the x-axis and this is perpendicular. So we already know that this is 3 and 0. Now point R is basically x is to 0. So the question is, we need to find that x value. So this is a good question after all. So we need to find the equation of the tangent. From the equation, we work out the x-intercept. From the x-intercept, we can now work out this distance, RT. So because this is what we want. Okay. Right. So let's keep moving, guys. Okay. Yeah. I bendizithanda-ke eza questions, but I'm not sure uba ndizenzile somewhere. Let's finish this one and see how many we can squeeze in. Right, so point of tangency serves two purposes. First, the gradient at a point, and we already have the point, so this is good. We can find the equation of the tangent. So we can say now, well, at the port, we know that the first derivative, in fact, this time, we understand that, this one is going to be quite silly. dy dx is equal to 0 at x is equal to, is it? No. It's not 0. dy dx is going to be equal to, let's see, it's going to be minus 2x. It's going to be minus 2x. We can say, therefore, the gradient of the tangent is going to be minus 2 is to 3. Right. Minus 6, that's good. It's not bad. Yeah, this one was a bit nasty, ne? It was a bit nasty. But we do what we can do and see what is left of it. So we can say then the tangent, maybe because we're not answering the final part, we can say also the tangent is going to be y equals minus 6x plus c. When we take the port, so this is minus 10 is equal to 6 into 3 plus c. Therefore, c is, this is 18. When we take it to the other side, it gives us 8. 8. Makes sense because the y-intercept is positive over there. So we can say, therefore, y is equal to 6x minus 6x plus 8. We can then say r is such that minus 6x plus 8 equal to 0. This implies minus 6x is equal to minus 8. Therefore, x is basically 4 over 3. Makes sense because, again, you can see that it's not very far from 1. It's 1 comma some change. So we can say this implies that RT is going to be x at t minus x at r. It's a horizontal line, which implies that RT is equal to x at t was 3 minus 4 over 3. Therefore, RT is, this is 9 minus that is 5/3. Units. Sure. As you can see, sometimes if you don't understand the question or you misunderstand the question, you end up in some serious tsunami. All right, so of course, guys, if you understood the question, remember the sketch is just to aid and get into the habit of sketching these things even when they are not needed, so that you can get to do the right sketches for the right questions. So first thing, derivative, and then getting the gradient, substituting the point, getting the x value, I think was key, the final answer. Yeah, easy, 5 marks, and take the 17 marks. Okay, easy, yes, if you understood the question, but if you did not, and I'm happy sometimes, as I often say, if I make a mistake and you are watching, you start to see what leads to problems in these exams. And no one is perfect when taking an exam. Because remember, questions like this you read for the first time. Sometimes you've never seen a question like it. So it's very easy to misunderstand. But look at how everything didn't make sense. You know why? Because I drew a sketch. If I didn't draw a sketch, I was going to do calculations that were going to lead me to hell instead of heaven. You see? So as you could see, drawing a sketch assisted me to realize how senseless the question was. I even tried to correct the question because I thought I was correct. But then even when I corrected the question, it wouldn't make sense for me to even think about it. So as you can see, when something is wrong, something is never going to make sense, so that you cannot proceed. And then you rethink, what is happening here? Yeah, man. It's another things. Hey, guys, time is not on my side. This one, practice. It's a good question, but practice this one, guys. It is a good question, but I don't think if I do this question, I'm going to win. Maybe I can make it one of those questions that can just fall from the sky in the channel. So stay put and stay watch. If I can finish these two, but there's a type of a question I want to close this session with. You know, there is a type of questions that this session must be closed with. So let's see how well we do with these ones. I'm not going to add extra questions. I'm not going to add extra questions. I'm just going to solve. If time allows, we're going to squeeze in that last one. So that, guys, I leave you with everything that you should have. And hoping that this course has been what it should be. It's going to be definitely a long and boring one. But Lisejo wanted a long course, and I've never done anything as long as this. It's the first time. Okay, let's see, guys. I still have some time before my next class with my students. That's if they will attend. I would be happy if they don't show up like they did yesterday. But anyway, I told them I was going to go to a funeral, and I knew that there were two things. It's either I was going to come back tired, which was the case, because I did come back, but then I waited for like 30 minutes because I did tell them that if I didn't say anything that class is cancelled, they must come through, and they did not. But I understand. They were supporting me somehow, so I'm not angry, guys. I'm not angry. You were considerate. Indeed, I was tired. I was going to be useless. I wonder how am I going to be today since we are doing what we are doing now? Will I have the energy? Yeah, there are some other things, guys, I wanted to talk about, but I think let's rather not at this stage. So we've got f of x is equal to minus 2x cubed plus ax squared plus bx minus 3. Right, so this is the function f. Now these questions were quite popular back in the days, up around 2019 or so. I see them less and less, but yeah, get used to this style where the a value is given and maybe everything else may not be given, but we are given an extra, the y-intercept. We know that it's minus 3. So we can already see that this point is the point 0 and minus 3. That's the first thing. And then looking at the coefficient of a, this shape of the graph is what we expected indeed. Okay, cool. Now D with 2 and 9 and E are the turning points. You see, this is what we want to hear. First question. Determine the values of A and B. Again, this is to say when given just the turning point, maybe a partial equation, and maybe a y-intercept indirectly, which is the extra point. What can we do with it? Well, even the turning point alone could actually do us very well because, yay. But what we do need something extra anyway. Let's see here, guys. So we know that at D, what do we know? We know that the graph of f is 9. So we know that f of 2 is equal to 9. So this implies, you see, minus 2 into 2 cubed plus a into 2 squared plus b into 2 minus 3 is equal to 9. Now this implies this is 8 by 2, this is minus 16 plus 4a plus 2b minus 3 is equal to 9. Can move everything else to one side. Yeah, this one, let's see. 16 minus 3, this is minus 18. We bring in to the other side, it becomes plus 18. So we can say this implies that 4a plus 2b is equal to 18 plus 9 is 27. All right. I hope this is good. So we can make this one equation 1. Second, also, what do we know? We know that the first derivative at D is equal to 0. Sometimes do show the first derivative here so that you can earn some marks. So this is going to be minus 6x squared plus 2ax plus b. That's what is cooking there. This implies that minus 6 into 2 squared plus 2a into 2 plus b is equal to 0. Now this is 4 times this is minus 24 plus 4a plus b is equal to 0. So we make this one equation 2. In fact, we can even go on and conclude that 4a plus b is equal to 24. Just want to entertain this elimination technique. So we can just say, well, from here, we've got 1 minus 2. So this is 4a plus 2b equals 27 minus 4a plus b is equal to 24. Just so that we can explore all these techniques. So we know that these guys are going to do it. This one is just going to give us B. 27 minus 24 is 3. Hey, injalo. Never. Ayikho njalo. Kufo nje. Kwenzeke ntoni? Kwenzeke ntoni? Why do I know, guys? I know because the equation didn't come out like that. So B is the coefficient of x here. So you see it's 4. So I'm getting 3. Something is not right. Something is not right. 8 times 2 is minus 16. Right? Then this is 4a. This is 2b minus 3. Then we saw that this is equal to 9. Okay? Minus 16 minus 3, it's minus 19. Yeah. So this gives us 28. See, mistakes okay, Baba. They okay. So don't cry. Don't cry. Just find it. Can you see when the steps are nice? You can find it. Do this when you're fresh, guys. Don't do it when you're tired. It's suicide. Telling you. Right. Okay. Okay. All right. So now we can see that yes. B. If we didn't know, these questions without giving us this info. So sometimes this highlights. Be aware of what you are doing and make sure you can trace every step. After finishing, go back. Double check if everything is good. Because as you can see, things could easily go wrong here. So we can say this implies that 4a plus 4 is equal to 24. Therefore, A, I'm moving fast. 24 minus 4 is 20. 20 divided by 4 is 5. So therefore, sigqibile konke besiyibuziwe ngaphandle kwalezi. So we're done. So know these things, guys. So substituting that point and finding this equation is key. Knowing the derivative is going to be 0, I think it's more important. And then this equation. Then the method. Mathematics says ninzi kakhulu. Then we didn't know what these guys were. 1, 2, 3, 4. Well, we can drop a mark and say, okay, whatever. It's your own problem, but yikes. Hey guys, I don't think I will finish. I have to delay my class until 8. Let me communicate with these guys so that they don't attempt to come through at 8. I can already see that I won't make it to past. For what I'm trying to do, it's not gonna work. Let me move the class to 8 o'clock. Okay, I've just done it. Yeah. Now let's see if we cannot complete what we wanted to complete. Done. So let's do 6.3. Okay, let's just do it in a new question. So 6.3 says determine the values of x for which f prime x is less than 0. So 6.3.1. Now this is the gradients. When are the gradients of this graph negative? Past this turning point, excluding this 2. So from here, going this way, we can see the gradients are negative. If you just draw a tangent on a section, you will see it is negative. And then also, if we just take another point, the tangent there would have a negative gradient up until this turning point. But now the problem is that we don't know what that turning point is. So, ba re qhekanyetsa jwale. Ba re qhekanyeditse ke a o jwetsa. So how will we find it? So we need to do our background check. Remember, this is your rough work. You don't need to show it. So we can say f prime x is going to be minus 6x squared plus 10x plus 4. F prime x, let's see if we can factorize. I think, yeah, let's try. First, we take out the highest common factor, which is 2. Then we end up with minus 3x squared plus 5x plus 2. Therefore, f prime x is going to be 2 into, right, so this is going to be minus 3x. X to get a 5, I'm going to have a 2 there and a 1. This must be the case. Why born? So we can already appreciate that this is going to be minus a third. So of course this is the RW. Nobody asked for this. So we can just answer the question and say, yeah man, come here. Answer only. When is this the case? It's when x is less than minus a third, or when x is greater than 2. Because we can see that's what happens. And of course, guys, because we're in the teaching mood, I need you to know, there's nothing wrong in going about f prime x less than 0 means minus 6x squared plus 10x plus 4 less than 0. And then we divide by a2. What do we get? We get minus 3x squared plus 5x plus 2 less than 0. We divide it by a positive number, nothing changes. We factorize. Minus 3x minus 1, x minus 2 less than 0. On the Cartesian plane, we know that this graph is like this. The graph is like this. So if I'm looking at this and this, I know that these roots are going to be both negative and positive. Where's my turning point? Is to the right. So it's going to be like this. Superb. That's what I am talking about. Yeah, guys, I'm sure you're bored right now. This is what... Is that how? Hey, Posisile boy. There's no way f prime x would look like that. But rather like so. Now we are talking. So this would be 4, this would be minus a third, this would be 2. Now when is this graph less than 0? Over there. Over there. So we can already see that conclusion, x must be less than a third, or x must be greater than 2. Now you can do it all and just present the answer only to avoid unnecessary problems. As I said, when a question is just 2 marks, it means other things, even if they are significant, you can do away, then come and bring it here. Okay, that's what is important. So that if anything you write is incorrect and you end up with a correct answer, you don't get penalized, because that looks like you have copied, but rather, unsuccessfully so, because you can't do incorrect operations and get the correct answer. But if you put it as RW, it means the mistake that you made, sometimes you can ignore because you may have noticed it and then corrected it in the final answer. Hi guys, banifundisa kamnandi kanje. Ukhona angiqondi. Masiyeni kodwa nomsebenzi, masingapolitiki. Ayidingeki nje leyo nto leyo. Sekuphapha nje. Seniphaphile, ngiyaxolisa. Niqorisa kakhulu. So 2 marks, guys, for these. How you got them is not a problem. The answer is what matters. Okay, 6.3.2. Now, when is this graph going to be concave down? Very easy. So we know that this is going to be concave down when x is greater than, because we're looking at this graph, we know that it's going to be greater than the x value at the point of inflection, which might be there. Maybe. This is the x at the point of inflection. Maybe. So what is it? It's going to be minus a third plus 2 all divided by 2. Therefore, x must be greater than, let's see, this is going to be 5 over 3 divided by this is going to be 5 over 6. Done. Cool. Sishayile, the method and the answer. 2 marks. Whoa, yeah, maybe the inequality as well. I went 10 go. Knowing the inequality is going to be greater than, we can even mark it here. That's if we used that technique. If you did not, you know what technique to use. Hi guys, njaninika noba niyakhala. Unulile mawufuna ulila. Second derivative must be less than 0, right? For concave down, in principle. Now second derivative, we differentiate the first derivative. So this is going to be minus 12x plus 10 less than 0. Transpose minus 12x less than minus 10. Divide by 12. You can say therefore x, if you divide by negative, the inequality changes. Then 10 divided by 12 is going to be 5 over 6. It still comes up, no matter what. Now this one would be nice because second derivative, the equating it to 0 or less than 0 story, the final answer gives us a nice 3 marks. So this means, yeah, at least we should not see the answer only for 3 marks. Right, yo guys, yaphela 9 hours ngoku sisebenza ngeke. So this one is another answer there. So this one is 6.4. Okay, another question not answer. 6.4 says, determine the equation of a tangent to the graph of f at this point in the linear format. Now we're gonna move fast, guys. We need the pot so that we can cook the things. So it's gonna be f of minus 1, which is gonna be minus 2 into minus 1 cubed plus 5 into minus 1 squared plus 4 into minus 1 minus 3. Therefore, f of minus 1, this is minus 1 times minus 2, this is 2. This is going to be 2 plus 5, that's 7. 7 minus 4. 7 minus 4, 3. 3 minus 3 is 0. Ha, ha, ha. Ke noto. Orauri. So this means this is this x-intercept. So we want the tangent at that x-intercept. Ke masosele ya engadingekiyo. So that's the tangent. So we can already see, guys, that if we produce it, the y-intercept must be negative. So, see. So at the port, this is what we have. So therefore, our port is going to be minus 1 and nothing. That's the first thing. And then, of course, we can say also the gradient of a tangent is going to be the first derivative of minus 1. Now, the first derivative is minus 6 into minus 1 squared plus 10 into minus 1. Was it? Yeah, plus 4. Which, this is 1 minus 6 minus 10, that's minus 16, plus 4, that's going to be minus 12. Ne? Yeah, I don't trust myself anymore. I get it tape. Yes, minus 12. Again, it's a steep gradient, it's negative, I'm happy. Then, the tangent is y equals minus 12x plus c. We take the pot, say park. Yes, 0 is equal to minus 12 into minus 1 plus c. Therefore, c is going to be minus 12. Therefore, y is minus 12x minus 12. Makes sense because that part is still an x-intercept of this graph. So this is good. Is good. Sure. Yeah, ne? The finish at this, guys, I'm gonna vele ndiyolala. Zange ndasebenza kangaka. Ndiyayiqala le. Kila mathomo, finding the port, finding the gradient, sapicity chushiu. That one, easy 4 marks. Siyivale lezo. Is there more? Phelile. Iphelile into ibithethwa. Now guys, this question is nice. It anchors very much on our beginning of the lesson, you know. That's why I didn't want to leave it. I'm just changing the position now. I'm sitting in. I want us to take down this question. so that we can have a peace of mind. Right. Of course, in the class, guys, there's a lot of things I say, a lot of points that I would not waste my time saying here. Those ideas are golden. So make sure you attend if you're in our group. Don't find yourself trailing. Now we're told in the diagram below, f of x is this business. Hi guys, Senkatel enilambile yo yonke ndinyakanya. So that's f. Okay, the coordinates of L and M are, okay, these are the x coordinates. One and two. Okay. Respectively. Okay, the average gradient, hear that. That's the word we spoke about. The average gradient between L and M is 5,5. Do you see that? Because a gradient between 2 points on a curve is an average. It's not a true gradient at each one of those 2 points. So this is the gradient of a secant. Do you remember how the secant brought us the tangent expression, which is the very differentiation that we do? Okay. Now we're told here that the equation of the tangent at x is equal to 6 is given by that business. So this is when now we're taking you from, bottom to the very top, honestly. If you know what to do here, you will win. So again, these are the questions the students who wrote so for the first time to survive. So it was a trial question. As you know, trials, guys, pack us like never, ever before. So they actually are killers. So try not to die because of trials. Okay, let's get to business. Show that A is a half and that B is 3. My throat is dry now. Getting a throat situation. I need to drink something. Right, folks, let's get to business. So what do we know? We know something, that this graph passes through the origin. So there's a point. The y-intercept is 0. So that is a point on the graph. But is it going to help us? No, it won't. So what are we going to do? Whatever we want to do. So now let's talk about it. How do we do the average gradient, Kanin? You remember. You remember average gradient is going to be f of the 1 point, which in this case is going to be L. M. You take the point ahead minus f of the point before divided by x at M minus x at L. I remember. Diakumbula. So that's how we're going to go, guys. So don't forget basics. They will leave you crying. We're told this is 5,5. Now, we just substitute 2 there. So this is going to be a into 2 cubed plus b into 2 squared minus that one at L. We substitute again. It's going to be a into 1 squared, a cubed, plus b into 1 squared all over 2 minus 1. You see. The denominator is as good as not there. but it's certainly not 0. So we simplify these expressions, we get 8a plus 4b minus a minus b. You see this? You see this? Now we can say, therefore, 5, 5 is equal to 8 minus 1 is 7a, 4 minus 1 is 3b. This is equation 1. Can you see we derived an equation from what you would be like, qala ngaphi? Qala khona la iqala khona. Basics are always going to find you hanging. The second thing, guys, we know without a shadow of doubt that the gradient at a particular point, this point is given to us, 6. The gradient at x is equal to 6 is going to be the same as the gradient of a tangent. So the gradient on the curve at x is 6 is the same as the gradient of the tangent at that very same point, because they share that point. So we're going to say also, we know that the first derivative of x, maybe let's just say the first derivative at 6 must be equal to minus 18, right? Here you can do yourself a favor and do the differentiation. 3ax squared plus 2bx, that's it. So we do it here. We gotta have 3a into 6 squared plus 2b into 6 is equal to minus 18. Simplify, this is 36. 36 times 3, is it 1 or something? Is it 96? Is 96 must? I think it's 96. 36 times 3 is 108. Hi man. Bendiyiqondile lizoba 1 over izaba 1 some change 12b minus 18. Yeah. Ayibona, masike si-enjoy i-eliminase ngoku. Asike siqhubeke nje si-eliminate nje, ndike ndikufundise uku-eliminate. Yintoni esingayisusa lula apha? Ewe. We can do a nice elimination or a bad elimination, but let's do a nice one. Let's do a nice one. We're going to say equation 2. Then 2 minus. Now, what do I want to get rid of? Is this 12b. Okay, because this is too big. I cannot get rid of it, but I think I can do 12b. So I'm going to say 4 times equation 1 is going to be, now let's take equation 2, 108a plus 12b is minus 18. Subtract, that one is 4 times 7 is going to be 28a. 4 times 3 is going to be 12b. 4 times 5, 5 gives us 22. Good. So we know that this 2 will go. So 108 minus 28 is going to be what? 80. 8, ne? Is going to be 8. Yeah, so we've got 80a equals minus 18 minus 22 is going to be, sorry, yeah, minus 18 minus 22. Ndibale kahle. Ke 40. Ne? Yeah, that's the one. Ke 40. So therefore A is indeed minus a half. Sibuye nayo phansi sikhuphule emazantsi. This implies that you can choose any simple one. This implies that 5, 5 is equal to 7 into minus 1 over 2 plus 3b. I'm just going to say therefore b is, now what we're going to do, we're just going to say 5, 5 plus 7 over 2. It's 9 divided by 3 is 3. Shabile, 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 and buried. Yabona? Because guys. So ndinika for every time now. Whether ufuna ubhala June, May, June exams eziqatha okanye ufuna ubhala June lo soft ka-matric, or ufuna uyobhala i-trials iqatha, or ufuna uyobhala i-final which is in between. Uyayifumana? I so wish i-finals bezingaqina ngqi. Ya, ningazodlalela kwi-finals. Cinga kuyadlalwa pha. Because funeka sisifte guys, maninzi gqithi ngoku nigcwalisa i-universities niyotoyitoya lapha niyosibangela isicefe. Thina sifuna ufunda, sinaxesha lokubhanqa benu. Beniyofundekela, unganisifasa ngasibhatalanga. Hey, sukani nje endleleni yethu. Nathi besilala singadlanga e-university. Mna for one benilala nje sonke neti ngenamali yokutya. Uyafumana? So guys, we all start somewhere. But we can't just make noise because kunzima. Oba bunzima busifundisa uba sibe ngabantu. Yacinga bendingazange ndisokola apha ebomini. Do you think bendizawuba nomdla nje ukujongana nani ndinifundise i-maths ne-physics? Bengendiyenze loo nto, ne? If you just didn't catch what I said, guys, sometimes struggles, they shape you. They shape your character. They shape your attitude. Your temperament becomes a bit better. You don't become emotional and impulsive. You know that no matter you become like that, you are going to stop, because problems are not going to go away because you're anxious. They're not going to go away because you're depressed. They're not going to go away because you've got suicidal ideation. They're not going to go away because you have someone to blame for your sorrows. You will face the problems when they come. And if you stayed long enough, you might just be lucky and make it through them, which is the best way. Because to have someone shield you from them, that's a disaster for later. Remember, later it matters what you do and how you do. And the success is almost a necessity at that time. So you don't want to fail when it matters the most. Right now it doesn't, but take it, because when you fall, someone is going to pick you up anyway. But I wish someone who picks you up only picks you up and say, hey, look around, Baba. Where's the hole you can run to? Try it. They must not take you through the hole. They must let you find the hole and get through the hole yourself. On the other side, you're going to stand victorious and very proud of yourself that you did stuff by yourself, for yourself, and perhaps for the greater good of all humanity, if you be dedicated to such a cause. Right, let's not talk. We're almost done anyway, because I knew that our troubles were this first one. So how do we do this, guys? Yo, kuninzi. 1. As marks is imbalwa futhi for le nto esiyenze apha. That one zimbalwa kakhulu. That one. Method. 1, 2, 3, 4. Tonenye singayiniki marks. Yeah, this derivative siyinike. Besizixelelwe mos. Besihlebele bazizo eziya. Yabona? Khala intonga apha. Bethwa intonga ebusweni. Ikuvala amehlo ngoku uzama ukuwavula. Xa wavala kuthi wavalela ntoni? Wavulwe ngenye intonga futhi. Phinda uthi usaqalaza ungaboni, ubona inhlanti awuboni. Ubonisa ngenye iklap nyana. Hey, akwabona xa sowubethwa sana uqonda babona ngubani ayi nabantu khupha umthethe. Andiwazi umthethe yintoni nge-English. Yeah, you will tell me. 7.2 says the equation of f ndiyilibele ndiyayazi uba yintoni uChris. Athi nguChris. You know, when you iron your trousers so that the crease is nice and perfect, is erect, and is not going sideways. Yes, uyaqondiswa ke lapho, you are being ironed. Uthi ke xa uqala uthi give up ngoba soka ndiyayekuthe yewena hlala phaa qhabo phambane. Heyi vele ubone na uba yabona ngoku ziyaduma emzini wezinsizwa. Right. 7.2 says now, if this f of x is like that, of course, guys, this was already giving it. Determine the coordinates of n. N is the turning point. Now, the turning point, we know what to do, right? So we're going to say f of x equaling minus half x cubed plus 3x squared. So at n, we know that the first derivative must give us nothing. Let's do it. So this is going to be minus 3 over 2 x squared plus 6x equal to 0. Highest common factor is khale uthathe half, but xa ndithathe half kuzakwenzekani? Kusala bani? Increase le masiyeke lo nonsense. So it's going to say x into minus 3 over 2x plus 6 equal to 0. Therefore, x at n, remember, 0 is coming up, but we're not interested in that. That's where the turning point is, but we're interested in the other one. So this one, when you transpose, it's going to be minus 6 times 2, that's minus 12, divided by minus 3, it gives us 4. Ne. Ithi ndiyijonge. Minus 6 divided by minus 3 over 2. Yes, Oskov. So we can say then f of 4 will be, I'm not going to do the substitution, you do it. Ngokwakho mntwana wesikolo. Musa ukwenqena. Mntwana wesikolo. Musa ukutswafa. Ngwana wa sekolo. Ke mathata a hao. Ako waqete ka buwena he. So therefore, n is 4 is to 16. I'm sure, guys, you can already see now that, yes, it's labor intensive, this topic, but it's very nice if you have the basics in check. As you can see, I'm not really struggling to get around, but it's some serious work still. So the first derivative, yeah. Equating it to 0, yeah. Factorization, yeah. Finally giving us what we want. Because nansi into besiyifuna, besingafuna ezinye way. 7.3 says the graph of f is concave up for x less than k. Can you see they're just giving you some mathematical stuff? Find the value of k. Obvious. We want the point of inflection. So k is the x at the point of inflection. How do we find it? Average between the turning points. So this is good. So we know that x is going to be less than x1 plus x2, all divided by 2. Maybe we can even say this nicely because this one has names: x at n, x at o, divided by 2. So this means x is less than x at n. We saw that it's 4 plus that one at the origin is 0 divided by 2. So therefore x is less than 2. So this means M is the point of inflection. Ke boy. Re qetile. O no nahanang. Method. Answer. Even though, I mean, come on. Why not? But if you write an answer only, you'll get 3 marks, guys. You won't. Look what happened. Calculate. Now we have to see it. Unfortunately, an answer only is a no-no. Right? Or, if we can't solve it otherwise, we go algebraically, Baba. We know that the concave up is when the second derivative is greater than 0. Ne? Then, let's look at the second derivative. Second derivative, we differentiate the first derivative. So this is going to be minus 3x plus 6 greater than 0. Minus 3x greater than minus 6. Therefore, x, when you divide by negative, inequality changes. Yes, you know what happened. We born. Now, differentiation equating to 0. Answer. Sharp. Yo, sayigqiba inyaka. Now, what about you? This was a good question, though. This was a good question. Do you really want me to show you guys this thing? Like for real. Okay, ngoba sesihambile. Sesihambe kakhulu, masivele sesihamba vele. Bese sizivinca zonke as questions. Masivele sibe sesihamba, guys. Question 5. Hi, f of x is equal to x cubed minus 12x minus 16. Now, what do you notice, guys? The b term is missing. Remember, f of x is usually ax cubed plus bx squared plus cx plus d. Do you see here that this is missing? Now you'll notice trends that when this is missing, it's already telling us that there's going to be a repeating root. But it's not always the case. Remember that even when it's not missing, we do get it. You saw in the example we did above. But when we see this, without a doubt, once we're missing that b term, we know that one of the x-intercepts is going to be a turning point. Okay, let's go. 5.1 says calculate the coordinates of the turning points. So we know that the first derivative must be equal to 0. We differentiate 3x squared minus 12 is equal to 0. This means 3x squared is equal to 12. This implies x squared is going to be equal to 4. Therefore, x is going to be plus or minus 2. Done. No, not done. So f of 2 gives us what? 2 cubed is 8. Minus 24, so this gives us minus 16. Minus 16 gives us minus 32. Is that so? Use the calculator to double check before you run a risk. Yes, we are correct. And f of minus 2 will be, this is minus 8 plus 24, that gives us 16. 16 minus 16 is 0. And the box. Ibiana. Let's do it. Minus 3 cubed. I want cubed. Minus 3. Wayibona. Irifile qanda. What did I say? If the turning point is at the x-intercept. You see there was a repeating root there. So this prediction sometimes, guys, might save your life in some situations that demand as much. So you can say, therefore, the turning points are 2 is 2 minus 32 and minus 2 and 0. Because the question said coordinates, not one coordinate. So first and foremost, for these 5 marks, the derivative, equating it to 0, these 2 points, and the substitutions into the original. Of course, any suggestion thereof. Remember, we want the ordered pairs. We didn't say we want one of them. We said we want all of them. Okay, that was 5.1.1. Okay. Now 5.1.2 says, we want the x-intercepts. Can you see the examiner is secretly giving us a free pass of not going through trial and error or checking out things. We already know that that's an intercept, so that means x plus 2 is a factor. So folks, we know that f of x is equal to 0 implies x plus 2 into the quadratic things. So this is going to be x squared. If I already have 2, how do I get to minus 16? I get minus 8. Now I'm going to focus on the middle term and say, fine, this one is the only one, so I want 12. So I already have minus 8x. What must I have to get to 12? If this is 2, then this must be 2 as well. I need 4. So this must be minus 4x, isn't it? Because minus 4x minus 8x is going to give me minus 12x. This one and that gives me x cubed. That one and that one gives me minus 16. So this is fine. Now we factorize further. So this is x plus 2. This is x. This is going to be minus 8 plus 2. Can you see the repeating root? We predicted it. Here it comes, right in our face, saying, hello, how are you doing? Did you find me? Damn, you're good. You're very good, brother. You understand that you understand things. Right, I do understand that we understand. What were we looking for? X-intercepts. Remember, these are points, so we can say, therefore, x-intercepts are these points here. Minus 2 and 0 and 8 and 0. There's a repeating root here. You can say it. Or there's a repeated root. Repeating root, repeated root. Of course, you would have said here x is minus 2 or x is 8. Excuse me for forgetting. I'm not trying to tell you not to do it. Ishap. Drir marga. So basically, we needed to find this quotient and then factorize it. And then give the points. 3 marks. Yeah, pelile. Nobungalila. Nobungangalili. Indaba yakho leyo mnandi ugqibile umsebenzi. Whether you cry, whether you don't, the trabajo es terminó. finish and clar. So 5.2 says y is equal to 15x plus p is a tangent. I told you, cannot finish a cubic function without being asked stuff about a tangent. First in your term 2, second in your trials. Then in the finals, we may decide if we want or we don't. Okay, look at me trying to make myself look like one of them. I am not one of them. I imagine myself as one of them. In fact, could have been, should have been, may have been. How about will be? Still possible. Not possible at all. Calculate the x-coordinate of the points of contact. Meaning the port. This time we want imbiza. Sinikezwe ukutya ngoku sakuphaka sakubeka pha sathi fumana le mbiza apho ukutya kuvela khona. Where is the port? Let's find the port. Let's find the port, guys. So what do we know about the port? We know that at the port, yes, at the port, the gradient of the function is the same as the gradient of the tangent. So we know that the first derivative at the port is going to be 15. Let's do it. So this implies that 3x squared minus 12 is equal to 15. So 3x squared is equal to, move 12 to that side, we get 25. Is it? Oh, 27. This means x squared is 9. Therefore, x is plus minus 3. This is the port. This is the port. And remember, it said point or points. There was a catch. It says so we're going to say f of 3 by 27 minus 36 minus 16. Yes. Sivele siyenze nje kakuhle singancami. Yo guys, ndiniwe man. Ikhona ke question heavenly eyasezulwini. Eish. Ngcwele yemimangaliso. Minus 25. Sithola yena ke bafowethu, minus 25. Hey. Hayi injalo. Ngizawenza njani? And f of 3. F of 3 ngibani? F of 3 ngibani yena? Hayi man, not 3, minus 3 this time. Tenza ntoni ngoku? Kirabiyana biyano. Let's go and change the sign. Yo. Yeah, guys, you will see these exams can text you, ne? Minus 7. Yeah. And sayithembi yonke ke lenyanya. 10 zonke zaba negative. Hey. But anyway, minus 7 is bigger than minus 25, meaning this turning point is a maximum and that one is a minimum. All right. Looking at the shape, where do we start? We start with the maximum. It's the first one. Minimum. As you can see, the order of those x coordinates already tells us which one was which. Now, what was the question? Determine, okay, there we can say, therefore, the ports, hey, ezimbiza zimbini, guys. Nansi yokuqala, 3 is 2. In fact, masizibhale nje in the correct order. So this is minus 3, minus 7. But it makes sense because the shape of the graph, looking at this graph, it should be stuff like so. So you can see the first turning point is the maximum. The second turning point is the minimum. It speaks its own language of truth. Believe it if you want. Deny it if you want. Whatever you take, your perception is fine. Your choice. Sitsho njalo ke xa sitsho. Now, knowing that the first derivative is going to be equal to 15 and doing the actual derivative, Nazia, 4 marks in the bag. Everything else, your problem. Now, 5.3 says, for which values of x will the function be concave up? As you will see, concavity, guys, keeps on popping up. Concavity keeps on popping up. So when will this be concave up? I think let's just use the differential calculus. Second derivative must be greater than 0. Let's differentiate. First derivative, answer. Second derivative is going to be 6x is equal to, hey, nansi into senzeka, umhlola obomvu. Nanku umhlola obomvu. 6x is greater than 0. So therefore x must be greater than 0. Yo, ayibona? Point of inflection is right on the x-axis. How interessante. Itsho lento, khange kutsho mna, kutsho yona. Eva yonke lento. Mna ndithethanga nix. Ndendazithulela nje, ndathi cwaka. Eva yonke lento, khange ndithethe, ndendathula. Ngivele kayitshela tsaka dintho jwale. Sesatye ezomqalethu nje sahlukana nezinkinga. Konke besike sayenza kodwa ibidibene nezinto. Nansi man. Plus and minus 2, you can see phayana ziyabulalana vele. We can use those points. Bese nimangele bake kwathini. Or we know that x is going to be, now if you think of the graph, concave up, it has to be greater than the x value at the point of inflection, whatever that is. So we can say x here is going to be equal to, not equal to, but greater than x1 plus x2, where x1 and x2 are x values of the turning points. Please be explicit. So x is greater than, oopsie, over 2. So we can see there that x ends up greater than x1 is minus 2, plus the second one is positive 2, divided by 0. Therefore, x must be greater than 0. So no matter how you look at it, you get it done, guys. Easy 3 marks. Knowing the derivative, that must be like that, 3 marks, or this and that, and then we can say, okay, fine, knowing what to do explicitly, so why not? Yeah, but even if you just didn't show the formula, you would still get 3 marks. 2 marks for the final answer, 1 mark for the method. As a methodology. Hi guys, igqibile i-differential calculus. Ne? Finished and clear. Now the last question, which is a special question. I wished we could do more, but let's do the Limpopo one. Sivale. Now I want you to cry if you want, but yeah. The Limpopo question, because we couldn't answer this beforehand. Now we're given that the function is in the generic form. Okay, we don't know anything. We just know this is the standard cubic. With the following properties. Now, sometimes these questions are typically higher grade. Most likely NBT, you will find such questions. So think about these types more, because the rest is easy as I have shown you. But this one, not so easy. Right, let's interpret this quickly and sort this out without any. I may want to avoid the other questions, but let me try and see if I cannot finish them. F of minus 2 is the same as f of 1, which is equal to 0. So what are these? X-intercepts. So we've got minus 2 and 0. Then we've got 1 and 0. Can you see? You're given x-intercepts in notation form. I showed you, if you look at that video, where I spoke about a headway to functions. Yeah, if you watch everything I show you guys, you will stand to be very proud and thankful. But if you just ignore because it's not popular, it has 5 views, and you pass it by, you will see it when you have messed up big time, and you will kill yourself for doing that. But you're not gonna die, of course. Right, f prime of 1 is equal to f prime of minus 1, which is equal to 0. Now what are these? These are the x values of TPs. Okay, so the x value is 1, the y value we don't know, the other x value is minus 1, the y value we don't know. But look at what happened. There's a repeating root because one of the roots is also a turning point. So this means this graph turns at that x-intercept. So these are the patterns you need to look out for. Further information, f of minus 1 is 4. Can you see? F of minus 1 is 4. So this means this is the value. By the way, what was the x? We were told f of 1 is 0. So this is exactly a repeating root. So now we've got full coordinates of the turning point. Right. F of 0 is 2. What is this? This is the y-intercept. This is 0 and 2. Now we're also told further that f prime of x is less than 0. 4x is like this. So now what happens? We know that the first derivative is negative between the two turning points. Why do I know? Because we know that the x-coordinates of the turning points were like that. So these are the ones that we see here. So which graph has this kind of a parameter? Is the graph like this? Opposite. It's a graph like this. So this gives us the shape. Because we know that between these two turning points, a tangent line has a negative gradient. Oh, you see? Basic knowledge, guys, will take you far. First question, once the sketch drawn, without any other stuffs, you know. 1.1, we can put it on the Cartesian plane and play with it. Right. My students are going to kill me, guys. It's almost that time, and can you see? But I think if we can get through this question nicely, the others are going to be a walk in a park. Now, what does this graph look like? We said it turns at one of the x-intercepts, right? And it turns on the second one. And we know what the shape is. So this is a graph like this. I don't know if it turns beforehand. And it turns there. I don't like it. Okay, that's what it looks like. Hayibo, don't ndinafuna so sandiphaphela wena. Sokundiqhela tyhini. This is f. We saw that this is 1. We saw that this is minus 2. Ne. Yamos. Then at minus 1, we saw the turning point. And then the other one is at 1. And the y-intercept, we were told, is 2. Over there. The other turning point has a value of 4. It's a sketch, guys, and it's perfect. We showed everything. So you get a mark for the shape, get a mark for the turning points, get a mark for the intercepts, get a mark for overall. Axis must be labeled We need to see where the origin is and the y-intercept, if you will. Right, so that is what we do there, guys. Nice and easy. So 1.2 says, now determine the equation of f in that form. Now, this question highlights yet another important factor, the root form, because we've got both the roots and there's a repeating root. So we know that f of x is a into x minus the first root into x minus the second root, but it's repeated because once this is also a turning point, the second bracket must be squared. It's a perfect quadratic. Right, so what are we going to do? We're going to take a point on the graph. Any, can use one of these turning points, but I'm going to choose the y-intercept. So now, with this one, 0 and 2, what are we cooking? We've got 2 is equal to a into 0 minus 2, this is going to be plus 2. In fact, I should have written here. Yeah, this is better. So this is going to be x minus 1 all squared, in fact 0. So what do we see, guys? I'm not going to waste time, so I'm going to conclude a is, this is 2 times 1, that's 2. So a is 1. So then f of x is just this bracket. We don't write 1. So this is x plus 2 into x minus 1 all squared. This implies that our f is going to be x plus 2, x squared minus 2x plus 1. Therefore, f is x cubed, right? Now let's deal with the x squared. So we already have 2x squared minus 2x squared goes away, nothing. Okay, remember this is going to be minus 2x squared plus 2x squared, 0. Then the x term is going to be x minus 4x. So this gives us minus 3x. And then this is 2 times 1. This is plus 2. So do you see again what is happening here? The bx squared term was missing. And what happened? One of the roots became a turning point. So you can see there's some consistency to this. So we were not lying when we said if this appears, then we are getting somewhere. All right, guys, let's get our marks nice and easy. This format, substituting the point, a value, and the equation. 4 marks. Penny mark. Where is the other mark? I think for the fact that we were supposed to square this, it makes sense. Okay, so let's do 1.3. 1.3 says, if g of x is equal to f of x minus 3, write down the x-intercept of g. Okay, the x-intercept of g. So what did we do? We just shifted this graph horizontally to the right by 3 units. So this means for every x-intercept, we just take an x-intercept, we just add 3. And then this is the transformation that we need to perform for all the intercepts. So we can say here, we know that one x-intercept is going to be minus 2 plus 3 is going to give us, maybe let me show you the thought process. It's minus 2 plus 3 and 0. Remember, horizontally, the y value doesn't change. The second one, is going to be 1 plus 3 and 0. We can say, therefore, these points are going to be 1 and 0. This is going to be 4 and 0. Now this is the thought process. You don't have to show it. But if you show it, it better be correct, because the first thing you write is going to be marked, especially if it does not agree with your answer. So that's the story, guys. But if the first thing that you wrote agrees with your answer, then we can consider your final mark. So I'm also telling you how to behave in the exam. Hi guys. Oyifumana phi teaching enje. This is what we call comprehensive teaching. Yekeni lento. Ninikezwe yonke. Now last question says, determine the values of p for which x squared minus 3x plus 2, can you see someone is confirming the equation, is equal to p will have exactly 1 root. Now this is our original equation. So for which values of p? Now remember, p is a horizontal line, so we've got line y is equal to p. So if we draw these horizontal lines here, then remember we need to copy and paste, not copy and paste, but we need to consider different positions. We can consider that where the turning points end up showing, we can consider this part in between. So can you see, once you know what to do, this is not so bad. That turning point, I'm just panicking because my class is supposed to start. So above that turning point. So now which lines are answering the question? When we say this must have 1 root, it means this one. This one passes the test because we want 1 root. So that's good. 1 root, that's good. So what are the limiting points? Is the x-axis is the line y equal to 0, and that turning point, the line y, is equal to 4. So those are the critical values for this business. So we can see nothing in between, nothing at those values, but everything outside. So what do we say? We can just say p must be less than 0, or p must be greater than 4. Igqitywe bantakwethu. Last 2 marks, and we smile, knowing that we did everything, guys, we could for the basic concepts in differential calculus. Unfortunately, optimization would have been an overkill here. So I'm going to do a video, a part 2 for optimization only. All right, guys, so this is it for today. Of course, you will find this document in the description of this video together with this memo, so that you can remind yourself in case you forget things. Otherwise, folks, I'm not going to prolong this. My class is supposed to start. So goodbye until next time. Keep well.